running technical conferences over the internet over the last about year and a half or so, but this is the first one that's actually ours. We hosted a lot of stuff for the Foundation for the Future, some stuff for International Space Universities, the chief scientists of U.S. Space Force and MarsCoin and the Moon Society and a couple other things. And it's been really fun, but we decided to make some changes for ourselves to do this as a Liftport project. And that change, I think, is pretty darn important. It's important to our company, but it's also important kind of as a shift in the kinds of things that we're going to be talking about. So the day is going to look kind of like this. You can find the schedule on the internet. I'll post it in the chat here. So feel free to follow along. What we're going to be talking about over the next 2 days is something huge, huge. I'm really excited about this. And it's not just for the next 2 days, it's also for the next year. We're going to spend the next year focusing on what does it take to get 15,000 people on orbit. 15,000. There's 6 up in the sky right now, 6. A couple months ago, we had 11. That was a big deal because we had a private space station, well, a private spacecraft orbiting that had 4, and then a couple more in the Chinese Heavenly Palace, and then a few more at the International Space Station. But that's it. That's the limit of humanity's very best efforts right now. 11 people. So if we're going to go to space for real as humanity, as we move away from, as Konstantin Tsiolkovsky calls, the cradle of humanity, how do we do that? And so we decided that we were gonna try for something just ridiculously ambitious, and that was on purpose. That was on purpose. I'll talk a little bit more about my background and who I am and what I've been doing in the space community. I'll do that later this afternoon. I don't want to spend a lot of time on that right now. But I really like big ideas in space. I really like the imaginative, the astounding. My bookshelf is just full of old science fiction, technical manuals. That was my inspiration, that we could build, humanity could build an amazing potential future. And it's one of the reasons why we copied the idea of Starfleet in our name. Now, we took some heat, there was a little bit of controversy around that name, but I stand by it in the sense of Starfleet was an aspirational goal from Star Trek, and I think, why not start that? Why not begin that? I don't know exactly if we know how to begin Starfleet, but I think aspirational goals are worth the effort. So what we want to do with this Better Futures Starfleet Enterprise program for the next year is to imagine what it takes to build a 15,000 person space station. And some of the pushback that we got from this was it's unrealistic. It's too expensive. We don't have the technology. And I acknowledge all of those things. It is really expensive. We may or may not have the technology to jump from 11 people to 15,000 people. That's a boggling leap. But But if we attempt it, even if we miss, it's still amazing. But if we attempt it and succeed, it transforms human civilization. It moves humanity from our single cradle of life to the moon, to Mars. I think it sets up the potential to move to other stars. I think this might be the first real step for humanity. Acknowledging Armstrong and Aldrin and the first and second steps on the moon. It's been 60 years and it's time to do something else. It's time to go back to the moon. It's time to go on to Mars. And in order to do that, as a collective species, we have to work together. And I think that the first step is a giant space station. Now, I'm not here to set up architectures right now. I don't know whether it's going to be one big station or 150 stations that are 100 people each. We're going to talk about requirements later in the day, architectures, feasibilities, and trades. We're going to talk about that later in the day. As we go forward, today we're going to be tackling on-orbit manufacturing. How do you build stuff on a station? And tomorrow we're going to focus on something that I think is fascinating. It's actually very brand new to me. It's the idea of, if we're going to have 15,000 people in space, we're also going to have, wait for it, sex and babies in space. And that's a topic that nobody ever talks about. But if we're going to build a town on orbit, we're going to have kids. So what does that look like? I have described it as the holy grail problem space, that if we can figure out how to have children on orbit, then that's perhaps the last critical obstacle for humanity. Everything else will kind of take care of itself after that. So that's where we're going. That's what we're doing. Today and tomorrow should be a really exciting. For future planning, we're going to do this every month, the first Friday and Saturday pair of each month. Next month, in March, we're going to talk about all the potential space stations. We're tracking 11 space stations. There's 2 currently orbiting. There are several, I think 6, that have at least $50 million. Some of them have hundreds of millions of dollars, and 2 of them have billions of dollars backing them. So next month, we're going to talk about current, planned, and proposed aspirational space stations. So what is the field of this look like? The month after that, April, we're going to get into the fact versus the fiction of being on orbit. So we're going to bring in some authors who have imagined the future, and we're going to try and bring in some engineers and possibly some astronauts who have actually been up there. And we're going to talk about what is the same and what is different. And then the 4th month into this series, we're going to spend the full 2 days working on systems of systems, integration. What are the requirements, architecture, feasibility, and trades necessary to put 15,000 people on orbit? So that's what our program looks like. We're going to try and keep it interesting. We're going to bring in terrific world-class guests and speakers. We're going to host workshops where we start getting into the nitty-gritty of doing the work. And very importantly, we want y'all to be a part of this in an ongoing fashion. So our attendees are invited to join our Discord channel so that we can keep what we refer to as the other 28 days going, so that we can keep people interested, excited. and build on momentum. So we know this is a start. This is a starting point. My internal team have referred to this as the training wheels event, where we're off to a clumsy, bumpy, cluttery first step wheels event, where we're, every toddler falls a couple times before they figure it out. Bumpy, by the end of the year, we hope that we're sprinting onto a new amazing path. So with that, the program looks kind of like this. I'm going to talk about the grand architecture, the kind of future that I see for the next until 2035. We're going to spend about 2 hours talking about policy, because that is really darn important. And then the afternoon, we're going to talk about manufacturing and building things on orbit. And then finally, we're going to end today with workshops and trying to understand the hardware and the business of going to space. Okay, so with that, I'm going to shift gears here for a second. Let me pull up my screen. Just pause a moment. Just one moment longer. I'm having minor technical, there we go. Okay, let me do a screen share here. Okay, this is us. We're Liftport Group. We'll go into that in a lot more detail later. Oh, sorry, let me expand this. I can't see mine. Okay, is that clear to everybody? Full screen? Okay, thank you. So here's where we're going. Our personal task is to go to the moon. That's not everybody's goal, but that's definitely Liftport's goal. And so what does it mean to kind of build out a grand architecture? We have this goal of what is the next 25, sorry, the next almost 15 years to 2035. What does that look like? And a little over a year and a half ago, the National Space Council put forward an idea that the Biden administration is committed to talk about where we're going as the United States. Now, I know that this is a global conference, and I know that that's not the same for everybody, but this, I think, encapsulates, the United States policies, and that influences the policies of other national efforts. The things that they're focused on is commercializing low Earth orbit, getting back to the moon, extending humanity onto Mars, doing real science, and kudos to all the people that finally launched this James Webb Space Telescope a couple weeks ago, because that's going to be amazing science. And then, building out the team, the knowledge base of people necessary to build this stuff. I'm very interested in the commercialization of LEO, because that's up front and present right now. We have a lot happening there. We're going to talk about that in a moment, but that's the thing that's really kind of galvanizing the human species to go to space, because in a very short amount of time, in less than 10 years, Well, let me give you a different example. When I started in space 20 years ago, there were 400 satellites, and a big chunk of them were dead, orbital debris. There's north of 4,000 functioning satellites. I think the catalog for dead satellites is north of 1,500. That's a 10 times increase in 20 years. But here's the thing. We're about to go from 4,000 to 40,000, another 10 times increase in less than 10 years. And there's very strong indications that we're going to hit 80 to 100,000 satellites in the sky in the next 10-ish, 15-ish years. And that's because of miniaturization and launch costs that have just dropped off a cliff. And it's opening up some really big, interesting, powerful business models. Economies of scale are really playing into this. So that's happening. And that's allowing us to kind of move into this, this idea of going back to the moon, but this time to stay. It's not just a camping trip where it's not like going to the beach for the afternoon and then coming home. This is going to be setting up settlements and eventual outposts. The United States is doing a lot in this. The amount of activity going to the moon is unparalleled. We're doing more now than we ever did during the heyday of the Apollo program. And that has definitely caught the attention of our global allies. And it has caught the attention of China and Russia as well. They have recently announced plans to scale up their lunar development and speed up the timeline. So those things are happening right now. I mean, you can feel it change every day. These two guys I really admired, Lieutenant General Quast and the Chief Scientist of U.S. Space Force. And I think they represent wild cards that have not really been factored into most of the developments in LEO. Now, I don't think either of these folks are advocating going to the moon anytime soon. That's not on their agenda. But I think that they have, when you consider the budgets that U.S. Space Force has and their role in government, I think that is a wild card that has not been factored into the commercialization sector yet. So I think that's going to be interesting to watch it evolve, and it's evolving very, very, very quickly. One of the guests, and we've had both of these folks on guests in our past conferences, and I hope to have them on our show later. But another guest that this is very recent news in the last few days, Colonel Felt is being reassigned from Air Force Research Lab out to Washington, D.C., to the Pentagon to help head some of the new space acquisitions programs. And I think that is a really significant shift. So we're going to see this evolving very, very quickly. And I want to stress that while I'm talking about the United States, this is happening at different levels in different governments all around the world. I'm going to bring up a different chart tomorrow that talks about what launch looks like in the world, and it is really significant. There's some important points about this. So what are we talking about? We're talking about the 4 pillars of infrastructure development. This is how I break everything down to help me put it in a bucket that my brain can operate with. Hardware, business, outreach, and framework. At the end of the day, things that go to space are things. Yes, we interact with it digitally, so data is vitally important, but at the end of the day, it's things that go to space. So what is the hardware look like? How do we develop it? How do we expand it? How do we test it? And ultimately, how do we deploy it? Business. I mean, whether you're, the former Soviet Union or, any other nation or company, one way or the other, you have to pay for it somehow. You have to pay for this grand adventure that we're on. So how does that happen? What are the finances of it? What are the operations, the logistics? If we're going to have 15,000 people going to orbit, how do you get them enough Cheerios and Oreos to survive up there, right? Logistics is a really complicated problem that has not really been addressed. Outreach is storytelling. It's building out community. It's the reason that we're doing this kind of event in the first place. It's to get engagement, and that's engagement in lots of different ways. It's STEAM, it's science, technology, engineering, arts, and math. It's reporters. It's building out a Discord channel for the other 28 days. If you neglect telling your story, then other people will tell it for you, and that may not be the narrative that you want. Finally, framework, and this is what we're going to spend a lot of time on today. We're going to spend a lot of time on hardware and framework. Framework is policy, it's laws, it's governance. We just a moment ago talked about how Space Force might be an interesting wild card. It is the rule set that you have to operate in. And oh my goodness, are there rules about going to space? There's rules about launch, there's rules about communications, there's offsets for your satellite can't come too close to my satellite, and we don't want a conjunction event. All of those things factor in. That's framework. We also break it into a couple different parts, like who are the actors in this field? We've got academic, civil, defense, and commercial. In most cases, most people fall into one of those buckets. So then what does the architecture look like? What does this grand architecture look like? What are the parts of it? I think we have a really good handle on launch, communications, and Earth observation. We're really good at that. We launched more than 60 times. As a global species, we launched about 60 times, 50 times in the last quarter. Think of that, 90 days, 50 launches, a launch every other day, basically. We're really, really good at launch, communications, and Earth observation. So I'm going to consider that a checkbox. Then the next part is in-space transport. And that is a developing technology. There are at least 3 space tug type technologies. Maybe there's 5. There's indications that China recently has been moving some stuff around. So maybe there's 4 or 5 space tug operations. What is that? It's moving things from where they are to where they need to be. It is a tugboat for space assets. That has been on the drawing board for more than 30 years, but it's only been in existence for a couple months. I mean, it feels like anyway. Maybe it's a year. I think the lunar elevator certainly factors into that. We're going to talk about that a lot more later. And then this is the whole reason that we're in this event series. Stations. There's a lot happening. I think it's the next important, necessary milestone in how we move out into space. And frankly, I think it is a milestone in humanity's evolution. What does it take to have a lot of people on orbit? And you got to know that 15,000 is an arbitrary number. We could have made 50,000. We could have said 5,000. But I wanted it to be big enough that it represented a small town. So my town in Washington State that I grew up in, not the town I live in now, is 15,000 people. And I'm like, you know what? Let's go with that. There are other reasons for that number, but let's pick a number that is possible, that is a lever to other developments, and it's aspirational. I think eventually we're going to have mining and manufacturing, mining on orbit. We're going to talk about what mining on orbit sounds like earlier today. I know that probably sets off some question marks and maybe some red flags, but trust me, there is going to be mining on orbit, and then mining assets from the lunar surface is the next step. I think the idea of mining asteroids is probably a lot further away, but I've been wrong on a couple things before in my life, so I'm not ruling it out. So I think there's three kinds of mining: orbital, lunar, and asteroidal. And then what do we do about manufacturing? And I think manufacturing is going to go hand in hand with space stations. I think those go by together. And then finally, ultimately, I think we're going to have space-based solar power, whether it is launched from the ground of Earth. I'm a little skeptical. I'm more convinced that it's going to be pulling resources from the lunar surface to build the solar panels for the sky. So that's what I think our 2035 looks like. There's a lot of parts to it. The locations are certainly important. And this is us. This is home, right? We refer to this as the Cislunar econosphere. Ken Murphy from International Space University coined that phrase, I don't know, 10 years ago, 15 years ago. And I think we're finally coming to see it into fruition. So we'll see how that goes. This is the station that we hope to ultimately build at the Lagrange point. We'll talk more about that tomorrow. And with that, I'm gonna close off this section. Give me a second. Okay. So I'd be happy to answer any questions about whether, what we're doing as this conference series, where we're going for the next 12 years. We break this stuff down into 20, where are we now, from where we are now to 2025. From that gives us a baseline. We're going to collect information about where we are now, and then we're going to use that baseline of what we have now, the assets that exist and the assets that are being constructed between now and 2025. We're going to use that information to try to understand clearly what 25 to 30 looks like. And then things get pretty murky after that. So what does 2030 to 2035 look like? But I think we've got some pretty good analysis about how this grand architecture is going to unfold. And they're based on as much information as we currently have. I'm not going to say that this is accurate. Part of the point of this series in the first place is to get a better, more clear crystal ball. Our series for the next year is we're going to host these events, the Starfleet Enterprise events. We're going to host them every single month. But we're also going to host 3 other conferences, workshops. One is focused on the future, 2035, and it's going to be how I just described. Now to 2025, 25 to 30, 30 to 35. We're going to host that. We're going to host one on money and finance and capital of space. This stuff is expensive, and there are new mechanisms coming online regularly on how to pay for this stuff. And that's important, right? The financial tools have to evolve as our technology evolves. Spreading risk, de-risking projects is super important. Surprisingly, the stock market does that very well. I said a moment ago, I've been wrong before. A couple of years ago, when Virgin Galactic announced that they were going to have a special purpose acquisitions company, a SPAC, I was very skeptical, and I went on record being skeptical of that. Nearly 20 SPACs later, maybe 25 SPACs later in the space sector, clearly I was wrong. The market has accepted that as a new financial tool, and that is a powerful model. So I'm curious to see what happens next. So we're going to host an event on the money and finance and capital of space. And finally, we're going to host an event on lunar development, but with an emphasis of settlers and settlement. Again, hardware just enables people. So that's what we're aiming for. So how do we get people up there? So every month, space station's topic. Then we're also going to sprinkle it in with lunar development, the future, and money. So that's kind of where we're going. I've got one question in the chat. How many space stations now? How many planned? So there's two. There's two currently. International Space Station typically hosts 6 people-ish, plus or minus a couple. It has held, I think, as many as 10 or 11. It was super cramped there. Maybe it was 13. That only lasted for a few days. It doesn't have the resources to handle that many for long. And then the Chinese Heavenly Palace is currently unmanned, I believe, uncrewed right now. They swap crews in and out, and it hosts 3 people, I believe. So those are the only 2 that exist right now. There are many being designed. NASA has its Gateway program for development of lunar assets. I hate to say this about my friends at NASA, but I'm somewhat skeptical of their architecture, but that's not my job, so I'm going to let the pros do that. And then China has some expansion plans, and that's a topic that Pierre Garretson and Dr. Goswami are going to talk about here in just a few minutes. And then you've got Orbital Reef, that's backed by Blue Origin, Northrop Grumman, Starlab, which is a combination of Nanoracks and Lockheed Martin, and then Axiom. So those 4 are multi-hundred million, multi-billion dollar funded organizations. So I can't count those folks out, right? That's a pretty safe bet. So something like that is going to happen. And then there are several more that are what I term aspirational. China has been talking about a 1 kilometer sized structure. I'm pretty surprised by that, but that's, as far as I know, that's just a paper, a research paper. I don't know if that's actually got weight behind it. And then there are other aspirational groups that want to build stations. There's one that has just $2 million. Now, $2 million certainly doesn't build a space station, but it might get you some blueprints for a station. So there are probably 5 that are what I consider aspirational And there's probably 4 that I consider planning, and then 2 operational. So that I count that as 11. Okay, we are going to swap over and bring up Peter Garretson. He does not seem to be on the screen. Nami, are you and Pete swapping? Oh, you are there. Okay, great. I did not see
I'm here.
Hey. Good morning. Ow, I just flinched. I broke my arm. I broke my arm in 2 places a couple weeks ago, and I didn't want to wear my sling and my cast because I wanted to wear a suit. So as soon as I just you know me, I reflexively do a peace sign as to people and say hi, and I just did that with my left hand, and as soon as I did, I flinched. So sorry about that.
I'm so sorry for you.
I'm good. It's fine. Pete, I'm so happy to have you here, sir. I'm a little flustered in that I don't have your bio in front of me, so I do somewhere, but I can't seem to get it right now. So would you mind introducing yourself for a moment? I usually am a little bit better prepared than that, but I can't seem to find the screen that has your bio on it.
Not at all.
Okay.
So I'm a retired Air Force officer, and in the Air Force, I did a lot of strategy related to space, and I've gotten out, and now I'm a senior fellow in defense studies at a think tank in DC called American Foreign Policy Council, where I think about a bullish future for space.
Terrific. That is a somewhat modest bio. You're welcome to expand on that if you like. I won't press you on it. All right, pass. Okay. So I want you to kind of jump into this conversation about, this is pretty aspirational what we're aiming for, right? 15,000 person space station, whether it's one station or lots of stations. What does that mean? Like, how realistic is this? How hard is this? What does it take to make this happen? And on a scale of 1 to 10, how credible is this idea?
Well, let's try to take those in order. So let's understand, what scientists or engineers would call order of magnitude. So, today, we host on the order of 6 people on the International Space Station, and it's about 400 metric tons-ish. It's about the size across of a football field, and that's the largest object we've ever made. It's in low Earth orbit. But to go to something where you've got 15,000 people continuously occupying it, perhaps even settling it, perhaps having children on it, you've really gone to an entirely different scale, and in power too. So you've got about 100 kilowatts on the International Space Station. So you would have to scale up, pretty proportionally by those standards to get to that size. And one of the major things that I think would be hardest about this would be the creation of a closed life support system, which is you're basically living in a bubble, with other threats to you. So there are all kinds of security concerns and redundancies. But to do that, you would have truly changed the game in terms of being able to get mass from where you want it to your construction location, and that's a big deal. So did you showcase already, Michael, what such a station would look like? Did you provide a vision?
I wanted to leave that to other folks. So if you want to bring some screens up, you're welcome to. I was, this is the first event and you're the first speakers. So this is our starting point.
So yeah, I have a terrific graphic somewhere that showcases the difference in size between the smallest space colonies up to the largest, and I wasn't able to find that this morning, but I do want to kind of let's go really big and talk about like how big have people thought about space colonies. And so behind me, you can see, one image of what's called an O'Neill cylinder. And these are basically the largest. I'll throw up a few screenshots of what these look like, but they are vast rotating enterprises in pairs that you can see through the window down, onto the landed section. And each of these landed sections that you see behind me are meant to be about the size of Manhattan Island and to accommodate millions of people, not just thousands. And typically they're constructed out of lunar materials and would be housed initially in the Earth Moon L5 point, which is stable and doesn't require fuel to get there. And these were designed in the 1970s by Gerald K. O'Neill and his students at Princeton, using basically shipbuilding technologies that was available at the time. And of course, this is the largest that I'm aware of that anyone has seriously considered. And smaller than that are the Bernal Sphere and the Stanford Torus, which is the small. Oh, I wouldn't say the smallest. It's smaller. And then you've got even smaller ones like Kalpana 1 that I think are on the order of 8,000 people or so, but they're all sort of enclosed planned communities, not unlike this. And they require, in order to do them, an in-space manufacturing capabilities, and not unlike this, and they be able to provide the materials, which might be an in-space manufacturing capabilities, silicon, and not unlike this mainly, and they provide the ability to an in-space manufacturing long-term internal biosphere, which so far we've had very limited success. So we had a single experiment, Biosphere 2, on Earth. And within space, we are able to keep alive continuously the astronauts on the ISS, but it is not what we call closed cycle. So we're constantly having to add energy and material, to the ISS in order for it to persist. So on a scale of difficulty to do, I mean, this would be the equivalent of the Egyptians building a pyramid, for our generation. That said, though, it appears as if, all the basics that it would take to build these massive structures, that we know the basic physics behind it, but the scale and financing, the business models behind it, and certainly the fine tuning of, creating a closed ecology, are things that we would have to get serious about moving forward on.
I love that part, right? So what you're saying is maybe, right? We have the tech can probably scale. Do we have the will? Do we have the finances? Is there a reason to do it? Okay, I mean that, I'm not sure that there was a reason beyond the pharaoh's self-interest to create the pyramids. I think there was a religious component to that, if I remember my history correct. But is that a reason to build these superstructures in the sky? I don't know. I don't know if we've crossed over the threshold to make it worthwhile. Like, so what are our success metrics for building something like this? I don't think anybody's proposing an O'Neill cylinder right now. Not that I'm aware of. I was inspired as a kid by the Ringworld series, which I think would be pretty amazing, a world that encompasses a sun. but I think that we are in an era where we're going to start building a lot of stations, and I think they're going to be different kinds of stations. I think people are going to test different systems. Um, uh, I don't. My hunch is that we're not just going to go from 11 people on 2 stations to one giant 15,000 station, right? That doesn't, that is a leap that's probably too far.
No, I think you'll see I mean, first of all, why will it happen? I think it'll happen, basically because it's inevitable that, what life does is expand. It expands its habitat, and human beings are a migratory species. To quote Teresa Hitchens on my podcast. And so I think that, that we'll do it, principally because we want to, but we'll do it when it's within our capabilities. And I think our capabilities are going to steadily increase in this direction. And let me sort of paint you, how I think it's going to go.
Please.
So, the chief competitor on the global system, the People's Republic of China, has a very well-developed idea about how they want to, occupy and industrialize the moon. And they would build an extractive industry base there. They would build a transportation base. And then their initial target is to build these solar power satellites. Now, solar power satellites are gargantuan compared to the International Space Station. They are not kilowatts, not megawatts, but they are measured in the gigawatts of power. They are not a football field size across. They are like 7 kilometers across. So they are truly a kilometer scale structure. And if you're going to build them at scale, it really makes sense to do it from lunar or asteroidal materials where you're not having to fight the Earth's gravity well. So, it's 22 times less energy to get to escape velocity from the moon as it is from Earth. So getting material off the moon is simpler in terms of energy. It's simpler in terms of you don't have to worry about the vibration of the atmosphere. So there are numerous reasons why logistically the moon is a force multiplier. And I think that eventually the United States will figure this out too, that we'll realize that just getting people to the moon for propaganda value, or for feeling good value is insufficient, and that, the real game is about economics. And we've certainly taken some important steps toward that in the 2015 law that codifies Americans' rights to use space resources. But once you have an industrial base that can build kilometer scale structures, and once you have an industrial base that is able to extract the materials from the moon, it's actually a fairly minor step to scale up to larger and larger pressurized volumes. And I would point anyone who is interested in sort of seeing the stepwise to read John Strickland's book on developing space, where he shows, I think, a very credible way of how you start to build an O'Neill cylinder, a Stanford torus, which is significantly larger than the 16,000 space colony that we're talking about today, I think. But nevertheless, appears to be possible. And then, where could this go? Well, it turns out that, if folks who have, attempted to look at this problem, basically calculated that, within the places that you would optimally want to put these close to Earth, meaning not in a long-term and low orbit, but up in the L4 and L5 points, the circumference of those orbits are large, like, almost, certainly larger than geostationary orbit. And even if you have like 100-mile spacing, that's room for about 5,000 colonies. And if you're building things like this, that's 20 million each. So you're talking about 100 billion people, far larger than the Earth. You might ask, okay, well, that's an incredible. It's so many more than is on Earth. Could you possibly get the materials you need? Well, surprisingly, each of these is about 20 billion tons, but the moon is so much bigger than that. But even if you were to build 5,000 of them, right, that's a millionth of the moon, right? Because it's you don't have all that wasted space of Earth underneath you. You're just spinning inside a shell. So when people talk about the moon as the eighth continent, it's really more like the next 100 continents in terms of size, or in terms of where it allows you to scale. And real estate has always been kind of an important market, and the ability, if we solve the life support problems, then it basically provides unlimited room for human, or at least in terms of what we think today, unlimited. So you'll hear Jeff Bezos talk about a trillion human beings in the solar system, with 1,000 Mozarts and 1,000 Einsteins living simultaneously. And Dr. John Lewis has kind of gone through this and calculated what is the carrying capacity of the inner solar system using just the asteroids, and it's quite a few trillion human beings. And it turns out that we're actually mostly limited by phosphorus. That is the one element that limits the size of the human population in the inner solar system.
I never heard that one before. Why?
So life needs phosphorus, and it's essential, and it's just rare. At least it's rare in terms of what we've found so far.
That's showing my lack of biomedical knowledge. Tomorrow is going to be kind of embarrassing to me because we're going to be talking about kids and babies, and I don't know anything about biology. So that's just going to be that's the first embarrassment of the day, of just simply not knowing a thing about this. I didn't know that was a cutoff. That's fascinating, actually.
There are some interesting things related to this, right? When you think about a closed cycle life support system, we're used to breathing nitrogen. Nitrogen is definitely one of the things that you can get plenty of oxygen on the moon, but nitrogen is in short supply. Carbon is not that abundant. You could probably get carbon, from an asteroid. We seem to have an excess of it at the moment in our atmosphere right now.
Right.
But there are elements that you'd have to bring up to fill this, to begin your farming. And, certainly, you'd have to, and you can't see it in this image, but the entire, let me see if I've got another image here. So this is sort of what it looks like, the two of them paired together, and this entire little ring that goes around in front. These are mirrors over here that are mirroring the sunlight in, but this is actually a 0G or low G farming facility, where folks would grow their own food and medicinal herbs and anything else that they would need there. And that's tremendously underexplored, how we would do that, how they would interact. But what we really don't know yet, we're assuming these rotate at a speed that, like on a carnival ride, creates this feeling of artificial gravity at typically at Earth normal gravity. And there are a lot of reasons why you would want to do that. But we think that the body can't tell the difference between rotational artificial gravity and actual gravity, but that could be very important to whether or not human babies can be born and develop normally. And so that's actually a big deal, to find out whether or not we can biologically reproduce in space. And I think, frankly, we in the United States and in the West generally probably aren't going to be the ones who figure that out, because I think we are very concerned with the ethics of that. And I think other societies are more concerned to find out that, in fact, we can do it.
Yeah, we're going to talk about that a lot. Tomorrow's kind of the first showcase of that. Definitely the ethics, the biotechnology research is still a long ways away. In our program series, in 2 months, I hope to have some folks talking specifically about centripetal acceleration and whether or not we can use spin simulated gravity, if that's going to work. So that's on the to-do list, but I didn't want to try to cover that in our program this month. Frankly, it's too much, but it's one of those things, right? So and Grant over at Paragon just got a $200 million contract to start working on environmental controls and life support system for a couple different projects. This is big stuff we're talking about. Like the technology is being developed not for a station as large as the one behind you. By the way, I in that set, there's one with I don't know, a deer, a stag, like in a park underneath that. That one, I kind of shied away from the deer on orbit meme. I felt like that was maybe a bridge a bit too far, but having there you go, there's a deer in orbit, right? That's the one. Yeah, I love that picture, but I feel like that kind of makes the whole idea whimsical and nonsensical, right? That's
I actually take the opposite, right? I mean, I think that what people don't realize that I think is beautiful about this idea, and I'll try to get a little philosophical here, is that
please.
When human beings go to take settlements abroad, we are not just taking ourselves, we are taking thousands of species of our biosphere. We're taking our gut biomes with their thousands or millions of species. We're taking all kinds of fungi and bacteria and plants. We are really moving, Earth life, to new places, to new venues. And, I think that enclosed capsules like this, really represent a new form of complex life. Just like in eukaryotic life, you incorporated, two different types of bacteria to become one, and then they learn to be colonies, and then those learn to be animals and grow an information system, right? This is going to be, spacefaring, life in entire, ecosystem moving abroad. Mm-hmm. And so, this, I think this gives humanity a kind of a potential for a very special kind of mission to be, essentially the gametes of Gaia, or to be, the life carriers, mm-hmm. Of at least Earth life to other places, as Rick Tomlinson says, to carry life, to places now dead.
Yes, exactly.
And so I think that's a very, exciting possibility that, rather than the image of, us, going and ruining every place we're going, we're Johnny Appleside, we're the gardener that's, bringing through. So I like the idea, that, when we go out into space, it's not just human beings in their spacesuits. It's human beings and as much diversity of life as possible.
I'm so glad that you said that, because later this afternoon, we're going to talk about requirements, architecture, feasibility, and trades. And I was having a conversation with my brother over the summer, and we were on vacation and we're wandering through the redwoods, and very arbitrarily, I'm like, we need a station that can support a grove of redwoods, just as a tribute to, like, that we have enough excess capacity, enough, environmental controls, we have enough just raw dirt that we should be able to sustain a living organism that can last 2,000, 3,000 years, right? We should
And,
just
and
have
that
that
might
as
be
a
a great
requirement.
place to start, right? It might be that, you could build a smaller, essentially a terrarium, right? I mean, imagine how incredibly inspirational it would be, to have not on this scale, but something that might look very much like this, a scaled down model at L5 with just a redwood forest, and a HD camera showing that, Earth life now exists at a point in space where we might want to go to. I think that would be, pretty phenomenal. Just on another thing, some of these things could actually happen on their own. I was, reading with great sadness that NASA plans to deorbit the International Space Station. If it were me, I would be releasing a grand challenge and tender to raise it and move it to L5, where one day it can be a museum for us. But you think about, they have problems now with bacteria that coats the interior walls, and they've got little plants, and it'd be interesting to see if you just left it alone, with a webcam on, what might grow over time.
Yeah. I think that would be great. I definitely have the same opinion about the International Space Station. It's a brilliant, beautiful machine. It's, I think, the most complex machine humanity has ever built. It is time to surpass it. But in the same way that the footprints on the moon are a cherished heritage site, I think the ISS deserves that place in history as well. We've got a question from the audience. Dr. Muzyka, he's going to be speaking later, actually, with you guys in just a few minutes. But he's asking, assuming the current course of advancement in automation, will we see more robotic space stations and factories than classical crewed stations?
Almost certainly, almost without a doubt, the majority of what we're going to see, I suspect, is going to be, robotic stations, but those are going to give way to something else. So, once you have, these are, courtesy of Anna Nesterova and John Strickland, but, here you can see an idea of how basic, fairly near-term robotic infrastructure, builds itself out, into a truss, starts attaching materials, then, builds a larger truss structure, builds, this large, jig, and then starts, moving around in, very much a robotic arms on tracks, like a roller coaster, you can see on the left. And then, slowly builds this large toroidal structure, that where you've got these little robots that are laying cables and, doing welding as they move on the tracks and just build around until eventually, you've got just beautiful images that these guys put together, till it wraps around on itself. And they've got a method of tooling, to eventually build yourself an enclosed, space like this. So yes, I think robots are going to lead the way, and certainly for industrial processes, and most of what we're going to see, I would guess over certainly the next 20, maybe 30 years, that's going to far surpass what is needed. I don't think that you put human beings in space necessarily because you need them. I think human beings are a migratory species, and they will decide that that's where they want to go.
Absolutely. I 100% agree. This is interesting. I've been very focused on space elevators, Earth elevator originally, and now lunar elevator. I have, for the most part, ignored space station technology development. I have not been paying attention because I didn't really see the crossover. It's only in the last year or two that I've really kind of had this epiphany that that's kind of the necessary next step, that my elevator will happen, but it's kind of further down the road. And so I've only just really recently become fascinated with the idea of stations and size and what their potential is. It doesn't displace my focus on the elevator, not at all. It enhances my focus on the elevator. But I'm really looking forward to just spending the next year digging deep into this topic that I've not really known that much about. And so this has been fascinating. Thank you for your insights and your vision for where we're going. I'm going to ask each guest where they think we're going to be in 3 years, 2025, 2030, and 2035. So how many people will live on orbit 3 years from now, 8 years from now, and 2035?
Well, my hope is that in 3 years from now, we will have doubled, maybe tripled. I'm hoping that, we'll have, 1 to 2 breakaway space stations that will be crewed.
Okay.
So I hope that, and I think India will be up in space as well. So, you'll have the ISS, China, you might have, Axiom and a couple others, and then you'll have India. So, I kind of think the upper boundary of what I think could happen in such a short time frame, would be, maybe quadruple the size, but I'd be more comfortable with a bet of, twice the number of people in space that we have today. So maybe 20.
Maybe 20 by what day? By what year?
Your first year was when? 2020.
Okay. 2025.
Yeah, 2025. If I were really bullish, I would say double.
Okay. And then 2030. I'm taking notes, by the way. Everybody's going to get quizzed on this afterwards.
2030, I could see it going one of two ways. We're either satisfied with the level of private space stations that we have, and it hasn't really budged. So you might still have 20 if we decide that we don't need that many. On the other hand, George Poland has, basically said that, if a private company figures out that they can do important biotech or do important material science, and that having people up there is cost effective and useful, then, it will become sort of a selling point, of a company like Pfizer, for instance, to have their own space station. And then, I could imagine that having built one, the ability to build more would be possible. So, you're talking about an extra 5 years to 2030, right?
Yep.
I would still guess that even if there were a lot in the pipeline, you would not have done more than double again. So, maybe you'd have 40.
Okay. And then aspirationally 2035. I know that that's a wild card. We don't really have that number, but make a guess.
Well, 2035, I think you'll be completely comfortable having built stations. I think, you will have had sort of this movement started by Musk and Bezos of becoming, multiplanetary, as well as the technology to have, orbital space hotels. So, I think it would be possible in that time frame to be thinking about 100 to 200 people, barring, now I would just say that there's also a potential wild card here that, if NASA succeeds in having long-term sustained presence starting in 2028, and if companies like Lunar Resources and Off-World, succeed in, building a lunar infrastructure, with significant amounts of material, somebody like a Jeff Bezos might arise that says, we're going to go and do the next super exciting thing that nobody else is doing. Or you could have seen at that same time period, China having really moved aggressively into kilometer scale structures and and space solar power satellites, and they might, for national prestige reasons, try to build something larger. I still wouldn't expect you would have your 15,000 people, but I could imagine that people are starting to experiment with that level of structure and design, for that purpose.
I'm going to go with that. That's amazing. I mean, we need to shift gears, but just think about that from perspective of, in the whole of humanity, we've only had slightly more than 600 people go to space. And you're saying we're going to have 200 on orbit at one time in just by 2035. I mean, that's astounding. That means the numbers of astronauts is, because they're going to cycle through, that's going to be thousands and thousands and thousands of astronauts in order to hit that 200 number. All right. Peter Garretson, so much fun to have you on our program. I'm so excited about how this next year is going to shape up. Going to definitely have you back on some other conversations. We're going to shift gears. Thank you so much, sir. Taylor, do you want to come on and introduce Namrata? And before you do, I'm going to introduce my team a little bit. So we've got Taylor Burns is our new to our team communications staff communications person. So helps tell our story. I said a moment ago about how important outreach was. And then in the background, under the tag of Better Futures, is Fabio Mendez. He's been with the team for 2 years. So I couldn't have done this. We couldn't have done this without these two amazing people. So thank you y'all for your help. Taylor, could you introduce Dr. Goswami, please?
Absolutely. Thank you so much, Peter, again, for your words, your images, your expertise that you shared. And we will be transitioning to Dr. Namrata Goswami on Asia and space, insights into China and India's space priorities. Namrata Goswami, PhD, is an independent scholar on space policy and great power politics. Recently, she has been invited to teach at the Thunderbird School of Global Management, Arizona State University, for their Executive Masters in Global Management space course. She is a consultant for Space Fund Intelligence. She was awarded the Minerva Grant by Office of the U.S. Secretary of Defense to study great power competition in outer space. Dr. Goswami testified before the U.S.-China Economic and Security Review Commission on China's space program. Dr. Goswami, the floor is yours.
Hi, good morning.
Hello, Michael. Good morning, and thank you, Peter. Thank you for that kind introduction. So I have a few slides that I would like to show. So let me just get them up here. Can you see my slides, Michael?
Yes, thank you.
Okay, great. So first of all, following Peter, since he ended by talking about the kilometer size ambitions that China might have in terms of building a space station. So I thought that's a great segue. So in the about 15 minutes, what I'm going to do is talk a bit about Asia and space and insight into China and India's space priorities. So I always like to show this particular graphic. This is an updated budget that was revealed by Euroconsult in their report for the 2021 budget for space activities. And what is so interesting is that despite the COVID-19 pandemic, the space sector actually saw an increase of about 8% increase in terms of spending. So from about 80 billion, it became about 92 billion. In 2021. The US, of course, as you see from this chart, dominates in terms of spending in space, both civil and military. And China has actually increased its space budget. So from about 8 billion, the open source documentation tells you that it's about 10 billion, which is interesting because that's an increase despite the COVID pandemic. And you can see that several other countries are also basically increasing their space budget. So what this means is that if you look at the drivers for space policy, you can see that space is determined today in terms of how countries are spending, how they are actually motivating their own private sector through the lens of nationalism and leadership. So there is nationalism behind space activities still. And so you can see that in the Chinese white paper that was released, which I'll speak about a bit later, and also in terms of India's investment in space. So there is a great thrust to develop India's commercial sector, including plans that are tentative but have been talked about by the Indian Space Research Organization's chief in terms of India's own space station. Now, the other driver for developing space stations and developing, for example, capability to go to the moon for resource utilization is the economic potential of space, which is extremely high in terms of, if you look at the calculation offered by some of the sources in China and India. Now, the third important driver, of course, is national security. So you would also want to have presence in low Earth orbit and beyond. And space stations can actually offer such kind of capability. One of the reasons why the Chinese invested in their own space station is because they wanted to gather experience, not just of experiments with regard to microgravity, but they also wanted to experiment in terms of how humans can sustain themselves in space, how they can grow food and other organisms. Another driver is, of course, foreign policy. So space brings about a lot of status and prestige. So the country that is seen as leading in terms of space capability, space rules and governance is seen as a country that is something to aspire to. And this particular driver plays a big role. And then alliance structures and vision. So if you look at, for example, China, Russia, the United States, India, there is a lot of stress on partnerships and developing space together. So India, Japan signed an agreement to invest on the moon. China, Russia, as you know, have invested in a document that talks about building a research station on the moon. And then the US, which has also partnered not just in the International Space Station, but also for developing lunar capability. And then vision. So vision really matters. So as Peter mentioned, you need to have a vision of how a space station or structures in space would be like. What kind of capability will it support? What is the end goal of particular development of space stations? So that itself builds into the space policy structure. So one of the interesting development that we are going to see this year is that China is going to complete the development of its Tiangong space station. So the Tiangong space station, the Tianhe module is already up in low Earth orbit. It's about 24 tons, and the entire Tiangong space station will be about 66 tons. So in comparison to the International Space Station, which is about 400 tons, it's a smaller station. But what is interesting is that it's going to accomplish some of the goals and vision that China set for itself. So there are three reasons why China is investing in its own space station. One, as I mentioned before, carry out experiments in space. And so there are about 1,000 Chinese experiments that are going to go up to the space station. As you know, China cannot collaborate with the US with the International Space Station because of agreement or the Wolf Amendment in Congress, which was passed in 2011. And so despite that, what China has done is that it's established its own space station, one for carrying out its own experiment. Second reason that they provide is that it's going to help them develop future capabilities. For example, how do human beings live in space? And finally, to develop a life-sustaining system. So it's very interesting. And then the other thing which they want to basically master is in-orbit docking, propellant. Also, if you look at the Tianhe module, they have two different ports that they use. So one, of course, for the cargo vessel. So this is another capability that China is investing in terms of its space station, which is that it has the Tianzhou cargo spacecraft that actually carries up cargo to the space station. And they want to do it in a very quick, efficient manner. So the idea that Chinese space policymakers and scientists that are within the space station program points out that in case there is an emergency, China should have the ability to launch immediately and reach its space station quickly. because that kind of capability is going to develop what they are going to do in the future, for example, on the moon. And then last year, the China Academy of Sciences supported a project that is looking at developing a kilometer-sized space station in low Earth orbit. So you can see that they are starting to have ambitions of developing larger structures in space. And so this particular space station is going to develop that capacity going forward. Now, just another graphical view. I thought the audience would be interested. These are all from open source documents. Some of them have been taken from the China Manned Space Agency website. And so you can see that they have given you a good graphical detail of what the two different labs that are going to connect to the space station Tianhe module are going to be launched this year. And so one is Wangtiang. And so they'll have a crew working compartment here. And so it's a very interesting depiction of their capability and development. And you can see that they have given you a detailed account of how their space station Tianhe is working. Recently, they also tested their robotic arm so that they can grab, for example, a debris coming to them, or they can use that for carrying out structural or other activities in space. So all this actually builds knowledge in terms of how do you function in space on your own. Okay, so one of the interesting developments that has happened in January of this year is that China has issued its white paper on space. So if you look at its white paper, it's very clear that the vision, which I mentioned before, is that it wants to explore the vast cosmos, develop the space industry. By the way, this is interesting. These are new concepts that are coming up. So before this, China talked a lot about state-funded space programs, especially through the China National Space Administration. But today they're actually talking more about how do you develop a commercial space industry supported by government subsidy and vision. And so the space industry is a critical element of their national strategy. So they're very clear that this is not something outside of national strategy. This is actually within national strategy. And then the other important point, which when I was going through the white paper, is that space is integral to overall development of China. And then the other important thing that they stress on is that if you look at China's space program, it's very critical to have an overall very clear vision and direction. So they are not comfortable with all different agencies working in their own visions and silos. What they want to do is to integrate all these platforms so that they can develop a comprehensive national space power. Now, another important thing, which by the first time has been used in a white paper, is that they are investing in reusable rockets. So till now, what we had in terms of some idea as to what is China focusing on came from newspaper reports and interviews that China's space policy scientists and rocket and engineers basically talked about. But today, we have a white paper, which is an official document that tells you that they are going to focus on reusable rockets and heavy lift rockets. And then they view space and the development of space, including their space station, through the Belt and Road Initiative, which means that they are viewing their space station as a part of diplomatic development of partnerships and subsidized funding of other countries' space ambitions as well. For the first time, they have pointed out that they are going to invest in a manned lunar landing. So this again will bring up interesting questions. So by 2036, Russia wants to establish a lunar research station, which is a permanent structure on the moon's south pole. And the white paper clearly tells you what are they going to do with regard to their lunar program from now to about 2035. And so this is going to become an interesting development when we are thinking about structures in space. And so they want to actually lay a foundation for exploring and developing cislunar space. Now, what is something new that has again come up in China's white paper is that for the first time, they are talking about planetary defense. So this is, I quote from the white paper. So study plans for building a near-Earth object defense system and increase the capacity of near-Earth object monitoring, cataloging, early warning, and response. So I thought this is very interesting that they're picking up concepts that are going to build their capacity, especially in space, not just from Earth. Now, before I open up the floor for questions, India is also a very interesting and mature space power. And so some of the drivers of India's space program, I recently published a paper with the French Institute of International Studies that look at these particular concepts. So nationalism plays a very critical role. But interestingly, entrepreneurship is becoming a key factor in India's space program as well. And national security and international and national development play a role. But again, if you look at this chart, you can see that India is also having plans to develop its own space station and do not want to collaborate with another country. India is not part of the International Space Station. And so the idea is to build a very small space station, which is about 20 tons. And the capacity for India, any Indian astronaut to stay or work on that space station is about 15 days. Now, this is much less than China, which now is capable of supporting about 6 astronauts to about 6 months of stay, and the ISS, which is much more. So, but then it's again the starting of ambition and capability of where they want to go with their concept of space station. And what is interesting is that India is also pushing to privatize and develop private space startups to build structures and support in orbit, manufacturing and propellant structures in space. So you can see that it's following a trajectory which the US is doing right now by signing agreements, for example, between NASA and Blue Origin, NanoRacks. India is also trying to develop that particular capacity. Now, I'll end by saying that, and this is something I always like to point out, that the future that we are talking about to 2035 is going to be a very interesting future in space, because unlike the Cold War, and I've mentioned this in my writings and presentations before, we had just 2 major powers, the US and the USSR, that invested in space capability and had actually very mature ability to go to the moon, for example, and land humans there. Today, you actually have several nations that have recognized this growing economic and national security implications of space. And I see a future where the country with the best space structure, be it the US, be it China, or be it India, will actually attract alliances and partnership, and by which you mean funding for their space activities and program. So this is the present that we are dealing with, and this is the future that we have to anticipate going forward. Michael, I'll end there and I'll look forward to questions. Thank you.
Leave that graphic up if you don't mind. I love that picture. I've never really seen it like that before. I don't know if you saw me, but my face lit up when I saw that, because with my background with International Space University, I'm aware of just how diverse the global space effort is. But to see it in a graphic like this, it kind of makes me feel pretty happy, right? Like as far as I'm concerned, this is the beginning of Starfleet. Like this is if these folks work together, we can build Starfleet. So I love this image. I have not ever seen that before. Thank you. Thanks for putting that together. Thanks. All right, cool. So you had a couple things in your talk that surprised me. I've been interested in what was happening in China for a while, but to have that paper where they talk about reusability as a priority, that industry is a priority, that's a big change. I wasn't expecting that. I did know that they've been kind of looking at reusability for a while now, so that didn't surprise me, but that is now policy is important. I think that's really significant. And I was not tracking that India was building a space station at all. So that one surprised me. Are they going to build that internally entirely, or are they going to, that's really nation building, industry capacity building for them, correct?
Yes.
Yeah.
So if you look at what the the chairman of the Indian Space Research Organization, in an interview about 2 years back, when he was asked this question about space station, he pointed out that this will be done internally. So India, so this is an interesting cultural definition of India's space program. And that is why Indian space program has tended to be slower than, for example, China's space program that collaborated in the beginning with the Soviet Union and then with Russia. So India focuses a lot on developing its own indigenous capacity. And so the space station follows that particular structure and culture. So the idea is that India will be developing its own space station. As you know, it's not a big space station, but it wants to develop that expertise. They have given a tentative date of 2030. So we'll see if they get there.
Okay. And I know you said there was only a few people only for a few days. Do you have any, do you want to take a stab at the same thing I just asked Pete about? Do you want to take a stab at a prediction for 2025, 2030, and 2035? And do they factor in if they're only short term? Does India factor in if it's only short term? So do you want to take a stab at that crystal ball, or do you want to gracefully pass?
No, I can take a stab, and you can always think about the future, and you might be wrong, but that's fine. So I think what I see a future in space is that, as Peter was mentioning, and as the discussion that you were having, that you will have a lot more space stations because there is demand for it. So I'll give you an example. So for example, when the only structure that scientists and academics are now able to carry out experiments, which they want to, is the International Space Station. So the moment China announced that it's going to have its own space station, there were thousands of applications to take part in China's space station for those who are not able to get into the International Space Station structure. So, for example, China received about 99 applications for academic and scientific experiments, and they were only able to select 9 because they have thousands of their own experiments that they could not carry out, for example, in the International Space Station. So given that, and that's the future that we are looking at, if you have commercial space stations, you would see that there will be a much more development of human capacity and understanding of how to live and work in space. And so by 2035, I would forecast that there would be the Chinese space station, there could be the Indian space station, there could be commercial space stations that are being developed in the US. And you could actually see commercial space station development coming out of China as well, because their own space sector seems to invest in innovation, capability, and wants to compete in this particular venture because they see it as profitable. So I would say there could be, my number might be more conservative. I would say that there could be about 10 or 12 space stations. And then I would think that one of the possible future that we need to think about is that China is already starting research on a kilometer-sized space station, much bigger than the International Space Station. And the trajectory of China is that if they announce something publicly, it slowly makes its way into their policy document. So they first start testing the surface.
And they have a history of when they say something, they do something basically on schedule, right? So that's really significant. I was going to ask you about that. What do you have? Do you have any confidence on? Is that a 50%? Like, so as I understand it from the outside, it's only a research paper right now, correct? Like, it's not a funded program. It's a few people doing some basic sketches. Is that correct, or is it more than that?
That is correct. So this started last year. So they have identified developing the capability for a big size space station as one of the research areas that they would look at. And there is funding for it because it is coming through China Academy of Sciences. So, which means that they will be building the knowledge, they will then slowly build the map for how they are going to get there. But they have not announced the date in which they would think of building such a structure. I think what they are doing now is that they are learning from how they are actually assembling Tianhe and Tiangong. And then the next big project for China is the Lunar Research Station, which they have announced. So, and publicly put it in their policy statement. Russia has also put it in its own public statement. So that's the next big project, which is going to be an astounding project if you have a permanent structure on the lunar surface. And then I think they will go on to build their space station. But you're correct. Right at this moment, it's more on the theoretical level.
Okay, that's amazing. That's amazing. And so your line in the sand is 10 to 12 stations by 2035. Do you have a number? Do you have a number of people? How do you have a guess what that is in terms of people?
Yeah, I think I can say that we would not exceed beyond 500.
Okay, less than 500. Okay.
Yes, because I know there are ambitions to have much more, but looking at the trajectory of development, we could hope for about 500. But once you achieve that particular capability of supporting 500 people at one time, not over the years, right? So today we have about 500 people that have actually gone to space and lived in space. But if you can exponentially increase that figure, you can then develop the capacity. Now, I might be completely proven wrong because technology can surprise me, capability development can surprise me, as reusability did surprise me. So, yeah. Yeah.
That's interesting. At first you said it was maybe a little bit more conservative than Peter, and then you doubled his number. He came in with 200 and you're like, it's 500. So, I mean, that's the thing though, right? Like we're in a wild card state where we really, really don't know. I do really agree with this number, 10 to 12 stations. Just math, that would be 50 people per station, 10 to 12 stations and 500 people, 50 people per station. That's the thing I can't figure out.
Yeah.
Are the stations going to be big enough to support 50 people? By 2035, I feel like that's a little bit more optimistic than I would have picked, but we just don't know. We just don't know. There's so many wild cards. And when you put up an image like this with, what is that, 70, 60 space agencies around the world?
Yes.
A few years ago, we were shocked silly by Luxembourg deciding to build a space program entirely commercially funded, right? Nobody saw that coming from the outside. So we know that United Arab Emirates is a wild card with their Martian goals. So I think there are some interesting wild cards, and we just don't know. So it's fascinating to see this number as this event unfolds. I'm going to be tracking everybody's predictions, and we're going to see how this plays out. But thank you so much, Dr. Goswami. Really appreciate you having here. We're gonna switch to the next person on our schedule. Let me switch gears here.
Thank you, Michael.
Thank you very much. I appreciate it. Kamil, sir, I really appreciate you being here. Let me pull up your bio here. Give me a second. Kamil Muzyka is a PhD candidate. He is a member of the Polish Astrobiological Society, co-editor of Prawo. I don't know if I'm pronouncing that correctly. He's a specialist in space manufacturing law and the field intersecting space law and patent law. Dr. Muzyka, please turn on your screen and join us. Thank you. Kamil, can you hear me?
Yeah, I can hear you now. Okay.
All right. Thanks. Please join us. The screen is yours.
Okay, so first of all, slide presentation. from the beginning and share screen. Which one is it? Yeah, this one. Okay, everybody sees my presentation? Okay. Yeah, is it showing?
Yes, it is. Thank you.
Okay, no problem. So, hello there. My name is Kamil Muzyka, and I am a Master of Law and also a PhD candidate at the Institute for Law Studies at the Polish Academy of Sciences. I'm also involved with several initiatives, mainly the Law and Outer Space Initiative in Poland. I was the member of the SGAC and the NPOC in Poland, and also I'm a member of the Polish Astrobiological Association. I mostly do legal works from the intersection of patent law and space law. So today I'm going to talk about the legal challenges for in-space manufacturing and possible solutions. So first of all, what are we going to talk about? We're going to talk about space objects with manufacturing capacities. So what is a space object? A space object is an artificial object, and via the tautology of international space law, even the component and the launcher is also a space object. And any robot that crawls on your space station, even though a space station is not a legal term in space law, a space station is a term, let me get it from the American Communication Law. The FCC Act, the paragraph 97, actually regulates what a space station is, and it's a station something about 50 miles above sea level, a radio station, not a crewed or an uncrewed space objects which provides experiments and so on. So yeah, we're going to talk about space objects because that is how they are defined within space law, although the American acts do refer to the term space object, but they use mostly the term space vehicles because some of the acts of the Title 51 were initially made for the shuttle program, especially the, for example, or even the Title 35 1005, the inventions in space were made.
Here we are, ready for our first.
Oh,
sorry about that.
No problem. Okay. So anyway, no problem. So anyway, also the definition of a space object comes mostly via Article 8 of the Aerospace Treaty, Article 1D of the Liability Convention, and Article 1B of the Registry Convention, although each nation has its own definition of a space object, and well, we will go back to this later. Anyway, what is a space object possessing a manufacturing capacity? It's a fairly mobile space object, meaning a crewed station, an interplanetary vehicle, cycler, a planetary rover, capable of producing programmed objects and products from available resources. The manufacturing capacity doesn't have to be limited to one object, like a roving factory. It might be a swarm object, like the one from the Advanced Automation for Space Mission that was Frosch's and Freitas's idea, which was later developed, the self-replicating lunar factories. Anyway, some of those objects may even possess and manufacture living components, although we have to remember that biosats actually did have living components registered in them, so they were so living organisms and bio and life science experiments were actually space objects, including the organisms that were within them. So yeah, that's a very curious thing if you actually think about it. But anyway, we won't talk about well, living space objects, although it is a very nice topic to talk about someday. but mostly the hello-technological, meaning the non-living technology. And what we need to discuss is the resources that we are going to talk about. First of all, the resources would be either those provided from celestial bodies, meaning the ISRU or space mining, how do you want to call it, or even the terrestrial industry via regular shippings. And well, there can be either natural space resources or the artificial space resources, the ones that are made from cannibalized or recycled space debris, something that Michael told me is going to be discussed at this conference. So I'm actually very eager to listen about how the people who are addressing those issues. So anyway, can we actually create a space object from a let's say from an asteroid or a lunar resource? Well, yes. The American US code, oh, it didn't show here. Okay. The US code title 51, paragraph 51.303, the asteroid and space resource rights states that an US citizen can actually use, own, possess and sell, and transport the resource he, she, or they obtained. So what is the use of space resource if you cannot use them? And by use, we mean that we can actually manufacture things, other space objects, their components from those resources. So the US has this in the clear. So, but well, not exactly, but it's at some point it is in the clear because they're allowed to use space resources, but the status of a space object isn't that clear here. Let's say that we come to the idea of machines making machines in outer space, even though they might be teleoperated by astronauts, and thus let's say if we are still in the American legal sphere, well, the title of astronaut actually gets let's say gets passed on to the space object. So the space object can, if it's teleoperated by an astronaut via the maritime law of the telepossession and the Columbus case and RMST case from the American salvage law, the space object can actually be used as an astronaut, but this is not the this will come out later here. Anyhow, now let's discuss the problem of, okay, can space objects, well, they can, we assume that they can manufacture other objects, but will they be recognized as space objects? This is where my PhD thesis and my legal work comes in, and the von Neumann doctrine, which has been presented in several papers and lectures I given and presentations, which mostly states that a state which retains jurisdiction and control over a space object possessing manufacturing capabilities shall retain the jurisdiction and control over the space objects and components manufactured in outer space or on a celestial body by said object or group of objects. What does it give us? Well, it gives us this trait status of what do we actually do via manufacturing, because, well, if it isn't a space object and it's not a celestial body anymore, then what is it? Well, some may say it is a foundling, like Star Wars fans, but mostly no, it should be a space object because, for example, nobody can steal it from us because, well, if it doesn't belong to anyone, that's not even a theft. And also, if we actually create something that later causes damage to other space objects or people or tourists, well, it is better for it to be known to others so they can actually claim our liability and sue us for damage. So anyway, the authorizing party will be recognized and held responsible and liable for damage done by in-space manufactured objects. And also we have the security that nobody can steal those objects from us. Well, of course, they will still remain open to other representatives under the Article 12 of the Outer Space Treaty, but that will come in later. Similar concepts have been presented also by the Hague Work Group for Space Resource Governance in their concept of a space-made product. And also the idea that, well, the jurisdiction and control, that the states actually retain jurisdiction and control over space-made product that their space objects and crew actually made. A similar concept came in the American Space Commerce Free Enterprise Act of 2017 and later 2019, which was never passed, unfortunately, but it actually gave some ideas over what was a manufactured or assembled space object and what clarified as what qualified as a space object and what didn't qualify as a space object. In the meaning of, for example, creating space objects from celestial bodies or simply manufacturing them from terrestrial matter in outer space. Anyway, there are some quarrels here because, well, the problem is with elements and infrastructure. For example, let's say that we made some kind of pavements or the dust protections at the launch pads from refined lunar regolith. Okay, so dust preventers that prevent dust blasts from harming any other space objects in the vicinity. Okay, they can be there from made from refined regolith or basalts that are part of the regolith. And okay, they can we can claim they are also space objects. But what about pavements? What about roads? Don't we actually go too far? We have to actually place a limit and say which part is going too far, or actually create a different concept for space objects. Because under Article 2, we cannot claim sovereignty or perform a national appropriation via either declaration, planting a flag, or even I don't know, any kind of activity we are going to do. But mostly we cannot assume that because we are carrying out experiments, we are carrying out mining operations, we are settling people there, that we actually own a part of Mars, Moon, or even some other celestial body. Well, and this was actually a form of protection against any kind of it was called, let me recall, it was the homesteading, yeah, homesteading, where you improve part of the land in order to gain real property. So no, real property is still not a thing in outer space, but any operation you do, but you do not claim sovereignty and you do not limit access of others, well, it's purely legal. But then, well, yeah. But where does the sovereignty and jurisdiction and control in space end? Because, well, we have to say that in order to actually, well, we were discussing the O'Neill cylinders. The O'Neill cylinders actually are a form of a, well, they are space objects, but they are the size of towns or even big cities. So a city-sized space object with a population is a piece of land that can be actually claimed as a colony. This is why they are called colonies, because that's the only way you can, well, in the legal term, colonize space. You can actually create an artificial piece of land, which is no longer a celestial body or piece of outer space. and extend your jurisdiction, sovereignty, and control over everyone and everything that is inside it, because that's under Articles 8. It's part of your jurisdiction. But anyway, there is the thing that you're seeing here is the keep out sphere and the approach maneuvers to the International Space Station. So how do we actually maintain that okay, sovereignty and jurisdiction end within the borderlines, the limits, the physical limits of a space object, and there is a void gap between those objects? For example, no matter if it's a few centimeters, few millimeters between two space objects, this limit actually is void of any jurisdiction or claims of sovereignty. It is a part of the province of all mankind. And this is yeah, on the face of it, yeah, this is international space law works that way. But if you have if you've just managed to create swarmed objects which work in cohesion, like for example some kind of new wave of a hyper constellation which creates a Dyson swarm-like megastructure. Anyway, you can actually limit the access of any terrestrial base operator to the outer space, because you cannot, let's say, shift, not shift, have to move those objects at whim. And anyway, that's a problem, because anybody who comes with into this void gap actually can cause harmful interference to your space objects and their operation. And this is where Article 9 comes in, and the problem of, okay, so even though you own your sovereignty, your jurisdiction and control only cannot exceed your space object, you can actually control spaces between your objects. And this is something that will be also discussed within the idea of safety zones, which aren't mostly, which have been spinned as a part of the space mining initiative, but actually are more connected to either the other industrial activities but mostly with propulsive landing on the surface of the moon. And this is also where the second of my concepts comes in, the hermit crab doctrine. The hermit crab doctrine comes from the idea that you can use discarded space debris or space wreckage, something like a dead satellite, a dead rover, and actually cannibalize it for spare parts that you could actually use. Of course, that is based on the Article 2, and it's in several interpretations. And why does it actually state that it's that you incorporate those parts of a dead spacecraft or a rover into your space object? Because the ISS is a patchwork of national jurisdictions, and every nation actually is responsible for their own, in some capacity, but they are responsible for their own space components and what happens with them. So okay, but in this case, for example, if we have let's say an American rover and a Chinese rover, and the American rover has a broken wheel and the Chinese rover has the same set of wheels, but it's broken, inoperational, and it cannot be revived, but those wheels could actually work, you could ask via the Article 2, and also this is where astronauts come in, because the astronauts have the right to enter foreign space objects, also have the right to get assistance. So, that's from the Article 5 and Article 12 of the Outer Space Treaty. Anyway, you can actually get this wheel and patch your rover, if it has the capacity to actually incorporate the wheel. But let's say that it has the capacity to incorporate the wheel. The problem here is, okay, so you suddenly have a rover that is mostly American, but part Chinese in its jurisdiction and control. So let's say if the jurisdiction control over this new wheel is still within the capacity of China, can China say, okay, we are turning your wheel off? So anyway, if it gets incorporated into the American jurisdiction, well, that also presents some issues with the patent system, because, well, suddenly it may turn out that it's not patent exhaustion if this wheel is patent protected in the United States and you haven't bought it legally from the authorized vendor. But we don't have time for discussing this much with the issue of patents. But we need to recall that in order to discuss space manufacturing, we need to see, like J. Peter Weik wrote in The Doomsday Has Been Cancelled, that there is no such thing as waste in our space, only byproducts. But, well, for example, that is how, for example, in the interstellar communities, the communities which actually study interstellar travel, view the interstellar medium and asteroids. They don't view them as, oh, we can sell platinum, we can sell titanium from the moon, and so on. No, we can reuse those things in order to patch up our ship, refuel our ship, or even replicate our ship if it's a Orbit probe, or, well, they are mostly called von Neumann probes, but they are essentially Orbit probes. Anyhow, yes, there will be a lot of talk about at this conference about recycling and upcycling space objects, but we have to recall that space objects are forever, even though we are erasing them from our national register. By placing them in graveyard orbits, they can still cause harm. And well, if they are for the taking, as some legal scholars think, well, those in the graveyard orbit, well, they're free for the taking, so nobody has to ask anybody about either either trade secrets or the use or the authorization of such an operation. But in any case, well, it's mostly because, well, nations need to agree on re-registering space objects, especially if they are, well, discarded space objects, because, well, they can include some elements which are classified or military grade, and something we don't want civilians or any private entities or foreign nationals to get their hands on. But this is also the problem with patents in our space, because the utility patents cover the embodiment of a protected device, a process, a method, or a system. A system is a very difficult thing because it can extend beyond several objects and objects that are even off foreign registry. Depending on the jurisdiction and the body of law, there are different doctrines and that apply to utility patents. Well, granting and authorizing granting a patent on an industrial space technology is different from authorizing space operations. We need to recall that even though something is illegal to be authorized in our space, it doesn't mean it's not it's not patentable, and these are different administrative procedures and different administrative bodies which govern authorizing space operations and the patenting of industrial space technology. And there is also the different subject matter of, for example, software patents and how they are treated, and biotechnology patents. Biotechnology patents are actually a very good example because, we'll get back to it later. And also there is the idea that, while physical phenomena cannot be patented, methods, devices, and systems that utilize them can be patented. And giving someone a national monopoly, because we need to recall that even though we are following a PCT patent procedure and patenting something and trying to protect a patent internationally, it's not covered internationally, but only in the jurisdictions we apply our priority. So anyway, getting back to issues with patents in space, well, there is a problem, for example, with the subject matter. And not everything is patentable, and also, we may try to, for example, patent a purified form of titanium. Well, this was even a U.S. COTUS case with, I don't recall if it was not John Dory, but it was a court case in the U.S. that, purified form of titanium is not patent applicable because titanium itself, is a product of nature. This is the product of nature doctrine. And also there is the problem of a space patent paradox, which currently exists, that, you have to disclose your technology in a patent in order to have this protection granted in the jurisdiction where you filed for a patent protection and or priority. And also there is the downmass problem, meaning that, many products from outer space will have limited use on the surface of the Earth, because we don't have the means to bulk freight not even refined metals or helium-free, but even something like protein biocrystals, or any kind of, for example, optical fibers. Anyway, we also have the problem of importation exhaustion and cannibalization, because, we're going to cannibalize space spare parts, and this is where patent exhaustion will kick in. And there will be several lawyers. I can bet anyone that there will be lawyers actually seeking any kind of seeking a how do you call it? Sue anybody for damage and patent infringement, because, the issue of parallel import or exhaustion, the repair and repair and reconstruction doctrine. This is a very important one for in-space manufacturing, because we would require our 3D printers or any other means of manufacturing to be able to manufacture spare parts and elements of our systems, spaceships, and so on. And the idea where the repair ends and reconstruction starts is something that we will actually need to address several times within the the legal sphere, especially when the legal sphere catches up with the idea of space manufacturing, because many people in the space law spheres are still bogged down in the concept of, can we mine space resources, or aren't we allowed, and we should seek another, or let's say a moon treaty or something like that, where the concept is, okay, so if we allow space resources to be mined commercially and be turned into space objects or their elements. So, and currently the remanufacturing, reconstruction, and repair doctrines of patent law will start to apply, and then we will see a major boom in, for example, training and workshops for people working in space manufacturing with patents and with lawyers. And also the idea of self-replication. Yeah, the self-replicating machines are something I really love in science fiction and futurology.
Kamil, pause.
Yeah,
pause.
This is the last slide.
Okay, great. Okay.
Okay, so the self-replication is actually an issue, and there is a term called self-replicating or self-reproducing technology in patent law. And the concept of self-replicating technology will be something that will need to be discussed in the space manufacturing circles, especially when we take into account that objects create other objects, and how it translates to jurisdiction, and how it translates, for example, to the idea of patent exhaustion, like because you're creating a new, a new unit, a new, let's say that create new parts and throw them out into the market, or like you're begin to be the competition to the patent holder. Also, the temporary presence. This is the problem that we will have to face because, well, while docking space objects do not create a problem of themselves, the American extraterritorial reach and the doctrine effect would actually, might actually interfere with problems like, for example, in space servicing or tugging space objects, or even using lasers on, light sails for propulsion, because you're actually having an effect, positive or negative, but you're using a patented technology, and it has an effect. It was on the American space object. This means that the patent holder can sue you in front of before the American court, and this comes from the Deca Loran case, and also the it was called Research on Motion versus NPT cases, and also the Deep South comes in. The void gap has been discussed, but also we need to recall that there is something like innocent infringement, because there is going to be talks about space objects using AIs and robots. And robots, unintentionally reconstructing or in other ways infringing on somebody else's patent. And how are we liable for something that is beyond our control within the patent system? And also the multinational and multi-jurisdictional modular space objects. Oh, and I forgot to say that all space objects within the international law are considered to be mobile. So there is no distinction between a ground base and ISS or a Mars cycler. They are all treated as if they are mobile. So that translates also within the temporary presence doctrine from the internet. It's not the international patent law, but internationally recognized harmonized patent law. So thank you for your attention. That would be all.
Thank you, sir. I'd like to bring Dr. Goswami and Peter Garretson back on the screen for a minute. Pete, I know that you have a really hard stop here in just 10 minutes, so I'm going to ask you to speak first, if you don't mind. Before I bring you on, I want to let everybody know that Nami and Pete wrote a pretty terrific book. I think it's worth highlighting and noting. It's pretty interesting. I recommend it. This next section is really a little bit of a free-for-all, because we just had three pretty fascinating conversations about policies, potential, and pitfalls. And so, Pete, if you want to kind of think about what's some of the potential pitfalls or policies, what's on your mind? What are you thinking about as kind of like the thing that we have to be paying attention to? Is Pete online? Okay, we knew that he had a hard stop, so he may have moved on. Nami, do you what's on your mind as far as the things that are absolutely have to be paying attention to, the pitfalls, potential, and policies that we should be looking at?
Yes, so the three things that I have in mind in terms of pitfalls, if I can start, is that I think we really need international application, if I may, or a body that can actually create very good space situational awareness. So today, most of the concerns we have are because we do not have a clear mapping of where the satellites are. We have registration, we have the US Space Force giving a warning, but we do not have a system that actually communicates and makes sure the communication reaches the other side, right? And that can create contention. We saw the recent difference of opinion between the US and China, where China complained surprisingly to the United Nations Office on Outer Space Affairs, a body that does not have the legal right to mandate how distances are to be maintained. And the US responding that China never reached out to the US bilaterally. So they just put out a response on January 28th, right? So that's number one in terms of concern. The second concern in terms of pitfalls I have is that one of the issues that we are not able to deal with, because space is also seen from a national security perspective, is the anti-satellite tests that are happening. So ASAT tests, of course, have national security implications. A country can argue that this is in the self-defense of the nation, which is supported by Article 51 of the United Nations Charter. But then what about the consequence of the debris that it creates? So that's the second concern I have. The third concern I have is once we have permanent installations, as the previous speaker was mentioning, that space objects are seen as mobile, right? Like moving. But if I understood him right, but the point is that what happens when you actually have a permanent structure that is built? How do you deal with the consequences of that? So a scenario I think through, including in conversations with my Chinese colleagues, is that what happens when you have a permanent installation like a research station on the south pole of the moon, right? So what happens if another country or entity wants to land there, but cannot because there is a permanent installation? So those are the three concerns I have in terms of pitfalls.
Interesting. I'm space domain awareness.
If I may address the last one.
Yeah, just a moment. Space domain awareness and just debris propagation, tracking. I think those are very, very big issues. What's up there and where is it? Like that seems like a pretty basic thing that we should already have answers to, but as we pointed out, it's a super complicated problem. Yeah, Kamil, I do want you to respond to that, but you mentioned a term while you were talking very briefly. I think is really important. I'd like you to go a little deeper into it, which is the doctrine of non-interference, because that's at the heart of this. That's kind of at the heart of some of this problem that we're dealing with. So could you go into a little bit further about what non-interference means so people understand that?
Yes, because, Goswami, that's your first name?
Yeah.
Yeah, Goswami mentioned the permanent station. So there is this thing like the Article 9, which causes when triggered, nations need to actually address the problem of harmful interference and create a how do you go? Well, they need to discuss the ways to actually prevent it or mitigate any problems of harmful interference. But that hasn't been very much tested yet, because we haven't. The moon is too big for our contemporary operations, but with more operations where you actually have a permanent station on the moon, and somebody just rides around in the rovers and so on. It's something like even a better concept is with Mars, because Mars has a thin atmosphere, and we know drones can fly there. do you have let's say a aerospace jurisdiction over Mars? Can you say that you cannot fly above my station? Stop flying above my station. No, you cannot. You can only claim harmful interference if there's any interference. But let's say astronauts or space tourists' privacy isn't considered harmful interference today. So yeah, there's the problem of non-collision and this and a harmful interference, especially when we are going to do something like, for example, making swarm objects or like multiple objects, place them on the moon or in orbits. This is going to be a very hard bargain for everybody because, well, today astronomers are complaining that they cannot see the skies properly, observe the skies properly because of Starlinks. Okay. But as far as I recall, there was even an issue where somebody wanted Starlinks to spread out because they wanted to launch a space object. And this is going to be an even bigger problem because, well, Starlink takes the hit for the team because they are also being prepared on other mega constellations of space objects. And this will be a giant problem because, well, you have a mesh around your orbit. Similarly, you will have a mesh around the moon because not only lunar surface objects, but you would also have to manufacture and launch and maintain lunar GPS satellites. Well, call it a lunar positioning system, but you know what I mean. The navigation, the telecommunications networks on the moon, and any kind of infrastructure for humans, robots, I don't know, any other post-human, para-human life forms or entities that we would give the rights and allow them to operate on the moon. Everybody needs this. And also the problem that I touched in one of my papers is the problem of living space objects. Because if you try to create, for example, you heard about biomining, I assume. Yeah. The use of bacteria for extraction of minerals. Yeah, so there is even a Polish startup called Extremo Technologies, which is being run by one of my friends who is also a member of the Polish Astrobiological Society. And they are aiming for things that were, well, also research like by the DLR and NASA that you can actually mine using in microgravity using bacteria. So if you actually create a hard enough bacteria that you don't need for example, a protective shell over them, they could they are well. They may be considered something like harmful contamination on the moon, but they are mostly being discussed in engineering and astrobiology circles, not as a problem, but as a solution for space mining, for industrial forming or terraforming. Industrial forming is a term that relates to not making something habitable for humans, but making it more habitable for industrial robots.
So when we're focusing back on the idea of a space station, or whether it's 1 or 100, how do these things come into existence? You know, we've got policies, we've got national sovereignty issues, you've got academic, civil, commercial, defense players. What I'm hearing is this is really complicated. Like, this is hard stuff to do. And it's not just the technology, right? You know, I think, you know, I'd have consensus from the two of y'all that the technology is probably available, but that the hard part might be just humans getting out of our own darn way. Is that fair? Is that where we are?
Yes, because there is a problem. Okay, Go ahead.
Please, Namrata.
No, go ahead. I'll follow you.
Yeah, Kamil, short.
Okay. So, so the problem I see is, for example, with one nation actually accepting and respecting the other nation's authority to follow Article 6 of the Outer Space Treaty and authorize any activity. If the nation authorizes, for example, manufacturing of a constellation of satellites or a group of robots or anything they actually want, I don't know, creating a O'Neill cylinder, other nations need to actually respect that, and only, they're allowed only to act when there is a potential threat to them in outer space, or, for example, if it would carry weapons of mass destruction, or, in some way, for example, potentially damage their own space operation, interfere with them. For example, if you would like try to create a only cylinder, but not in the L points, but in the lower Earth orbit. So yeah, many satellites would crash into it, permanently, or have other permanent damage. So yeah, this is the problem where actually some states would actually either try to undermine other nations' authority and sovereignty, the sovereign decision for administrative acts that translate into authorizing space activities, but also we need to take into account space piracy and cybersecurity, because this will also be a form of a weapon of the underdogs against the major players. Like ASAT weapons, for example, you can they can be proliferated. You can like nuclear weapons. There is a problem of proliferation that somebody can buy and then use it as a means of terror against one another. Well, the problem with with space hacking is also a problem that needs to be addressed, because you can actually hack and authorize, for example, a space factory to create the rods from God, as you may call it, and either threaten or create a shrapnel craft, which will spew space debris, and you have a Kessler syndrome on the way. So that's from me.
Nami?
Yeah, sure. So I think to answer your question about space stations and what we can anticipate in terms of, the good thing is that there are different companies and countries talking about space stations, because we need them more, because of the fact that there are more experiments to be had. We need to learn how to survive in space, not just a few, but several of us, right? So that's the good part. I think what was not anticipated by the 1960s treaties and the follow-on treaties was that you would have 1,000 satellite constellations, right? That's one. And so, for example, and that is a case study that I think we'll learn from. So the recent case study of China complaining to the United Nations Office on Outer Space Affairs that 2 Starlink satellites came very close to their Tianhe module in July and October, and calling upon the United States to basically meet its treaty obligations under the Outer Space Treaty. But what is interesting is that if you see the response from the US, and I urge your audience to read it because it's going to become a precedent, right? So their argument is that, well, there were bilateral channels that China did not, basically use. For example, they could have reached out to the US Space Command, which monitors such satellites, 2 Starlink satellites in question here. The second important thing pointed out was that the US Space Force basically gives warnings if there is a possibility of satellites coming very close to an entity in space. And so what we see here is that there was the urging of bilateral communication. And so that's why I say the importance of an international communication structure is critical. And the UN Outer Space Affairs does not have the legal right to mandate in this particular situation. And the final issue, I think, when it comes to space stations and the possibility of any debris or satellite coming close to it, is that there is no US national documentation of what distance means. So neither SpaceX nor the United States nor China has pointed out what is safe distance.
Really? There's not a rule? The FCC doesn't have that for, sorry, we're about to get into the weeds here, but I'm curious. So for those folks listening, satellites that are too close to each other can have a communications interference, right? So based on the power of the sending and receiving antennas of the various craft, I thought there were rules defining how close they could get. Are you saying there isn't?
Yeah, in terms of open source analysis, there is no common understanding of what is safe distance between countries. So for example, if the US thinks that 100-mile is unsafe distance, let's just take a speculative number.
Yep.
So China might not agree. China's safe distance might be 50 miles, right? Mm-hmm. And SpaceX, and what is unfortunate is that in this particular incident, none of the entities involved, the US, China, or SpaceX, have responded to questions about what they consider as safe distance. And so that's another issue that we will probably be dealing with much more as we build more stations and as we go out. But I think, Michael, I'm more optimistic because these situations are coming up now. And so already the United Nations office is now getting involved. So there will be pressure. And you can see that, for example, resolution 7536 that was brought about by the United Kingdom in December 2020 urges nation to think about this issue, space traffic management, space debris management, and 163 countries actually supported first committee in the UN General Assembly to look at this question. It's called the Open-Ended Working Group. And so we'll have much more guidelines in terms of what is safe distance, international consensus on what is safe distance. So I think those are the issues as we think about structures in space that we need to deal with. We do not have answers to it today.
Is that also going to bring up the work that Kamil was interested in about debris recovery, or is that just communications?
It will also include debris mitigation and recovery, as he's talking about. So China recently, I think, demonstrated its capability to grab another satellite in geosynchronous orbit, right? So which they have pointed out that it's part of their debris mitigation program. So if you look at their white paper, they stress on the need for developing what Kamil is talking about. Cleanup space, for example. It's expensive. A Japanese company, I think, is starting to do it in terms of theoretical concept, but that is also part of the issue. Now, the other thing which gives you insight into how member states are thinking is the responses to the UN General Assembly resolution. So if you look at the 7536 resolution, there are responses even from Iran and North Korea to how they think about space traffic management and debris. So it's very insightful, actually.
Oh, that's fascinating. I wasn't aware of those.
There is also a problem here.
Yeah.
Sorry, there is a problem also here that you actually those same means of remediating space debris and clearing up space wreckage, salvaging dead satellites, are also the means that you can damage or incapacitate active military satellites or actually commercial satellites. And this is also a problem when discussing how should we clean up the skies, because suddenly somebody says, oh, but that's the same means you can use against a legitimate satellite which is operational and has a strategical or in other ways meaning for national security or national economy. And that's kind of a showstopper in those discussions. Like the people don't know how to address the issue. Well, I know that some people say, no, it would be only limited to dead satellites, and we have good faith in people who want to do it. But we also know, you, Michael, also read Larry Niven's works, and you know that, propulsion is your first weapon in outer space.
I've heard these conversations a lot. One person's tool is another person's weapon. Right? You can use a hammer to build a house or crush a skull, and these space tugs of various different flavors can be great for debris cleanup and mitigation, but also can be used to, grab an adversarial nation's satellite system. So it's one of the reasons why Space Force is looking to miniaturize its assets and spread them out, so it's not big, exquisite, juicy targets as they talk about. So
yeah, I think I'll quickly respond to that point, Michael, because I think it's an important point you make. So one of the concerns that was put forward when China actually showed the simulated version of a robotic arm in 2013. And one of the Chinese papers that came out of the Academy of Military Sciences pointed out that you could use it for dual purposes, right? So you could use it for debris, picking up a defunct satellite, but you can also possibly pick up a functioning satellite if conflict, for example, if there is a conflict in the Taiwan Straits. So that's a concern. I think the one biggest concern in terms of the future we are talking about is that we do not have any international obligatory or guidelines. For example, if two satellites come close, which satellite or which country's satellite will maneuver away? So it's a prisoner's dilemma. Who is going to maneuver first? So actually, it's interesting because it has happened in 2019 between two friendly countries. So for example, the European Space Agency satellite, a Starlink satellite came very close to a European Space Agency satellite. And ESA actually communicated to SpaceX that this is happening. But SpaceX, for some reason, didn't see the email or did not respond.
Yeah,
and
skeptical.
ESA had to maneuver. But maneuvering costs you money because you need fuel. So I think we'll learn from these experiences, but these incidents are happening as we speak.
Well, let's go a tiny bit further into that because we got to switch gears, but
Also,
maneuvering costs
thing
money, right? That's an important detail. Maneuvering costs money. It costs fuel, reduces the useful life of that satellite, and there's a price tag to that. So nobody wants to move, and it's a game of cosmic chicken at this point. Prisoner's dilemma.
Yeah. We forgot one thing. I forgot one thing discussing space law, meaning the arrest of a foreign satellite. Do we all remember the thing that came out between Myanmar and Japan, where Japan actually arrested Myanmar satellites because there was a fear that the currently operating government can use those observational satellites in order to persecute the opposition in their country. That's as far as I recall, Japan never released those objects.
Right.
Even though they were actually obliged via contract to launch them and make them operational, but they seized the operation and they arrested those satellites.
Crazy. That one I find pretty fascinating and pretty strange. All right, y'all, I really appreciate it. We're going to move on to the next topic. Thank you so much for all of your insights and wisdom. This is, I think what we're saying is this is going to get bumpy, right? At the end of the day, this is not easy what we're trying to do. So thank you very much. I appreciate it.
Thank you, Michael.
Okay.
And thank you, Kamil. Bye-bye.
I only just a moment ago saw Jordan's question about, is the price tag allowing orbital service and assembling and manufacturing? I'm not sure I understand that question. I'll try to answer it later. Jordan, you've got my email, so go ahead and just send me that. Thanks. Okay. All right. So pretty interesting how this morning is kind of starting, right? What we're seeing is there's potential. I want to stress there's potential. Oh, I didn't ask Kamil during his Q&A about numbers. All right. Kamil, in the chat, would you mind posting what you think our space station numbers, our astronaut numbers are going to look like for 2025, 2030, and 2035. I'd like to capture that. Thanks. We're going to switch gears a bit. In our event series that we've been running over the last year and a half, we made the decision to not really have a quote bathroom break, because we are streaming on a couple live channels. That tends to, if you have dead air, it tends to drop our audience. So we don't really do that, but this would be one of those moments where if it's time, it's time. I'm going to spend the next 15 minutes kind of giving an overview of Liftport Group, what we're doing, how we're doing, how this event series kind of ties into our aspirational goals of building a lunar space elevator. So this is just a little bit of one-on-one time. If you need to go walk the dog or make yourself a fresh cup of coffee or whatever, now's the time to do it. So a lot of y'all are new to Liftport Group. A lot of y'all are new to my team. So let me give you a little bit of background. And I'm going to talk a little bit about this today and then also again tomorrow. Different content because people are going to, different people will be here. But by way of background, I'm Michael Laine. I'm the president of Liftport Group. And we have a very complicated history. I personally have a very complicated history. I started in space about 20 years ago professionally. I was a nerd long before that. And in my early 30s, I was in this spot where I was closing down my internet company. I had an internet company from 1996 to 2001. It ultimately didn't really grow the way I hoped it would, but I had a fair amount of personal resources because of some real estate investments. And I'm in this point where I'm trying to figure out what's next for myself in my future. I had always wanted to do space, but I never really had the background. I thought at the time the only path to space was go to NASA, and not to be an astronaut myself, but to help other people move out into the solar system. So I started a small company, ultimately never went anywhere, but in the process of starting that, I got the attention of some folks working on the NASA Institute for Advanced Concepts research team on the space elevator. So this is kind of the starting point of that very unusual career. In 2001, 2, and 3, I was on the NASA Institute for Advanced Concepts research team to look at the idea of building a space elevator on the Earth. And in 2003, I created the first version of Liftport Group, which was a small company. We eventually grew to about 14 people. You can see some of the artifacts of those days behind me. Down here, there's a whole bunch of nanotech. We did a fair amount of material sciences. Candidly, we were not that good at that. We had some interesting successes, but also we learned an awful lot of lessons from the things that didn't work. We made some strings. We made some, and for the Earth elevator, that was really necessary. It was a materials problem. At the time, I thought it was a materials problem. We built robots. We built some robots literally out of garage parts that were just lying around. And one day, my best friend and I just decided let's see if we can build a robot to climb string. We built a bunch using Legos to try to understand better. We had some people with a lot of artistic talent to help us conceptualize pieces. And eventually we built nearly 20 robots to climb up and down strings. So this one climbed a mile into the sky. We had large balloons tethered to the ground with robots climbing back and forth. So those were the years 2003, 4, 5, 6, and 7. Things got pretty dramatic for me in 2007. It was the beginning of the economic crisis. Most people learned about it in 2008. I learned the hard way. It was actually started a little bit early. I made a fair amount of mistakes in the process of building the first version of Liftport. And it came, I lost my real estate assets in 2007, and that led to closing out the company. So Liftport closed in 2007. The first version did. And then it was weird because I was in this kind of weird limbo state. So I went on to International Space University, ISU, in 2008. Took some other courses again in some MBA courses in 2010 and 11. And it was in around 2010 and 11 that my team, and we weren't a company yet, we were just friends. We remained friends after the company closed. My team helped me understand an epiphany that a lunar elevator was possible with current materials. Let that sink in for a second. We had just spent nearly a decade working on an Earth elevator where we were chasing, affectionately called unobtainium, a material strong enough to build the Earth elevator. And that was pretty interesting. No luck. Nobody in the world, even 20 years later, has solved that problem. There are some really interesting indications out in the UK that looks very promising. So I'm hopeful that my colleagues can solve the materials problem there. But in 2010, 11, and into 12, we had this epiphany that we could build an elevator out of current materials. And there are, depending on who you ask, there's about 14 materials that are all strong enough to build the lunar elevator. Now the mechanics are different. I'm not going to get into that right now, but suffice to say that that was a pretty interesting epiphany. Fast forward, we were not a company again until 2017, at which point we felt like we had enough substance, structure, financial capacity. Remember, my wealth had evaporated in 07, so it took 10 years. And so in 2017, it was just me and two very, very smart interns that helped me really start putting this together as a program, as a project. It was pretty meager to begin with. There are a lot of stories about the early days. One of the things that really gave me a lot of confidence was we made some presentations to what was then the chief scientist of Air Force Space Command. He has now been promoted to the chief scientist of US Space Force. We gave some presentations down in Colorado Springs. We went out to the Air Force Academy, went out to then Space Command. And I'm not going to say that they validated what we're doing, because they absolutely did not. That's not their job. But to say that we surprised them, that is true. We surprised them. And that has led to us, really having the confidence to build this back into a company, into a team, and into a project. When at the end of 2019, things were a little spooky around here. We were quite worried about what our kind of immediate future was going to look like. I'm sorry, the end of 2020, right? The end of 2020. because of the pandemic and the uncertainty in the world, things were looking kind of spooky for our company. And we wound up, surprisingly, with a contract to do events like this for the Foundation for the Future. And so our contract was to host and curate a once a month conference, a technical conference. And that was enough revenues to kind of keep the lights on around here and keep our team functioning. That was great. We were really happy to do that. And then over the course of that contract, which ended, very friendly, very amicably in November last year, what we realized was that building an elevator in the sky is really expensive and really complicated. And so what we needed to do was have a permanent, reliable revenue stream, a product that could support our research efforts. And that's the evolution that got us to today. That's where our company is. That's kind of the beginnings of our research project. We're very confident that the lunar elevator can be constructed with current technology, and we're working pretty hard to get that to happen. But it takes capital to do that. And so our decision to self-finance through developing these conferences is a part of that. And so when you look at the series that we're creating, space stations, the finance and capital of money, of space, and the future and lunar settlement, all of those things become a part of our grand idea. So that's kind of where we are as a company. I'll talk more about the lunar elevator itself in tomorrow's brief 15 minutes. So thank you. I'm going to switch gears here to a little bit of the more interactive component of this of today's content. If the target is 15,000 people living, playing, having babies, dying, building careers, whatever it is that you do, if that's really the goal, then how do you get there? How do you do that? We've got a blank sheet of paper ahead of us here, and what we're going to do collectively, I hope, is start to source what should those requirements, architecture, feasibility, and trades look like. And so I refer to that as RAFT, and I think that's the starting point. Tomorrow we're going to talk a little bit about. Tomorrow we're going to talk a little bit about the Numenia process. It's a tool set that I created in order to put structure around building the lunar elevator, and then we're going to employ that structure in the creation of this imaginary but aspirational space station. So let me just I'm going to stop watching you. I'm going to switch gears to a different screen. And what I'd like to do is capture notes about what you think the requirements should be for a 15,000 person space station. And you know what, before I get to that, is 15,000 the right number? I don't know whether it is or not. I told you a little bit of the story about how I arrived to it. That's only part of the story. But I think that's what I want to aim for. I think that would be a lever that the rest of the world can use to build. And some stuff that Dr. Goswami said a little while ago was that when we get to the point where we have 10 or 12 space stations, maybe they have 50, an average of 50 people, and you've got 500 people continuously living on orbit, that is the seed, that is the catalyst for something truly amazing. And I'm not going to sit here and try to pretend what that looks like down the road, but what I'm hoping that we do as a community, as a team, is to be that catalyzing agent to build something really amazing. So with that, I'm going to swap gears. What I'd like you to do is help us out in the chat and start putting your ideas in here, right? So first thing up is requirements. Whenever you're building a large system, good systems engineering means that you figure out what that is. What are the requirements? I used to joke about the space elevator. People ask me, am I committed to building the space elevator? Because 20 years ago, that seemed like a pretty crazy thing to be committed to. And I said, no, it's not. It's not. My commitment is moving humanity off the world. My commitment is to build space-based solar power systems that can power a planet. So, very tongue-in-cheek, I said, if we could figure out telekinesis and you could have, 7 people chanting around a bonfire and using their mind to push objects into orbit, then I'm fine with that. Then that's the plan. I'd stop working on the space elevator and focus on telekinesis. And that was kind of a joke, but it was kind of true. And so fast forward, here we are 20 years later, you've got reusable rocketry transforming space. It's transforming access to space. And so it makes me wonder whether the Earth elevator ever can be or should be built just from a pure economics and launch capability. We've got tens of thousands of satellites under construction and in development now. Is the Earth elevator able to dodge all of those satellites? I would argue probably not. Nami and Kamil were both talking about orbital debris. There is an unknown but north of millions items of debris out there circling the world. Can the elevator be constructed strong enough to withstand hits? The elevator that Edwards and I originally, the elevator that Edwards initially conceived of and that I supported was designed to withstand minor hits of small debris, but we did not imagine the world that the orbital environment that we're confronted with now. So I contend that the Earth elevator may or may not be possible anymore, but that the lunar elevator is kind of our necessary next step. But when you work on big ideas, you start with requirements. So what would be some of the requirements that we're starting to look at? And I see that people are starting to post stuff. So let me see if I can read that at the same time here. And we'll just talk about some of this stuff. Oh, Kamil, thanks for posting your numbers. What I would like I like this. I like the text that you wrote here. Thank you. I appreciate that. What I'm looking for is a specific number that you're willing to put your reputation on. So 2025 and 2030, how many people on orbit? 2030 to 35, how many people on orbit? And now to 2025, how many people on orbit? So, okay. So Chris, he's saying, don't don't focus on the number of people living in space as the goal. I would suggest we look at it to create scalable Earth biosphere replica that can act as cosmic homes. All right, so that's interesting. So first of all, don't focus on the number. I would make the argument that the number is symbolic. But I think you're absolutely right that it's really about the technology being scalable, so it doesn't matter how many, right? So if you can make a station that so you couldn't double the size of the International Space Station. Let me restate that. It would be very expensive to double the size of the International Space Station, but if you built the systems large enough, you might get triple the number of people. So if you enlarge the station by twice, you might get 3 or 4 times the numbers. So maybe that gets us to Pete and Nami's number of 20 people. I think that might be. But I think you're right. It may not be the number of people, but I would argue that a symbol, a target is powerful. And if you can show me a symbol that would be equally powerful, I'm definitely willing to consider that. But you're right. It's not about the number. It's about the capability. Does that kind of encompass it? I hope. Yeah. And then Jacob is saying that we need standards for collaboration and integration. And I know that that's his personal thing. He's always talking about as a service. I definitely can agree with that part. So standards, all right. So standards and integration are necessary. I would argue that those are necessary part of the requirements. Let's see. We see megaton-sized mini Earths with all the comforts of home as the standard for space habitation. Our position is that we want to have humanity to be a spacefaring species, not a multiplanetary one, and that our best application of technology is to create these enclosed biospheres that can be our arcs rather than living on mud balls. I do think that's interesting. The book that Garretson was talking about right from the beginning is The High Frontier by Gerard O'Neill. I'm really, I showed you my book collection here. I have a signed copy. Unfortunately, it's not to me. He died before I'd ever had a chance to read it. But I do have an autographed copy, and it's one of my prized collections. I have a lot of signed books. That's important to me. And his basic thesis was, is an advancing civilization better to live in a zero gravity environment? I mean, that was his, is a gravity well necessary or even good for a civilization that's growing? And I thought that was a pretty fascinating idea. I came to O'Neill really late in my career. I don't think I read O'Neill until I was 50. I'm 54. It hasn't been that long. I'd always kind of ignored it. I said earlier today that I had not really paid that much attention to space stations. And now I feel like it's like a light bulb that's gone off. So I do think that's interesting. So Chris, you're kind of advocating for big, right? I think that's how I'm reading. That's how I'm interpreting this. And yeah, I'm happy to chat. Let me. Here's my Calendly link. I'm happy to chat with anybody about, and I'll get I'm connected to a lot of y'all already on LinkedIn, but let me just, while I'm thinking about it, put my profile in here. I lost my place here. There we go. Okay, so Chris is going back with the numbers might be symbolic. My point is to have tech that can create unlimited size space structures, using the coming launch capacity to put megatons into orbit, 75% of which is Earth biosphere. Save humanity from climate change and create a spacefaring cosmic destiny. Boy, that certainly resonates with me. I appreciate that comment. A couple of months ago, I was, let me just find a link here. Give me a second. I'm very honored to be a part of this particular community. I'm sharing a link right now. At the invitation of the Chief Scientist of U.S. Space Force, he and the Air Force Research Lab and the Defense Innovation Unit, every year, they host a meeting that's called the Industrial Space Base Meeting. And this is the 3rd year that it's been running. I'm going to share screen of it for a moment. And it's so here's the link I just posted. Here's a pretty good video on it. And then later down here is the actual report itself. This report is really interesting. It's eye-opening. There's some important stuff in it. But let's look at it, right? So you've got the colonel who runs Air Force Research Lab, the civilian who runs who is the chief scientist of U.S. Space Force, and the general that runs Defense Innovation Unit. Our own Pete Garretson, who I don't know if he's still on the call, edited it. It's a pretty, I said when I brought Pete on that I thought his introduction was a little on the humble side, and that's one of the reasons. But so those are those people, right? And then the forward is by the NASA administrator and the 4-star general that runs U.S. Space Force. So arguably, these two people kind of identify, direct, and shape, at the very least, U.S. policy on space. And if you look at Namrata's chart of how many space agencies there are, the ripple effects that these two folks have out into the rest of the world are immeasurable but giant. And I bring that up. I'm going to close this off. Let me get the. I put the link to the site. I'm going to also put the link to the report. So that link isn't going to work. I did something wrong. All right. Well, don't worry about the link. If you follow the first link, it'll get you the second link. The report is worth watching, reviewing. But I bring that up because Chris is talking about sending megaton structures into the sky. And one of the things that's really interesting in the report is just how much launch capacity we have. And I have another document to share here. But I'm cited in the document we just described with the phrase Starship Singularity. And the Starship Singularity, in my opinion, is that everything in the world changes once Starship starts to fly. There is so much capacity on that machine. We don't really even have a good understanding of what to do with it. It hasn't flown yet. Like, we've had some tests. All right, the tests are super fun to watch. The Falcon Heavy hasn't flown very often. And so the first revolution in space right now is really generated by SpaceX. Blue Origin is a little far behind them, but there's a lot going on. And let me pull up another page here. So this is a report by Bryce. They issue a report every quarter. So this is brand new. It's only a few days old, maybe 2 days old. And look at this, right? This is all of the launches, right? Each of these organizations had one. Each of these organizations had two. That's pretty astounding. That yes, the nation of China had twice the capacity of one US company. That's pretty interesting to me. And SpaceX, and this is only quarter. So this is last year, the last quarter of last year, 90 days. So 90 days, all of this stuff happened, right? And these guys are coming on pretty fast, pretty heavy. These folks have been, a mainstay of the system for a long time. And we've got some, kind of new players in the field. I mean, JAX has been around a long time. Korea's been around a long time, but that's another private company in development. And I'm sorry, I can't read this well enough to know who this is, but I don't recognize the symbol. And that's a Chinese company, I believe, but I'm not certain of that. So this is what I mean by the Starship Singularity, that okay, it's only 170 spacecraft for one company. Now that means these spacecraft are tiny, right? I'm sorry, I can't put my hand up. I broke my arm. These are small spacecraft, but it's a revolution that's coming, right? Look at this mass, right? So SpaceX had half the launches, 8 versus 15, half the launches of China, and still it managed to launch 12,000 kilos more, 20% more than the nation state of China, right? That is astounding to me. That means the world is changing, and it's changing really, really fast. And then even these small organizations, it must have been Iran, the one I couldn't read. It must have been Iran that I couldn't read. I just realized that. And then this is interesting. I hate this map. Namrata put up a screen that showed all of the space agencies around the world. That's an amazing map. I love that map. But I mean, it's clustered, right? Australia, Africa, South America, not launching anything. Now these nation states tend to partner with these nation states when they launch something. So that's always good. But and I'm actually quite pleased. I know that's contrary to a lot of people thinking, for me, but I'm actually quite pleased that Iran was able to get a launch out. And I think we shouldn't be ignoring Japan. And I thought, maybe I misread it, but I thought there was an Indian launch, but maybe I was reading about a future launch. Maybe it was a different time. I'm not sure. But I feel like this map shows just how empty the world is in launch capability. Like on the one side up here, I'm like, oh, wow, we're really cool. We can launch a lot of stuff. And then I'm like, oh, but not everybody can launch a lot of stuff. So I think, we need to democratize that a little bit. But that's my International Space University Starfleet Academy mindset. So no surprise here. Lots of it's in communications. And no surprise here that small sats are leading the path. Okay, I'm going to stop sharing that and come back to requirements. I point all this stuff out because I want you to understand that things are changing. They're changing really, really fast. And as a result of those changes, the capacity for humans to do stuff on orbit is increasing. And when you've got a Starship Singularity on the horizon, I want to point out all of those changes, those are happening because SpaceX has perfected one rocket. The Falcon 9 is their workhorse, but their second rocket, the Heavy, has not been producing as much. It's not flying as often. It's not contracted as often, and that the Starship, when it does fly, has so much excess capacity we don't even know what to do with it. So megastructures, like Chris is talking about, that's happening. That's happening in a really big way, and it's happening very quickly. So hence hashtag Starship Singularity. Okay, I want to keep going. I want to go back to oh, Namrata, thanks. Right, I love the Bryce reports. Those folks are good. I recommend reading stuff from Bryce, Euroconsult. You had a Euroconsult graph I use a lot in your talk, and because I like tracking the money of space. Space Angels has a report that comes out, I think, every quarter also, and between those three, I feel like I'm somewhat on top of things. Yeah. So let's kind of stick back to the core topic of requirements, right? So maybe not focus on numbers, or maybe have a symbol that is still inspiring. Focus on leveraging technologies so that one can become two, and two can become four. Kamil was talking about von Neumann machines and self-replication. I'm not sure that we're going to have space stations replicating space stations, but there are going to be parts there that build other parts. And Pete was talking about how build a ring, build another ring beside it, build another ring beside it, and if you build enough rings in the right shape, you get a space station, right? So what are the requirements, architecture, feasibility, and trades? Let's throw some ideas out there. How do people feel about the difference between building one giant station and 100 stations of 150 people? Or vice versa, 150 stations of 100 people. I think there's some really important trades there that need to be considered. And obviously, those are arbitrary numbers. It's going to be something in between there. But what does that look like? I'd really like to get some ideas of what you think about architectures that we should be investigating. And then the feasibility, right? Like, if somebody wants to comment about 2035, I would love to hear how I've described it with the speakers. Who wants to put in some guesses about 2025, 2030, and 2035? What are our astronaut numbers going to be when we get there? Kamil, I don't know who Macro Life is, so I can't comment on that. If you could provide a link or some comment, some text, that would be helpful. John, before you got here, I mentioned and Pete Garretson concurred. So we showed a screen of that Jeff Bezos uses when he talks about giant space structures or neocylinders, and he's got an elk, a giant elk sitting on a hillside, and then you see that hillside's actually in space. And so we were talking about that, and I mentioned the conversation about building out a station large enough to encompass a grove of redwoods. That should be one of our aspirational requirements, that we should have enough real estate, enough control over our biome that we can bring anything that we want, because we should, right? We should have whales, we should have great white sharks, we should have bats. I'm not super keen on importing mosquitoes, but if you're going to have bats, you got to have mosquitoes. So like what are our, so that's a requirement then. We need to have enough control over our biome, water, air, pressure. We have to have enough real estate to have excess. They've never had a cat on the International Space Station. They could, right? That would not be particularly tricky. Might be hard to house train, but the luxury of a cat on the International Space Station is unthinkable, right? There's no way we would attempt to do that. So when we're talking about a giant space station or a series of many stations, incorporating those pieces, I think, are part of the requirement features. Chris, the core features needed in our space tech are these: permanent support of Earth life, including gravity. Now we're going to talk about gravity, centripetal acceleration. We're going to talk about that, I think, in month number 2 or month number 3, but we're going to spend a lot of time on that one because that might be the key to this whole thing. Self-sustaining enclosed ecosystems. We're going to bring in somebody who works on the Arizona Biosphere 2, and we're also going to bring in some other folks that I've got the request in, I haven't gotten confirmed, but people who actually spent time in the original Biosphere experiment. I've got some requests in for them. So we are going to try to get from the horse's mouth, right? What does it take to build a self-sustaining ecosystem? And we're going to bring in some folks that are running Martian and lunar analog sites as well. So we do really need to understand that piece. Integrate this from a single spacecraft hotel. Yeah, I think I'm going to reserve a little bit of skepticism about that. Next month we're going to talk with some folks running Starlab. That's the NanoRex single launch space station, which I think is long overdue. So we're going to try and bring in some folks that actually know this stuff, and they know it way better than me. So that's going to be fun. Yep. John wants to see, squirrels and deer and brooks. So yep, that's probably part of the to-do list. Chris, this list is what we use for our star cities. Okay, cool. Good. So that list that you just posted, permanent support, self-sustaining ecosystem, single spacecraft. Okay, cool. So Kamil answered the question about the Maker Life. I will look that up later, sir. I appreciate that link. We are going to be collecting this chat, by the way, so don't worry about stuff. I will be capturing it later. I actually built a place to take notes digitally with everybody, but this is actually easier. I explained that I broke my hand in 2 places, so typing is pretty challenging. So this actually works better that y'all do the typing. So I appreciate that. I'm not aware of these aquases. I'll have to look into that. That sounds really cool. All right, Nami, she's like, all right, so here's her, this is her putting her number for public. 2025, 50 people. 2030, 200 people, and 2035, 500 people. I gotta say, I love your enthusiasm. I appreciate that. I actually did not think it would be that high. So I'm really pleased to see that target. Yeah, the game-changing technology is right around the corner, right? So the ability to construct on orbit. So I hope you all watch and pay attention to the call that's happening a little bit, because I think Gary is going to wow everybody with some stuff. He showed some stuff to me about 2 months ago that my jaw just dropped to the floor. So constructing on orbit is a game changer. So that's what we're going to talk about here in a minute. Build aquasaves to address up to 1 billion climate refugees. Wow, that would be amazing, because I think we have a big problem here. And then yeah, so okay, we didn't talk about Russia. I feel like we kind of missed that opportunity to talk about Russia. So let's bring it back here for a second. I'm supposed to be switching gears to my next speaker right now. So I don't actually see my next speaker on screen, so I'm a little worried about that. I'm killing time. But I don't know. I feel like Russia, and honestly, man, you study this more than I do. You know it way better than me. But from an outsider perspective, given what's going on in Russia these days, I really got to think that their priority is not space, given their nonsense of their most recent test. Give me 10 seconds here. Let me check some messages and see if I have something from our next speaker. Okay. I've got communication with him from 30 minutes ago that says that he's got 2 other people, Fabio and Taylor. Can you verify that they have got the links? I'm seeing responses from them, so they're nearby, but they are not on screen that I can see. Yeah, so just hunt them down for me, please. I'm gonna bring Pete back on screen for a second. Let me just we're gonna tap dance for a second. Pete, can you like, you grounded us a minute ago about what's possible, and then Kamil and Namrata had the reality check that it's really, really hard and really, really bumpy. But if you were to make some predictions. Do you know enough about the space station companies themselves to kind of place some bets? Or is that kind of outside your zone?
I think that's outside my zone.
Okay. All right. I'm getting some weird feedback from you. That was weird sense. All right. Well, then what is your zone? What is your zone? What are the areas that you think are like these things we need to pay attention to? I know you had a hard stop on the last call a minute ago, so we kind of missed you in the possibilities, pitfalls, and policies section. So do you have any comments that you'd like to add to that?
So look, I think the possibilities are basically unlimited. And I think, it's going to be critically important. It's going to be, very important, to individual nation states in the long run as to who is in the forefront, of this, because, as Namrata and I discussed in our book, the components of national power have always been land and population, economic production frontier and resources. And, the resources of space basically give you access to all the components to be able to manufacture more of a country, basically, in space. And, that'll start with existing powerful nation states and may have some surprises in terms of who goes after it that isn't a powerful nation state today, but could be because of their investments in space. And, this, I will often show a slide. In fact, I think I've got a slide here, if I can find it, about exponential growth. And so let me just share the screen. So I don't know how old, the audience, is, but, essentially, compound interest, as Isaac Asimov says, is pretty magical. And the earlier you start, the more incredible different things can make. And, I would, say that, our efforts in space are compounding in growth, but especially as we start developing, systems that have some level of self-replication, the ability to exponentially expand out is very large. And so what that means is that it seems like things are going slow in the beginning, but then they build faster and faster and faster. And if you invest early, the difference it makes in terms of volume and wealth in the out years is just staggering. Like you can see the difference, here as to, if you start investing at 25 versus at 35, right? By the time you're 65, the difference in how much of your bank account, is
Crazy.
It's really substantial. And it's the same, in space and space resources. So, I think that the possibilities of, where this could go, are truly staggering in terms of like, where this could go. But we don't know exactly when, right? People thought that, the flying machine was, millions of years in the future, and folks thought the transcontinental railroad, was 100 years before its time, and that turned out to be wrong.
Right.
But we also thought that we'd be building on, colonies, years before today, and we were wrong. So knowing where you are on the hype curve is difficult to know, but, there is this underlying, logistics curve or exponential, curve that is going on, all along. And when you hit that takeoff point, you don't really know. And we've got the right, building blocks here, just to move way up in my,
right,
slide deck here. If you look at what contributed to U.S. national power ages ago, it was simple things: replaceable parts, petroleum, internal combustion, and those things gave rise to this incredible infrastructure. And right now we've got really, really simple things, extractive industries or space mining. You've got, the ability to, additively manufacture things and assemble them, but that could go, very, very far. You could start building enormous structures that could lead you to, large space hotels, and then ultimately to really, really big facilities like we started talking about, of, millions of metric tons. So it's very exciting where things are going. And these are they're very simple elements that we're already working on right now that are taking us in the right direction.
Beautiful. It's beautiful. I mean, it's a kind of an astounding potential future. It's one of those things where I imagined it when I was 15, and nearly 40 years later, I kind of have a hard time imagining that I'm a part of this now. Right. I always felt like somebody, way smarter than me was going to have to be the folks to figure this out. But, we all have a role in building this better future. I wanted to be one of the people who worked on a digger problem, by the way. My best friend and I have been pondering that for a very long time.
By the way, just to ad lib on this, right? These are all things that are, in planning, in development today. And I think, everything in this next slide, this slide right here, I should say, these are already in planning today too. But I think, certainly by 2030, I think you're going to see all of these components except the one on the bottom. So, you will see on the moon diggers and dump trucks, picking up and moving things. You'll see, some kind of a basic, metals and oxygen processing, probably much sooner, I would guess, circa 2026. And then already we're building the transport systems. And I think in the next 2 or 3 years, you'll start seeing robotic construction, and once those start doing things at any kind of volume, you'll see the press for these, really high transport systems where you're essentially got a catapult to push things off of the moon. And at that point, your scaling, possibilities are enormous.
Yeah.
Or I should say your space elevator as well as a direct competitor, with this.
I don't think in terms of competitor. I think of allied capabilities, right? They can do things we can do. They can do things we can't, and vice versa. We're gonna swap things around. I just got a communication from my team that there's been a timing confusion. So we're gonna start working on the workshop and community building component. Taylor, if you can come on screen for that. And give Gary a time specifically on when. Let's kind of narrow down the time of when he's going to be on screen at 2:30 Mountain. Is that correct?
Yes, I believe that's correct.
Okay. All right. So that would be, that's a while from now. Okay, cool. All right. So we're going to do our workshops first. Troy, thank you for joining us. I'm literally learning this right now. So you're welcome to stick around. Happy to have you. Or you can come back a little bit later when Gary's on. I know you're going to join Gary, so sorry for trying to do the logistics in real time with everybody in front, but this is what we got. What do you want to do?
No, that works. I'll come back with Gary in the group later. Already excited and loving what's going on here, and that's the fun of the new space, figuring things out on the fly sometimes.
We have to adapt. Exactly right. Exactly. I appreciate it. And I'm really glad that you, just as a personal note, I'm glad that you joined us on such a short notice. I really appreciate the work that Gary has done to kind of pull this really great team together. I'm excited to hear. I said before you came on screen that Gary showed me something 2 months ago that was astounding to me. So I'm really looking forward to your talk. Thanks. All right.
Wonderful.
So we'll see you soon. Thank you. Appreciate it. And Fabio, sorry, we have to do a little bit more logistics. Fabio, if you can adjust the website schedule to reflect this new change, that would be helpful. So we're going to do, Taylor, we're going to do both workshops now, and we'll push Gary and Paul back. Fabio, you're going to have to tell Paul his new updated time. Okay. All right. Sorry for the logistics shifts, everybody. But as I said in the first minutes, that this is, even though we've done this now 17 times, they're all different, and there's training wheels every single time. So yeah, thanks. All right. So this next segment, it's a little bit similar to what we did. The reason that we put that block in the middle, because we wanted to showcase the work that Gary and Troy and Paul and a couple others are doing before we did this workshop. So that's a scheduling snafu, but we are going to adjust. I wanted y'all to see some of the work that they were doing, because it gives some understanding to the complexity of what we're working towards. I don't want to do a spoiler alert and tell y'all what they're working on, so I know I'm being vague on purpose. But with being vague, we're going to focus on hardware, right? The things that fly, the things that we will eventually live in. Hardware, by the way I define it, it kind of has a couple components. There's the research and discovery phase. There's the engineering and kind of widget making phase. And then there's the mass production commercialization phase. And whether you're talking about carbon nanotubes and failed experiments, or whether you're talking about the logistics of getting gasoline at the gas pump, that technology is everywhere. And every technology in that chain went through the ideation invention stage, the engineering stage, and then the mass production stage. A long time ago, as a part of a space solar power startup that was promising a technology and a solar panel efficiency, because they literally had read something off the internet about a breakthrough technology, and so they went and incorporated that efficiency production number, energy production number, into their slide deck like the very next day. And I'm like, whoa, let's put some brakes on that. I called the company, and they said that they could produce that amount, the panel, the size of it would take them 500 years at their current production level to make a panel the size that my employer was promising. They would have to build entirely new factories in order to hit the production levels. So hardware is not something to mess around with, right? There are stages to it. So with that, I'm going to turn the screen over to Taylor, and we're going to do a community building workshop. Okay. And I'm going to go off screen for about 10 minutes because I have to go pay parking. So you're on your own, Taylor. You're good, right?
Yes, thank you, Michael.
All right, thank you. I'll be right back.
So I'll just take a moment to invite everyone, if you haven't already, to to share your LinkedIn profiles, to share your email addresses. If you do desire to network, please share that in the chat messages. But part of this workshop is a community building moment. We do greatly appreciate your attendance and attention at this kickoff event. And we do want to build on what we start here today. This is not just a 2-day conversation. This is not just an hour-long conversation. This is something that will take time, patience, teamwork, sweat, and many other factors for us to find success and to just find solutions. So it is our goal to maintain flow, increase contact time, and provide a niche for all things space station, and even some things that are just simply important to you individually or that you just find interesting. Better Futures really wants to know what you care about, what's dear to you. So we're here to start a forum and to showcase key indicators for the foundations of humanity's next step toward being a multi-planetary culture or a spacefaring culture, or both. This is the beginning of a major cultural and social shift, and your individual participation today is the mark of being on the bleeding edge, so congratulations. When Michael returns, he'll talk about how to get involved, about some of our social channels that you can use to continue the conversation, and he'll also go over minimum viable answers. So we know that there's, of course, going to be many hardware challenges, and we know that things, objects, people only make it to space because someone, or a team rather, made every effort to get it past the tyranny of gravity, as Michael would say. But to kind of get us to be a little bit more personable, I would like for those that can to comment, or if you want to come on mic, some of the speakers or panelists, if they're still present, I would like to hear from you individuals, something that you would like to personally bring to space, if you could. I guess either bring to space personally or send to space. And something that you would like to remove or exclude from space. This can be literally anything from a pet to a picture to a form of art. It can be a favorite. It could be an entire establishment. I'm just curious, what are some personal things that some of you would like to see in space? And what are some things that you would absolutely not want to see in space? This can be anything from bad attitudes to nuclear waste, to habits, to traditions. I see Paul has his hand up. I'm not sure if I have permissions to allow speaking. Perhaps our technician can help us with that. But I'll give you all some time to draft, to share the things that that you would like to see in space and that you would not like to see in space. Paul, did you want to say something?
Hello, I'm not sure if can you hear me there, Taylor?
Yes, I can hear you.
One item I would like to send to space, and it is sentimental. My good friend, he designed our logo and he designed our video for Fuse Ring, and he is a flying buff. He passed away from leukemia. He fought it bravely for about 4 years. Remission, came back, and I sense his pains when they give him those specific pills that tackles one specific gene. But anyways, he's gone, but I would like to send his logo into space. He designed the logo, and I asked NASA to give us space for a demo. The demo is we can weld in space, and it fits inside the Bishop container just nicely. And I thought his logo on the welding machine would be cool. So say Rob was in space. That's all.
That's very sweet. That's very heartfelt. It would be amazing to have an organized way of commemorating and remember those who perhaps aren't going to complete the journey that some of us are on. I would also say that that's also a very important part that's probably that may not be covered in this conversation this weekend. But yeah, we do have to figure out, how do we deal with death and mourning in space? I'm sure it'll look differently than what we have presently. So I don't have a ton of comments on what people would like to see in space. Perhaps you're still typing away. So moving past, I'll kind of circle back to Chris Medley's comment about the core features needed in our space technology, being permanent life support for Earth life, including gravity, self-sustained, enclosed ecosystems, integrating this from a single spacecraft hotel to the VLSS. These are all very important, broad, fundamental necessities. And I guess I'll kind of close the aperture a little bit. And I don't know if it's closing or widening, but I'm curious about, say, for instance, the size of things. What are their current structures that exist on Earth that are really compatible or congruent to the population size that we're throwing about, this 15,000 people number? And I'm also wondering, what type of message are we trying to communicate with whatever shape and geometry that we come up with for this giant space station? It's been mentioned, rings have been mentioned, cylinders have been mentioned, and I'm curious what that communicates to those that are able to observe the structure. When we step back and look at these different shapes, do they communicate speed? Do they communicate maneuverability? What exactly does it represent? Do we want to have symbolism in our architecture and structure, or do we want it to simply be symbolic? Do we not want to have these features? So another question that I have, and please feel free, any questions that you may have, please feel free to throw them into the chat. But scale, when we come to scaling and building and creating this infrastructure, how unique should it be? How much of it do we want to see be borrowed from previous space stations or space stations that are currently being drafted? Do we want it to be, how modular should it be? Will there be cabins, decks, and stories, and units, and chambers? How do we really visualize this asset and its architecture? So I've said a lot of words. If there's any that come to mind, I would love to imagine if someone has the courage to share what they picture, because of course we build upon the manifestations of our imagination. We have a comment, we have a few comments. Seeing in space from George, colonizing of space needs to benefit underdeveloped countries as much as return to investors of programs. Completely agree. The underdeveloped, underrepresented, underserved countries, the population is, it's only shifting, it's only growing. And I had a question, it's kind of a business question, but it's like, what type of responsibilities and roles, how are we going to base it off of population size, or we base it off of a country's GDP? At what stage these various countries participate in the construction and the talks? How do we dole out the weight and the importance and the roles of people? Because it'll just become more hairy as we have to decide and figure out who leadership will be, who will be the talkers, who will be the listeners. There's another comment from Chris. Yes, aircraft carriers and cruise ships house thousands of people. We just need to create space cruiser variants to take the marine cruise industry into space. I think that's a pretty cool statement. Modeling it off of marine structures makes a lot of sense. And I mean, we're coming off of a planet that is 70% water-based. So why not use that technology to not have to reinvent some of the wheels? John commented he's really interested in seeing a sense of nature in space. Love the idea of populating space, but don't want it to be antiseptic. I want to see natural flora and fauna. We need parks and we need ecosystems that sustain all the beautiful creatures of life, such as butterflies, redwoods, and blue whales. I agree. I think that life would be pretty dull if we didn't have the nuances of chirping birds, of rustling leaves, of just hearing rainfall. We won't hear rainfall. I think that those are very important humanistic, just spirit supporting, mindset supporting features that we're probably not going to. I think that if we just had to rely on speakers and headphones and headsets to try to recapitulate what we experience on Earth, we will definitely be missing out on a lot of things. I do have a question that before I turn it over to Michael to let him talk about getting involved in minimal viable answers. Tuesday just passed, February 2nd, 2022, and it made me think, what redundancies are key to the hardware of the space station and those it supports? That's a question that I would love to see answers to in the chat. Again, it's the question of what redundancies are necessary to the hardware of the space station. Of course, we want to have replicates because 2 is 1 and 1 is 9, but at what point does it become detrimental? Michael, would you like to talk about getting involved, our socials, and the minimum viable answer?
Yeah, let's do that. So thank you, Taylor. Appreciate that. So we're trying to build an elevator in the sky, right? That is a complicated thing to do. And so in the process of learning how to do that, we really come to understand that ambiguity is our friend. It is not our nemesis. It is actually an ally and an asset. And Silicon Valley has perpetuated this idea of a minimum viable product. Like, what is the smallest possible system that will actually work? And so when we're trying to build an elevator on the moon, because there are so many unanswered questions, I'm often quoted by the phrase, we don't even have all the questions yet, let alone have all the answers. That we do need to create a list of questions that need to get solved before we can proceed to the next step. And so what Liftport operates under is the idea of a minimum viable answer. And so a minimum viable answer from our perspective is a good enough guess. It's a good enough guess that so for example, people ask us all the time, like, how long is the string? Well, to answer that question, we have to identify what is the string made of. And we know that none of the strings are perfect. So we need to probably make a composite material because they've got creep and elongation and radiation resistance and ultraviolet resistance. So there's going to be a composite material. And so all of those answers come together for how long is the string. We cannot answer the core question because we don't have the rest of the sub questions answered. So we build this concept of the minimum viable answer. Basically, it's an answer that gets us further down the road. It gets us closer to where we need to be. And so that's kind of what we're looking for. That's the mindset that we want to perpetuate when we start thinking about big space stations or multiple space stations. Is what is the minimum standard? What is the minimum level? And when that comes to hardware, that means life support. That means, what is the air temperature, the pressure, humidity? How do we recycle? What happens when you have to use the bathroom, right? So, basic life support. I know that Pete and I and John talked about a grove of redwoods, but there's a company, Astrobotics, Grant Thornton. He proposed an experiment to go to the moon during the Google Lunar X Prize days. Ultimately never flew, but he proposed building a chamber, a terrarium, for lack of a better word, that would keep a plant alive during the 14-day sunlight cycle on the moon. Now, I think that's an astounding idea. I think that's the kind of thing that would really surprise people, kind of amaze people a little bit. And it points to, necessary next steps. So I think that might be one of those minimum viable technologies, right? That we go after that as a symbol for larger things. So one of the things I want to invite everybody, and it's not just me, it's the team. I want to invite everybody to our Discord channel to kind of keep this conversation going, to start collecting information, ideas, problem sets, questions. Let's identify as many questions as we can around the hardware, so that when we start thinking about requirements, architecture, feasibility, and trades, we've got a place to start. And we'd like to invite the community to participate in that. Paul, you had your hand up. Did you want to chime in on something?
Paul actually already spoke a moment ago. He was mentioning about a friend that passed, and we were kind of briefly talking. We were talking. He spoke about wanting to send a logo to space to remember a friend of his that passed from leukemia.
Oh, yeah.
And I mentioned that, the death and waste and dying is not something in mourning. It's not something that's really been covered in this panel per se, in this talk this weekend, but that's a very important thing to keep in mind. How do we deal with that? How do we deal with casualties in space?
Well, Paul, there are some memorial services that are sending people to space. There are some of those services. Some people are sending basically the equivalent of a fingernail, but it contains all of your DNA, and that's going to the moon. Other people are sending ashes to orbit and to the moon. And I heard about a company in Japan that is trying to build basically a custom-made shooting star, so that you have the body and you release it in such a way, at such an altitude and speed, such that it comes back to the world in the form of a shooting star and burns up on entry. I think that would be an amazing tribute. I don't know that that's the Viking funeral pyre that I want, but I do think that there are some interesting conversations around terrestrially, how do we deal with death? And no one is really talking about dying on orbit yet, right? So cross your fingers that nothing bad happens to anyone on the International Space Station. We just passed both anniversaries of the Columbia crash and the Challenger crash. January is a dark month for NASA's experience. Certainly nobody wants bad things to happen. We're kind of fortunate that it hasn't happened in quite a while, as the cadence for commercial launches increases, and as more private astronauts, commercial astronauts go to space. It's a numbers game. It's a game of roulette. Something bad will happen. We will all be sad when it does. It'll be a setback to the community when it does. When Virgin Galactic Virgin Galactic has had 3 people die in the pursuit of their spacecraft. One was a crash landing, and 2 people were killed in a fueling fire. So we do know that, tragedy hits our industry, and I don't think, we're going to talk a lot tomorrow about birth in space, but hardly anybody's talking about death in space. It's kind of I guess maybe we're right now that we're kind of discovering that it's a taboo topic. That's interesting. We should maybe pursue that a little bit. All right, let me, Taylor, can you post the links to the Discord channel? I don't know if any of y'all are using Discord. I don't know if that's a tool in your normal toolbox. We've started using it for community building and communications, and we just built this brand new channel specifically around hardware business outreach and framework. So we'll post links in the chat to each of these, and of course to the general channel. So I want to stick with the conversation about hardware requirements. What are the things that we need to really focus on for hardware? I mentioned life support, but that's just one piece. Paul later is going to talk about welding in space. I think a lot of people are not paying attention to the fact that we have to build this stuff, and how does that happen? John just posted that when they were building the Golden Gate Bridge, the planners expected 1 death per $1 million spent. It took $27 million to build, and there were 19 deaths. Wow. I sincerely hope that our numbers are not that bad. I consider that pretty good for a structure of that size and complexity. But if we're talking about a multi-billion-dollar, 15,000 person space station, that becomes very expensive in terms of human life. I hope that's not true. I hope that those numbers are do not reflect what we're doing. So what kind of, and we're going to talk about business and outreach and framework today and tomorrow, but what kinds of elements should be requirements for the hardware side? Let's not kill people. I think that's a good requirement. Like John, let's go with John's idea. Like let's not kill people, but if people are going to die, let's make that number low. Okay, like let's just make that a requirement. But right, the planners did have to make an assumption, so I don't know what our assumption would be. So yeah, let's try hard to not have people injured or die in the pursuit of this task. What other, Chris is talking about modularity. If you look at this robot, you can't tell from this distance, but there's 1, 2, 3, 4, 5 obvious modules. You can't tell, but there's another one at the top and another one at the very bottom. So we built that modularly from the very beginning. I'm a big believer in that. I'm going to recommend another book. Hold on a sec. This one, The Box, is about how the containerized systems. Taylor lives in a port town. I live in a port town. We see containers. It's a daily part of we're on different ends of the country, but it's a part of our everyday experience. These giant container ships that move from east to west and back and forth. Modularization is the key to space. It's the key to SpaceX with their incremental improvements. It's the key to several of the copycat companies. They're trying to follow on what SpaceX is doing, and improve and innovate over SpaceX. It's hard to innovate over SpaceX, but there are companies doing it. That modularity is super vital to this entire industry. This book, by the way, is making the rounds at some very senior levels across the whole space administration of the United States, whether it's at NASA, whether it's at Space Force, whether it's private companies, big companies, small companies, and academia. It's on this topic that I swear would be the most dull, deadly dull topic, but it points very specifically to how by making things modular, you had a global revolution in supply chain management. If you didn't have boxes, you couldn't have Walmart. If you didn't have boxes, you couldn't have Amazon. Like, that's how significant that modularization is. And that's modularization in shipping, but it's also modularization in developing of the systems, right? So the cargo that goes up needs to be modularized. The rocketry itself, you've seen the reusable components. You've seen the astounding pictures when SpaceX lands one or sometimes two rocket boosters at the same time. That's modularity. And we're going to take that as the foundation for the next step. So the stations, whatever they look like, will also be highly modular. So that's an important requirement we should add into the list. George Rogers, you've got your hand up. Do you want this? What are you thinking?
Hello. I've enjoyed your presentation today. Just wanted to let you know that there are lots of countries, depending on their economies and economics of space technology. Doing the space stations is just the first step, but I mean, we have multiple countries already going to Mars, and I'm looking at one of them. I created a company to do that, but in my business model, I started looking at the analog of who's doing what and where, and I found about 30, 40 different countries doing space analogs, and there's probably about double that looking to expand the next 3 to 5 years to expand their country's economies. And what I came across is that the space industry right now is got exponential growth, like you're talking about, but they're looking at that to be the next trend for probably the next 15 to 20 years. And every country in the world wants to get on that bandwagon right now. So as far as scale, this thing is as big as you can think. And a lot of people compare it to, crossing the Atlantic and seeing the new Americas, and combine that with the gold rush on top of it. So every country is trying to get the gold out of it and trying to figure out what kind of piece they can grab out of it. So there's no wild ideas or bad ideas. Everything is pursuable. The underlying statement, it has to be constructed and built right now. So constructability is the main thing. There's been a lot of proposals that been reviewed and looked at that's not buildable and can't not be built. So right now, everybody wants to make the fastest push to space right now. And in order to get there quicker, so our programs don't die, we need to get there soon. And it has to be constructed now. You cannot develop or design something that's in 15 to 20 years away. You need to be doing it now. And your research is good, but research and development is probably 15, 20 years out on new stuff. So our company is focusing on using existing technologies to go to Mars. And like you said earlier on your presentation, there's realistically nothing stopping us from going to Mars because we have all the technologies other than the SpaceX rocket. If they can prove they can get to Mars, we can live on Mars.
Yep. Thank you, George. I saw you put a link earlier in. I'd be really interested to chat with you. I posted my Calendly link earlier. I'll post it again. But I'd be really interested to talk to you about your 30 analog sites. I'm aware of probably about a dozen. 30 surprises me, and that's actually a really exciting number. I'd like to talk more about that. Later, I think it's in the summer. I don't have the schedule in front of me right now. I think later in the summer, we're going to specifically talk about analogs, what we can learn from them, what we already have learned from them, and what we can't learn from them. So we're gonna like really dive into analog. So I'd really appreciate a follow-up conversation with you. Thank you. Appreciate your comments. Okay, so sticking with hardware, we've talked about systems that can be expanded, and maybe it's for the moon, maybe it's for Mars. That the lessons we learn in building space stations can be applied in other places. We've talked about how we don't want it to just be a human-centric to the exclusion of everything else. Like that there needs to be a biome there that we create and take with us. That modularity is maybe the key to it. That people are going to die. How do we handle that? And what are our expected numbers relating that? What other things should we be considering when we're considering the minimum viable answers for hardware? I think something that I'm really quite annoyed about, 2003, 2004, very briefly, I was a part of a project to send mice to orbit. And it was going to be in a little circular satellite, super small, probably not even the size of my desk, but it was going to be a living space for mice. And the idea was, can critters gestate and come to term? And it was going to be a spinning system. It was going to be an artificial gravity environment. Wasn't going to be a lot of them, but there were going to be a couple. I think it was like 4 pairs. And the experiment started out with, it was going to be 4 male-female pairs, and somebody somewhere in an administrative role is like, nope, we're not going to do that. No explanation, but you can kind of guess where they were coming from. And then, okay, fine, we're going to send up 8 verified pregnant mother mice. And arbitrarily, that number got dropped to 8 because apparently, it got dropped from 8 to 4 because apparently 8 is too many mice to kill. And this whole thing just got whittled away and whittled away and whittled away until there was nothing left to this proposal. And I won't name the schools. You would all recognize the schools. They are giant first-tier schools from three different continents, all partnering on this thing. And at the end of the day, it got killed. It got killed financially. It got killed administratively, and nothing ever happened. And so here we are. I've been reading about artificial gravity, centripetal simulated gravity since for 40 years, and we still don't know the answer to whether or not we can procreate in space. We don't know. We know that bone loss and it affects, like gravity affects the minerals in your body. It affects bone loss. It affects your eyes. You may have permanent eye damage. There's some indications about hearing problems. We know what not having gravity does to us we don't know what having simulated gravity does to us. And so the idea of starting small with a mouse experiment seemed like a most basic minimum viable answer. And yet it's one of those things where we just simply don't know. There's good research behind it, there's good theory behind it, but no one has had the capacity, or I would say courage, to test these things in the sky. So that's one area that I want us to make sure that we are paying attention to is gravity or simulated gravity. Can we really exist? I mean, all the pretty pictures of elk in orbit come to nothing if we can't solve this basic simple question. So I consider that to be one of the minimums. George comments about a nuclear submarine has a crew of 200. I live, by the way, coincidentally, I live very close to a naval base that has some of those subs, so I'm pretty aware of that. They have a completely self-contained environment for 200 people. The whole life support system. They can remain underwater for days, weeks, and I've heard rumor of months at a time. I think there's a pretty substantial psychological strain if you're underwater for weeks and months at a time. But the technology is absolutely there. Now they have to resurface in an environment where they can replenish. And so it's not perpetually self-supporting, but it is a closed system part of the time. And I think that gets us mostly where we need to go. I think it's true for Mars. I think it's true for the moon, and it's true for space stations. Now, the difference is that replenishing of systems once they come to the surface, and that we don't really have a good handle on, which is why I'm a big proponent of going to the moon before Mars. But I don't want to start a moon versus Mars argument with you. I support Mars. I just think there's steps. Chris, I also am a big fan of energy, nuclear energy. Pete, do you want to, we got to shift gears here very quickly, but do you want to chime in on energy? Do you want to chime in on that? Are you still here?
Sure. I'm happy to talk the vital importance of energy.
Pete, before you jump into this, and we only have like 5 minutes, but I want your Pete is a acknowledged expert in energy and space. He had a quote maybe 2 years ago at that same space industrial meeting that I referenced earlier, that power in space equals power in space. And that's kind of an unforgettable quote to me. So talk a little bit about energy, sir. I'm going to cede the floor because it's not my area.
Well, I think fundamentally, any kind of transformation you want to make or any type of movement of information, requires energy. And, to get anywhere requires energy. To build anything requires energy. And, right now, the energy that we have in space, the largest single platform is the International Space Station, which is, on the order of 100 kilowatts. As a constellation, Starlink individually has, somewhere around, 5 to 6 kilowatts. But with the number that they've put up, I think the number is like, 4 megawatts. But if we really want to do impressive things in space, if we want to extract vital materials from the moon, if we want to be able to construct things, if we want to be able to go at any kind of, in speed that's relevant to human life, we're going to need a lot of energy. Now, the sun we our Earth makes use of about a billionth of the sun's output power. So there's a lot of growth for that one gravitational confinement fusion reactor that's actually working. And
what did you call that? A gravitationally confined fusion reactor is the sun?
Just
I like that
joking, you have magnetic confined, you have confinement fusion.
Gravitationally confined fusion.
So I work in gravitational confined fusion with direct conversion via the photoelectric effect. So if you look at just the growth possibilities for human energy on Earth from space, it's just staggering. If you imagine what kind of energy system we would like a 24-hour fully renewable energy system that could power all civilization. We need about 18 terawatts of energy for Earth today. And if you imagine that we could grow to say 12 billion people on planet Earth, and that all of them would have a first world lifestyle, the UN estimates are that you need about 55 terawatts, of which 40 terawatts have to be non-carbon producing. Well, you could make, a tiny fraction of 1% of the lunar mass, you could build, 6 times that required power, with very, very generous spacing in geostationary orbit. And geo is not crowded in terms of space. Geo is crowded in terms of antennas that radiate over the same area. But because a solar power satellite has such a big beaming aperture, you can put many, many more of them in geostationary orbit without any interference. So, you could put 332 terawatts or so just in geostationary orbit alone. And then solar is not, the solution for everything. It makes sense to move to both nuclear fission and fusion. And so, it is an all of the above, strategy in space. And then you've got to consider that energy gets stored and moved as fuels and propellants. And so that's where lunar water that can be electrolyzed into hydrogen and oxygen, becomes one of the, critical, and methane on Mars. Actually, there's some methane in the lunar poles, we think, as well. So, energy is terribly important. And ages ago, I wrote what I hope would become a strategy for the Department of Energy that I'll post in chat. But, basically, if you want to do ambitious things in space, you need to graduate from kilowatts to megawatts, and eventually megawatts to gigawatts.
Brilliant. Thank you. Appreciate that, sir. As an aside, some of this industrial base meeting that I keep referring to, a lot of policy documents are created out of that thing, and the one where Garretson was talking about power in space equals power in space, I believe that resonated, and that was the beginning of a Department of Energy decision to start backing space power systems, which they had kind of been reluctant to participate in. So, we had the meeting, the report got written, and about 6 weeks after the report was written, Department of Energy issues a request for proposal for space energy assets. So Chris is like, thanks, Peter. Yeah, thanks, Peter. Yeah, I'm not saying that he did it, and he will never say that he did it, but I think that it was a very influential conversation that we had back, I guess, 2 Mays ago, a year and a half ago. Okay, we are going to switch gears. I appreciate everybody's comments. I want to make sure I captured. Pete just posted a bunch of links. I will review them later. Oh yeah, you just put the industrial base. Good. I just talked about that one. Cool. Yep. Jennifer's talking about how the psychological elements of living in tiny space. I think that's really accurate. I know people who have, it's called overwintering. That's the term when you go down to the Antarctic and stay there, quote, over the winter. It's really hard. It's really hard to do that. I have classmates that did the Mars 500 challenge, where there were 6 people basically in a 500 cubic meter space for 500 days. Now, I guess it was 1,000 cubic meters for 500 days to simulate what it would take to go to Mars. It was a psychological experiment. The only thing they were testing was, did people go crazy? It was tricky. It was challenging. I don't think we can overlook the psychological impact, because we're talking about people going to these remote places. And I believe the longest person in space lasted slightly over a year, like 400 days. It was a Russian during the Soviet era, if I've got my history correct. And then Commander Scott Kelly went just under that. So I believe he's got the second longest record of like 380 days or something like that. But the impacts are serious. They're real, and we don't really have a good handle on it yet. I do think that as much as I loathe Facebook, that the idea of the metaverse is real, and it will be a factor in how we deal with artificially created environments. So that's my own hunch. I don't know. That's not an area. I don't count me as an expert on that. That's just me kind of ad-libbing from the outside. So we're gonna switch gears. Oh, and Jennifer, also testing in self-developing environments. It's one of the reasons why I want to bring in a bunch of folks talking about analogs, because I think that what we learn from those will be very, very helpful. I've spent a couple, I've never done a personal experiment at MDRS, Mars Desert Research Station, run by the Mars Society. I have visited there 3 times and run 2 experiments out there. So I was part of the support crew, not the internal crew. We are going to bring in some folks next month that have experience on that. Curiously, one astronaut who's flown, Dr. Proctor, and one astronaut that's about to fly in about 2 months, Jessica Watkins. What's Jessica's last name? Darn it. The new astronaut that just got selected for the extended ISS mission. Both of those people have had Mars Desert Research Station analog experience. So I think I think you're going to just see more and more of how valuable just how valuable those analogs are. But that's my hunch. All right, let me switch gears. We've got to switch gears. I appreciate Pete going kind of extemporaneous on the energy question, but we need to switch gears to kind of the same workshop format, where we're trying to solicit and develop community around money. This stuff that we're talking about is expensive, right? Yes, okay, the Starship Singularity is going to drop the price to orbit, but it doesn't drop it to 0. It takes it from billions into millions, which is amazing, right? Taking 2 or 3 zeros out of the equation is astounding. But there's still a lot of zeros left. So when we talk about what I want to focus on for this next 20 minutes or so is to think about the business of what we're trying to do. And let's be honest, it doesn't have to be an American corporate structure that accomplishes this. Roger's talking about Mars. The biggest wild card in the Mars game is United Arab Emirates. That's an entirely different source of money. We've already seen evidence that the cryptocurrency community is willing to fund big ideas in space. That's an entirely new source of money. Dr. Goswami was talking about China's activated goals of a commercial sector, but led by the Chinese party. So there is no set model on how we build and financially build a giant space station. There is no set model. That is as much a financial experiment as it is a hardware technological experiment. Further, the logistics and communications of the system are challenging. And if you look at the different models for how this will be constructed financially, whether it's a corporate capitalist program or a state-run program of the Indian, Chinese, or I'm not saying that the United Arab Emirates are going to build a space station. I haven't heard that, but their model is probably worth paying attention to. So how does this thing get built from a dollars and cents perspective? Again, we're going back to requirements. How much is too much money? How much is what's a price tag that's too high? John earlier was talking about the death toll for the Golden Gate Bridge. Somebody somewhere in an actuarial table assumed that $1 million per person was an okay price. That was a long time ago. I don't know if those numbers would still add up today, but let's talk about money. Let's talk about how we build this thing. What do you think? Anybody have any comments about the requirements of building a giant space station focused around business? I think this is the first time the chat has been silent today. I'm a little surprised. Yeah, I'm actually a little surprised. That's the first time it's been quiet today. Kamil is talking about manufacturing or building out a hotel. I think that's near and dear to my heart. I'll call Kamil and then Paul. When Troy and Krystal and Gary show up, we're going to talk about manufacturing really from a hardware perspective, but there definitely is a financial component there. John is talking about if you have 15,000 people, they all need a place to live. You could sell each $1 million spaces. I mean, that's a pretty interesting model. Just straight capitalist and not a government civic program, not a defense program, but he says we could finance it with conventional banking now. That's pretty good.
If I can chip in, Michael, there is a problem.
Wait, Kamil, let me bring in Paul first and then you, okay? Go ahead, Paul.
Thanks, Michael. Just a quick point. money the world has in oodles. If you look at Mr. Bezos' boat that just cleared Amsterdam, $500
$100
million.
million. Yep.
The world has money. All the question is which sector gets the money?
Mm-hmm.
We can live like Mr. Buffett drives a 13-year-old truck or car,
Right.
or you can live on a 200 or 400 meter yacht. So whichever, but it's a matter of dedication. That's all I wanted to say.
Great. I mean, I think that's definitely true. Earlier, we talked about the pharaohs creating the pyramids, and that was a very dictatorial program. It worked pretty well if you were at the top of that food chain. Didn't work so well if you were at the bottom, but that was the model once upon a time. So where is the will? Where is the finances? The money is there. It's just in different buckets right now. So how do you prioritize it into this bucket? Kamil, go ahead.
Okay, my problem with making let's say a singular space station is that you should not do something like the orbital reef, like Bezos is proposing. Not that I'm an enemy of space stations. No, I love space stations as when they have a purpose, and when they are designed and produced with the most, let's say, the best possible art, the level of the art that can be, with all securities, with shieldings, and so on and so forth. But imagine you're having an orbital reef. So you have a hotel, a testing prototype platform, and a manufacturing station at the all connected. They are all a one platform that has been segmented and so on. Do we forget about the problem of G jitter? The problem that vibrations and jumps from, for example, astronauts can actually disrupt microgravity manufacturing and microgravity experimentation. So, okay, if it's a factory, you have to actually, how do you call it? Not mute down, but
Tamp down.
Yeah, you have to damp the vibrations. Okay, that's your problem. That's all with the design and so forth. But if you're having a hotel, tell me about teenagers, YouTubers, any kind of streamers that go into a orbital hotel and they're, okay, you have to be quiet.
Be very, very quiet.
You can't jump, you can't have sex or party the hell.
Right.
No. It won't work. So I would go with multiple single-purpose stations, because some people actually would want to see better microgravity research in biotechnology, astrobiology, and so forth. Some would like to have something like Made in Space or Tetris Unlimited producing things, and just a business as usual production, and others would like to have all the fun they can have on a space station. And that way they don't actually damage each other, because everybody has their own experience. Everybody everybody pays for what they want. And if you're a biologist, and remember, we actually had the anniversary the anniversary of the Columbia disaster. Do you know how many life science experiments there were? There were the alpha interferon 2b biocrystals by it was Sherik Plow. Back then it was Sherik Plow. Today it's Merck. There were the urokinase biocrystals for cancer markers, which were recovered, but they have decayed in terrestrial gravity because they weren't stable enough. So imagine people actually having those kind of research being not destroyed because of a shuttle disaster or a tug disaster, any kind of accident, which can happen, but because some band of teenagers or students threw a party.
Right. So you're saying, okay, so take modularity that was discussed earlier, and really like drill into it, so that there was just announced a couple days ago that an organization wants to put a movie studio on orbit, a studio, not just show up because you're Tom Cruise, film a movie and then get out, but they want to build an actual entertainment studio. So there's one studio, then you've got a hotel, and then you've got a manufacturing wing.
Tell me, if there is a hotel, will there be sex work?
Yeah, we're going to move on from that topic right now, but
okay,
yes,
no, but I know, but
yeah.
that's the thing I always tell people. Yeah, right. If it's going to be a hotel, people will pay everything for this kind of experience. But do you remember Arthur C. Clarke's Islands in Space?
Yeah. Yep.
You remember the scene where they actually shot a movie in space?
Yep.
Yeah.
Yep. It's happening. Okay, so let's talk about money and production and finance and operations. George is talking about billions. We need a total commitment. As much as I admire the ethos of that request, so far humanity has not proven that they're good at that. So far, I remain optimistic. But the idea of a global program that people can work on together, contribute, whether it's companies or countries, I'm pretty enthusiastic about that. There's a great clip from a movie, the opening scene of I think it's called Valerian, the city of a thousand worlds or something like that, where the International Space Station grows and grows and grows and grows and grows and grows and grows, and aliens show up and grows some more, and more aliens show up, and they keep adding to it until it becomes a superstructure that becomes basically its own world. Valerian, yes, thanks, Kamil. Really fun movie, brilliant opening scene. It's findable on YouTube. I would show it, but if I did, we'd have some sort of copyright infringement on YouTube, and we wouldn't be able to show our videos. So I really recommend it. It's worth going out and looking for the opening credit scene of Valerian, because I think that's kind of the utopian version where we're all getting along and building something amazing. And I think the first few minutes are great because it's one country, and then you have another country, and then you have another country, and then you have another country, until all the countries are up there, and then an alien shows up, and now you've got a whole another crowd of people on the space station. So pretty fun movie. I would not call it technically accurate, but super fun to watch. All right, so money. We only have about 5 minutes left. I'm a little surprised this topic is a little on the quiet side. Does anybody have anything they'd like to kind of contribute? I don't think it's okay to say it's going to cost billions, the end. I think we have to do more than that. How much is too much? Let's flip it around. Let's pick an organization and say, that organization, whether it's a company or a country or a person, this is something they could do. And they won't do it if it's more than this, right? Is there an upper bound to it? For perspective, I believe the International Space Station is way north of $100 billion, way north, 140-ish. it's a giant number, and it goes up every year because of just management operation expenses. All right, so John's asking the question, how many people want to buy a home in space? I know the answer for Jacob. He'll tell his story tomorrow. The answer is yes, by the way. Yep, right. Yep. I'm really looking forward to your story, Jacob. That's gonna be pretty awesome. All right, so John's asking the question, how many people would buy it? And then you can't just say yes, George. How many would do it, and what's your price? Jacob, you'd better answer this one. How many would do it, and what's the price? And how much real estate do you want in cubic meters? So we're all using the same metrics.
My wife wants to come with me,
Okay.
and we have a dog and a cat, and they also should come with me.
A cat,
with
I'm
us.
telling you, the cat, it's key, right?
Exactly. So, and I'm living at the moment sort of in the middle of nowhere in a small farm, which is 100 years old. And I would like to take all of that with me. And so I need a lot of space. And I would like to leave my electric wheelchair at home, but I doubt whether that will be possible. But so I have quite a lot of requests for that. But coming back to the money, I think that if we do it correctly, if we do it in a commercial way, then we can do it in such a way that all the parties working together all can make money out of it. If you do it in a component-based as a service style of way, the way that I'm thinking about it in as a Minister of Manufacturing of Asgardia, the Space Nation, then we can all make profit, and then it will happen automatically because there's money to be made. I'm a very strong believer in that.
You dodged the question of how much you're willing to pay. So you're not answering that?
Well, I can.
It's okay. You can tell that tomorrow. You're gonna have some time tomorrow to go into a little bit more detail. But I don't want to like let you off the hook. Like, this is important questions. In order to build this stuff and it stop being fantasy, we have to actually start putting metrics into it. So,
well, if I were able to emigrate to space in 15 years from now, I would be willing and able to spend something like €1 million for that.
Okay, all right.
So that's real money.
€1 million of real money to get a wife, a dog, and a cat. How much cubic real estate is that? Like, and you want to bring your farm, so like put some metrics on that. I'm going to put you to the question tomorrow. I think this is really an important question. All right, cool. We're gonna switch gears and bring in Paul. Thanks a lot, Jacob. I appreciate that. I think that's heck, that's one of the reasons why we're doing this event in the first place, right? Is how do we evolve from, in America, it was The Right Stuff. That's the title of a pretty big documentary about the early days of the Apollo program. And it was about the mostly Air Force, Navy, and Marine Corps fighter pilots that had kind of proven capabilities that then translated into, quote, the right stuff to get to first get to orbit and then eventually get to the moon and back. And then over time, the right stuff evolved to that it wasn't about, ultra fit, small white men. And it evolved, in size, in gender, and culture. And that was because of the space station. It was, the space shuttle and eventually the space station. So the right stuff evolved quite a bit. And then most recently you had the oldest man, the oldest woman, an overweight, like a pretty substantially overweight 90-year-old man, You had the youngest person, 18 years old. So now the range is in astronauts, the range in astronauts is 19 to 90. And one of the people was a cancer survivor with a prosthetic leg. So the right stuff is changing. It's changing fast as a result. And if Nami and Pete are right about 200 to 500 people continuously living in orbit, that means thousands of astronauts have gone through the system. Not the 600 in the last 60 years, but thousands would be trainable, available to go to orbit. So that right stuff is changing. So I want to make sure that when we build this stuff, we're thinking about taking people. And I think one of the early markers is going to be, can we afford the luxury of bringing a cat or a dog? We can bring dogs too. Kidding. All right. Next, we're going to bring Paul Cheng to the table, sir. Please turn on your camera and let me get to your bio here. You know, this is really great. So we've had people from Alabama, Washington, D.C., Warsaw, Poland. Paul, I know you're in Canada, but I think it's Toronto, Canada.
Yeah, there. I picked Texas 2 hours away from there.
Okay, and then Jacob's in Amsterdam. So I love how we're starting to pull people from around the world to be a part of this kind of global adventure. I mean, I think that speaks to George's comment about how let's work together on this, right? So Paul is an MBA in economics and geology, is a retired international management consultant. Paul has an extensive background working for major exploration projects around the world. During his career, Paul managed 100 plus employees and budgets in excess of $30 million. He received 2 patents from the U.S. Patent and Trademark Office in advanced materials. It's called Fuse Ring. You'll hear about that a lot in a minute, and some additional patents pending. So Paul, really great to have you here. The screen is yours. Thanks for joining us.
Michael, guys, thank you very much for the time and the attention. Now, I don't have any of the cool stuff that you have in your office.
It's pretty cool. Don't sell it short.
But let me show you one thing.
Nice.
I bought this from an artist in Europe. Him and his wife were making small things, and I said, "Can you make something big? Just make something that what you like to make."
Right.
And so, anyways, I paid them in a bank draft, but they sent it back because their country does not accept paper money anymore. It's all electronic.
Right.
So then I had to pay him wire transfer, and then he sent this over, and these are my little toys. I have watched some of the videos on how the aspirations, the hotels in space, the different geometries, the big wheel, the big spoke. But if you look closely, how it's put together, the detail is really skimpy. And it's really just one video shows them pulling out a bunch of tubes out of a cylinder, and somehow expecting that to be the base of the spoke. And that we're sending a lot more material than we really need. And that's going to add to the weight and the cost. So maybe I'm wrong. But fuse ring technology works, and it is being used in deep sea and some of the automotive industries, but it's ultra secret. Nobody talks about it. I've got a bunch of patents on it. So I'm telling the world because I want this commercialized. The technique applies in vacuum and zero gravity. There's competing companies. I don't know if you can pull up what I just sent you a few minutes ago.
Sorry, I went on mute. Yes, I'll go look. Yep.
Okay, it draws up some of the diagrams that NASA is using right now. The most advanced Muzyka electron beam. But the problem is electron beam is not, there's issues to it. I don't want to disrespect any of the other current research, but there are issues. And all I'm saying is fusing is simplistic, it's simple, and it works. I did propose to NASA if we could send a demo weld unit to the ISS. But their question that came back to me was, have you done it before? Can you prove it? I said, well, I don't have zero gravity and I don't have vacuum facility. So, but the European Space Station, the European Space Agency did say, if you can make us the demo, even if it's small, we'll send it up for you, no charge. So that was very good, but that's a lower priority to me because the commercialization of this is longer term. So I'm focusing more on the commercial side. Like the wind towers and the submarines, the shipbuilding, these are the equalizers that we can bring jobs back that you mentioned earlier. Because the quality is automated and we can level out the playing field. Okay, one of the videos or pictures I sent is a Word document just to show.
Yep. Which one do you want? There's two.
If you could just show the simple one, the Earth, Moon, and
yep.
Just to set out why a space station makes sense. Great. So my push to this is, why are we lifting each individual load from flat Earth, from the ground to the moon, or from the moon to Mars, where we have to overcome gravity every time? 95% of the load is going to be fuel. But if we aim to build a space station, from Earth to space orbit is getting cheap and cheaper by the day. We can stock that up like a Frontier gas station, a Frontier supply station. Load it up, put the people up there, put the fuel up there, and have a bus that never lands. All it does is touch the orbiting station, load up, transport people to Moon or Mars, come back. And I think economically, I think Elon Musk mentioned that he might send 10,000 flights to Moon or to Mars to fill it up with what, 10,000 people or something like that.
Yeah, it's a giant number. That's kind of what I was referencing earlier about the Starship Singularity. So his goal is to have 3 flights a day. So basically 1,000 flights a year. And I think it's 100,000 tons. It's some giant number that's kind of mind-boggling. Somebody verify that it's 100,000 tons, if you don't mind. But it's a giant number. But it's 1,000 flights a year is his target. Yeah, it's so big. We don't even know what to do with it yet. So I'm excited about that.
Right, but if I may, as an amateur, I'm an oil and gas guy, so I don't know the finer details of finance or economics.
Right.
But if we can just cut the flights between, because the longest time is between the planets, and the most expensive part is the liftoff. And if we can take it in bite size, load up, the space station thing, we can cut the 10,000 flights down to 1,000 flights. Right, 1,000 flights to the station, and then maybe 10 flights to the long trip.
Yeah.
But that's building up the structure that we don't have that yet. And people did mention about money. A submarine is 2.2. This is public knowledge. It's no secret. They're in the billions. So the money is there. It just mattered, do we want to divert some money away from one branch of the government to another branch of the government?
Right.
That would be up to the people and Congress, I guess.
So let's talk about fuse ring. Let's talk about the technology. Let's talk about the actual nuts and bolts technology necessary to construct a space station, because that's not trivial. It's not easy. Before you jump into the space side of it, because I know that that's not your strength, talk about what fuse ring is, does, and some of the experiments that have already are the production systems. Do you want me to pull up that other slide yet, or do you want to wait on that?
Yep.
Okay. Let me stop sharing this. We have about 17 minutes.
I'll run through them really quick.
Sharing screen. Sorry, I told you I'm this broken arm of mine is so complicated in so many ways.
Just to fill in the time, one person said, I'll save $1 million, bring a wife and a dog. Let's put it the other way. It could be saving $1 million. I'll have to find a husband and a cat.
Right. All right, here's your screen.
Okay, this is just the what's NASA posting in last year, I think, in the internal studies. This is the electron beam. It's really the problem is radiation, and it is still 1 millimeter at a time. But I'll get into that. If we could pull up the PowerPoint or the PDF, Michael.
I don't believe I got a PDF.
I sent that on the link last night, I think.
All right, I'm gonna ask Fabio to hunt it down for me and post it. So that was in the speaker portal, sir?
Yes, sir.
Okay, so Fabio or Taylor, it's in the speaker portal. Can you go hunt it down? Paul and I are just gonna chat for a second. So Paul, let's talk about, because I don't think anybody on this call, anybody listening in the wilderness of the internet, knows the first darn thing about welding. So let's talk about welding first, and then let's talk about what makes fuse ring special.
Okay, the overall in high school, in junior high or whatever, we're taught when we weld two pipes together, you clamp this, you clamp this, leave a gap, fire up the heating torch, and put your stick in there, and just go one at a time, bzzz, like that. And when it's done, leave it alone, don't touch it. Let it cool. The problem is when it cools, it's got two heat affected zones, because molten metal, when it cools, rests against host metal, creates big crystals resting on small crystals.
Okay.
And then we have intergranular residual stress. That's universal in any metal in everywhere in the world. One guy 20 years ago came up with the concept. It's brilliant. He said, to back up one little bit, industry has tried to ameliorate, to fix that heat affected zone problem, but no success. They've incremental percentages. But this, and they've tried to heat the girth and then spin this thing really, really fast. And I wouldn't stand near that thing for 10 miles, because when it breaks, it would just kill a whole lot of people. That's why industry never adopted it. This fellow says, put a heating paddle between the work faces in an inert environment. Pull the paddle out, push the steel together, and rotate slowly. All it is really slow. It's like wet bubble gum. When you have bubble gum and you pull it out, you stick it together, it sticks. That's what the concept is, in essence. So when you push it together and you rotate, you break the crystals down. The crystals might be trying to form big crystals, but by motion, it shears it apart. There it is. I'll just run through this in a hurry.
Okay.
If we can go slide next. So this is the picture that I presented to SME in 2020.
Yep.
How to build a space station. Next. So the bottom few words says, how do we actually assemble a large structure in space on Mars? Option might be prefabricated parts that clip, bolt, glue, or Velcro in place. Next. So welding structure offers strength and rigidity. Welding in vacuum and zero gravity offers challenges, but there are options. Techniques are fast, works for thick and dissimilar materials, but crystalline structure is an issue, like we talked about the heat affected zone. K-TIG is a big proponent, but they have their issues. They have the problem because they need gravity to work. So I've spoken to them and they say, yeah, that's a problem. So we're not pursuing that market. Next.
Yeah, let's stick with that for a second. It needs gravity to work. There are so many chemical industrial processes that we completely take for granted that take gravity to work. Yeah.
Another
issue. I love this.
Sorry, go ahead.
No, go ahead.
Another technique would be the friction stir, but so far it's only been aluminum and fairly thin material. But this is a crystalline structure, so there are still some issues with that. Next. But this is what we can offer. This is a crystalline structure. This is the profile of this solid state technique. Smooth, there's no fusion line, and the crystal structure right from base metal to base metal is one characteristics. No coarse grain, no stress risers. Next.
Yeah, that's for the rest of the audience. It was this moment that was kind of the wow moment because this is really hard to do. This is really hard to do.
And so this is another finer details of it. Left side is the base grain. The bottom left is the middle of the heat transition zone. And the bottom right is the recrystallized zone. Now, if I may say, the Russians, the Chinese, the Koreans don't have this ability. They're aware of it, but I really don't want to put this on a silver platter and hand it off to the foreign competition. So I would like to build it here, but I tell you, it's really tough pushing new technology at home. So my Vaseline jar to kiss is getting dry. Next. So this is the hardness mapping. Traditional, all of weldings today, they have the two heat affected zone, the softness, where the metals melt and join the host metal. They're soft because they lose all characteristics of the host material. Every one of them. But this technique, we don't ever melt. We don't reach there. So our crystalline structure and the hardness mapping is much more homogeneous. Significant.
Paul, I got to break in. I don't really understand what I'm looking at. Is this bulge here the welded part? And so the red in the middle is
mapping data.
That's harder?
No, the university just went and poked a whole bunch of stuff and say, here's a hardness mapping of it.
Okay.
So then it says where it joins traditionally, where it's softer, we're actually slightly harder.
That's what I was thinking. So the red indicates that it is stronger at the weld, not weaker at the weld.
But the important thing is on either side of the red,
yep,
traditional technology, every one of them, those numbers drop significantly.
Okay, cool.
But this technique, the numbers either side of the weld doesn't drop. It's even and rises slightly.
Okay.
Next.
That's cool.
Yeah. So this is the grain flow. If you put acid and just, show me what it looks like visually, this is what this technique looks like. The grain flow is even. And you'll see the significance with the next slide. The top one is 1/8, middle one is 3/8, and the bottom one is 1/2 inch. It works for all. There's no fusion area where you can say, here's where it touched. There's none. That's significant. Next. So these are the X-rays and they all pass. We can skip the next three, please. So this is just a tubular, next please. Okay, now traditional welding is 1 millimeter at a time. There's a beginning and an end because it's one at a time. There's time and there's uncertainty. That's the biggest issue. We don't know what the quality is until after we examine by X-ray or phased array or anything. We don't know because it depends on the welder, on the machine, Monday at 8 o'clock or Friday at 4 p.m.
Right.
There's a difference, especially when you come to thick material. It's still an art. There is the heat affected zone and how do you repair it? That's the biggest thing. Inspecting welds is one of the biggest industries today in the world. It's not the repair, it's not the welding, it's the inspection. Next. So would like to introduce this type of a weld invented by a gentleman named David Lingenau 20 years ago. Brilliant, but the patent's expired. Here's what he offers. The OD and the ID are mirror images. Next. So this was his prototype many, many years ago. So he's got the one part stationary, a heating paddle in an inert environment, pull it out, push the other part in, next slide, and rotate. And next. So this is a fine grain structure for the people who aren't welding people, and neither am I, I'm no expert. But this is pretty good. When I saw this weld, I gave him a whole bunch of money, but the money's gone now. So that's where it goes. Next. So this is another further refinement from University of Waterloo of the grain structure. So it's not just me. Next, please. This is important. Across the grain structure, this is available on the LinkedIn post, I think. This is what the fine part looks like. No one else can replicate that right now in the world. This technology delivers that. Just take my word, and because it is darn good. Next. And these are the mechanical properties. They all break at the base. Next. And these are the finer details of it. There's a slight variation because we don't have enough big samples. There's only 3 samples that we tried, but we'll have to produce and emulate, test many, many more, hundreds more. Next. So now this is something significant. I will ask the audience on the top right corner of this picture. This was done by EWI, Edison Welding Institute. It's a third party. In 2012, they did the analysis and it's fabulous. But tell me what you see on the top right slide. Something is significantly, fundamentally different.
I don't have enough experience to know what I'm looking at.
No worries, neither did I until somebody told me. It is ovality, high-low. Industry is very sensitive to whether the steel or the metal or the aluminum or the titanium matches. And 9.5 out of 10.
Oh,
they
right.
never match exactly. Exactly.
Okay. All right. I
So
see it.
with
It's off
nylon
balance.
weld, it is forgiving because you melt and you just kind of, the puddles level out. But this technique also is forgiving. So it could be mismatched slightly and it still comes out smooth. That is different. So one nuclear group asked me, well, for a 6-inch pipe, if we're out by half an inch, what are you going to do? I says, well, sir, for nuclear, for 6-inch OD pipe and you're out by half an inch, you should send a lot back. It shouldn't. If it's 48-inch and you're out by an eighth, okay. Because the ovality, the in pipeline, the steel has some movement. Now the bottom right are 2 cylinders for Mercedes Daimler Chrysler. The bottom left slide, they wanted to use something like this. They wanted to, they want higher pressure and higher temperature per stroke. But when you put higher pressure and higher temperature, the heads warp in diesel.
Okay.
So they says, let's put a cooling chamber in between underneath the cylinder head. But how do you weld one cylinder inside another? So they did the Russian method. They spun this thing really, really fast and shoved it in. But the problem is, tell me.
Warp? Did it warp?
Nope, nope, the curls.
Okay.
You see the curls? They break like this.
Yep, I see it.
So then that disturbs the fluid flow. And so they tried this solid state method. And so the profile is smooth. That's the first in the world also. And that won a PACE award for the automotive in 2016. Next.
And it's this kind of innovative stuff that is necessary for orbit.
These are groundbreaking world-class technologies, Michael.
Yeah.
No question. But the more I tell people, the more people say, holy geez, who the hell are you? What is this thing here? So, and they're saying, come talk to us, kid. So this is evaluation by EWI, ultra high quality, true solid state, blah, blah, blah. Next. Technology and economically, it is the most scalable of one shot. And the bottom line says, machine cost is very competitive with friction inertia welding machine of comparable capacity. Today's technology for the automotive and the aerospace, we can only friction weld certain amount of size. And as you all know, the blades on the titanium blade repairs, the maximum is only a certain amount. I'm not going to say the number, but there's only a few manufacturers that can make that machine. The significance here is our power consumption is 90% less.
Wow.
So we can either make it 10 times bigger or power consumption is much less. So I'll be presenting that in California in March, because we will be in direct competition with current friction inertia welders. And that applies to space also. Our consumption is much, much less. Next. So going back to the basics, as mentioned before, one part stationary, the other part is heated up, push, rotate in an inert environment. And this works for pipeline tie-ins and a whole bunch of other areas, especially for nuclear reactors, because for the feeder tubes going into the manifold and the feeder tube to feeder tube, there's a lot of issues, and we can offer a significant advantage. Next, please. So basically, the fuse ring concept is, because when you have one part stationary, the other part rotates, when you come to the end of the pipeline or for the feeder tubes into a manifold in a nuclear reactor, how do you rotate the pipe and how do you rotate the manifold? You can't rotate either.
No, right.
What do? Tell me.
You fuse it. What do you mean?
You put a coupler in between.
Yeah.
And you heat both work faces at the same time. Take the paddles out. You rotate the coupler and you push both ends in. That's the patent.
Yeah, that's crazy. Okay.
And from that, I've applied a whole bunch of other stuff behind that. Next, please. So fundamentally, the top is the one stationary, the other one push and rotate. The bottom and my fuse ring invention, IP number 1 was granted 2017. And second one was 2019, and there's a whole bunch of other stuff now. So is the coupler in between, rotate the coupler, push the two ends in.
That makes sense.
And we can use that for dissimilar materials in automotive, in shipbuilding. It applies to a whole bunch of other stuff. Next. And we can make it flat. So this applies to the pharmaceutical, because stainless, getting the inside weld perfect is a big, big issue, because they cannot afford to have any crevices. So this application says we can bevel the pre-bevel it before we heat it, push it together, and it'll come out flat. So we can regulate the ID to be flat or a bulge, but it'll be smooth. So for the pharmaceutical and food industry, we can make a big difference to their cost when they manufacture plants. You see what I'm saying?
I do, yes. Yep.
Next, please. So for refineries and a whole bunch of other industrial applications, we're still using manual wells, like for shipbuilding and refineries and different areas. We can make them automated. Next, please. For space, this is the interesting part. We can use this technique for three-dimensional structures.
Right. You just described the system for connecting flow pipes into a reactor. It's the same basic idea, just scaled up.
Yes, sir.
But the same complexity of systems.
Right. But we offer a better weld. It'll be aluminum or maybe titanium. I don't know.
Right.
It'll be a different regime in heat and power requirements, but the technology is there. And the other IPs is the space station tubing is going to be pretty big. We cannot rotate 8-meter wide tubing. The power requirements would be huge, but the thought is we can break them up in segments, Michael. We can weld small parts of it, but how to join it together, that's the other concept, but it can be done.
Yep.
And we're talking to the wind tower people right now because their problem is now the biggest one is 8 meters by about 2 inches thick wall for the offshore towers.
Let's let that sink in for a second. At 25 feet across with a 2-inch wide seal basically to the ground. Like that's the size of construction you're talking about. Yep.
Right.
That is a functional system that exists in the world right now. And we take that basic idea and export it to the sky.
We can.
Yep.
But the wind people have problems. They says, forget the 8 meters, we're going 12 meters. And it's going to be 4 inches wide. So joining those is big headaches for them. And we have a solution. But anyways, we're getting off the topic here.
No, I think that's really awesome, actually. Like that kind of big construction's neat.
It's not easy. Joining, like welding 1/2 inch, 1 inch is a science.
Yeah.
It's automated. But anytime you go beyond 1.5 to 2 inch, it's still an art. So you still depend on the person and the mechanical setups and all that. And I like to eliminate all that and make it automated. This chart is something different. There's no PhD studies to back it up. But my push is on the chart to the left, it's a time temperature chart that shows where crystals form at temperature where they dropped.
Mm-hmm.
And I say that is a static diagram. And fuse ring is proving that that diagram is not static. Crystalline formation is dynamic because once you add a shear component to it, the crystals form in an envelope, not a flat spot.
So I want to point out, because we got to move on to the next speakers, that part is a big deal. And when we look at the next speakers and what they've accomplished, just kind of remember this this time temperature graph when we're looking at the next speaker. So because it's relevant, right? It's relevant.
That's all I have, Michael. Thank you.
Thank you so much, Paul. Really interesting stuff. It's one of those industrial problems that when you're building little stations, maybe you probably wouldn't encounter it, or not in the same way. But if we're going to build big things, we have to start thinking differently. So thanks a lot, Paul. Really appreciate it. We're going to bring on our next speakers. Terrific talking to you. And we'll talk again next week. All right. Thank you, sir. All right, y'all. Gary, Troy, really glad you're here. Krystal, sorry about the miscommunication on the times today, but I'm glad everybody was able to kind of ad hoc adjust.
I'm glad you guys could be flexible. Appreciate that, Michael.
You have been amazing over those last almost 3 months of this chaos, but really appreciate your support. I know you a little bit. I don't know Troy or Krystal at all. I'm not even sure whether I have bios for Troy or Krystal. So let's start there. Do I have bios? Does anybody know? Okay. Then I'm going to let y'all just introduce yourselves. I'll read Gary's, but it feels awkward reading his and only his. All right, so here's Gary's, and I'm sorry, y'all, but you're going to have to fill in the blanks when I'm done with this. Gary Calnan, certified financial analyst, is a co-founder and CEO of Cislunar Industries, a space technology startup focused on developing, building, and operating distributed on-orbit metal processing and space debris recycling facilities. With their industry partners, Cislunar Industries is revolutionizing the economics of space debris removal by transforming this costly cleanup effort into a massive self-sustaining economic opportunity. By treating space debris as a space resource, Gary aims to accelerate the development of a vibrant, diverse, and commercially driven in-space economy. Thanks a lot, Gary. Really appreciate it. And could you please introduce your friends?
Yeah, we've got, thanks for that, Michael. I don't know, I'll let them give their own bios, but we've got Troy Morris from KMI, one of the co-founders, and Krystal Skordo from Astroscale. And I've got a little recording from Newman Space as well, since they couldn't join today. So, because
it's the middle of the night in Australia and they're busy. They have a different project. Do you want to talk about why Newman can't actually be here despite the time zone, because they have something else exciting going on?
Yeah, today I think in a few hours anyway, there's going to be a conference that starts that ISU is running, International Space University, and some other partners down there with it's all about space debris. I know that Astroscale has someone at that conference as well, I think, at least one person anyway. And some of our other people are, Newman Space is going to be there as well. So. So you guys, I don't know who wants to go first. Troy, you want to go first, I guess? You unmuted yourself first, so.
No, easy way to decide. No, it's exciting to be here. So I'm Troy Morris. Like Gary said, I'm one of the co-founders for Call Morris Inc., or KMI. And we are a small space startup based in Marquette, Michigan, way up in the Upper Peninsula, if you know it. But our company is focused on orbital debris research and solution development, really focused on the active debris removal and kind of that final kilometer question of how do you characterize and then capture these unprepared, uncontrolled objects. There's wonderful work going on throughout the industry, Astroscale being one of the leaders in it, for objects that we're setting up now. And so I won't steal their thunder, but we started to recognize if we're taking active solutions for preventing new debris or controlling debris that goes up there now, we started to shift our focus for how do we deal with those legacy assets, the objects, the rocket bodies that have been up there for decades, that no one was thinking about when they launched them. Space is huge. What do we deal with? So I'll talk about that more later, but my background is in operations, business development, and I'm just very excited to be here and share a little bit of our story today.
Thanks, Trey.
All right. Hi, everybody. My name is Krystal Skordo, and I'm the head of marketing and communications for Astroscale US. Astroscale US is about 2.5 years old now. We're based in Denver, Colorado. So I'm joining you live from Denver today, and really excited to be here to teach you a little bit more about space sustainability, why recycling in space matters, what the problem is, and to share a little bit more about our company and the technology solutions we're offering to help solve this problem.
Thanks, Krystal.
Yeah, thank you.
And I just also say that when Michael suggested that I could present at this event today, I thought about how we could bring together some of the players that are in the value chain to kind of show how this is happening, and so both KMI and Astroscale are two of those players in the transportation piece of the value chain, and we'll talk about some of the other companies that are out there that are helping to make the whole thing happen. But yeah, so I'm just grateful to have you guys here. Thanks. Are you muted, Mike?
2.5 years into this, and I still can't remember. Yeah. So y'all, I want to kind of lay a little bit of groundwork in that first, my relationship with Gary. We're both space nerds from International Space University, but we went to different classes. And somewhere along the line, maybe 3 years ago, 2.5 years ago, you started talking about this idea of a furnace on orbit, and
Late 2017.
Yeah, okay, longer than that. Good, 2017. Wow.
I
So
know.
let's start there, kind of the genesis and kind of how you got to here, and then we'll bring in Krystal and Troy as kind of the story evolves, right? Because
okay, yeah, I have some slides that we can run through if you want. It kind of follows some similar story. I don't know if it starts with the origin story per se, more sets up the situation, but we can. Is that okay if I go through the slides and then we can kind of dive into this stuff? All right.
Yeah, terrific. Yep.
Let me pop that up there then. Let's see. Let's get the sharing.
And just so y'all know, there's been a fair amount of conversation earlier in the day about laws, rights, treaties regarding all of this chaos that's in the sky. So that kind of set the stage for today.
Cool. Yeah, perfect. All right, let me do this as well, and hopefully the video will play through screen. Oh, that's not the view I wanted. Let's see. How do I switch? You guys are seeing the wrong screen.
Presenter slide. You want to switch to the other one. If you have two screens, it's easier to do it on.
I can. Yeah, I have two screens. I can just change the screen that it's referencing, I guess. Let's
Correct.
see. Where's the? How do I exit the screen sharing? Oh, there we go. I move these things around too much. Okay. Stop share. Share screen.
While we're doing that,
There you go.
John is posting that there's a 6,000-pound rocket crashing into the moon. That is a
today?
story. That is a story that is circulating around the internet because it's very sensational, but it's kind of a trivial non-story to most of the rest of us. However, it would be really cool if we could have grabbed that thing. Keep that in mind when Gary, Krystal, and Troy talk about what they're doing. So
Exactly.
we all think it's a missed resource, but it's not an actual problem.
That's right. Yeah, and it's it's sensational because it's the moon. You know, people are like, "Oh my God, you're going to crash garbage into the moon." It sounds bad, but like you said, it sounds worse than it really is in reality. But I mean, in fact, I think didn't we crash an upper stage into the moon to figure out that there was water on the moon?
There's water on it, yeah.
That was how we discovered there was water on the moon. That was part of the mission.
For some.
Yeah. So as I said, I brought this group together because we represent part of that value chain for what we see as space debris recycling ecosystem. But before we get into that, I just want to I know I'm kind of speaking to the choir a little bit here, but this will be on the recorded for posterity, and for those in the audience for now or in the future who aren't thinking about this whole backdrop, I think it's helpful. So at Cislunar Industries, we really see that there is a new industrial revolution happening already in space. It's just getting started. It's kind of like the internet in the mid 90s, but it's happening. And as this emerges, and it's not just happening in one place, it's happening all across all segments of the in-space industrial value chain. And we really think that this is very significant because that capability, that industrial revolution, is going to be what enables humanity to move in a sustainable way beyond Earth. And I think that is what leads to a future of abundance for humanity. So, we think this is very important. As with everything on Earth in the Industrial Revolution here, metal has been key, and it will be key in space as well. If you look at any technology you have, there's metal in it somewhere. So, it's going to be a critical resource. And it turns out that metal is very abundant in space. But whether it's in orbit in the form of space debris or in asteroids or on the surface of the moon and other planetary bodies, it's very, very abundant. But it needs to be processed and turned into something to be useful. But nevertheless, we also have this problem sort of standing in our way. It could be an existential problem to maybe not to humanity's existence, but certainly to our way of life, and that is space debris. And we see it as there's a lot of cool solutions that are happening that people are working on right now, but really we need some solutions that are truly sustainable. And from our point of view, true sustainability needs to be economically sustainable. And as we're seeing a huge amount of space debris already up there, we're also seeing plans for tremendous amount of space debris growing into the future, not space debris, but satellites going into space. And many of these satellites will be equipped, for removal. But some of them will die as soon as they get there. And the more crowded it gets, the more dangerous this debris that's already up there becomes. So we're seeing, based on current plans, the satellite population should increase by an order of magnitude or more. And this will drive demand for end-of-life removal. But it'll also add this risk from the space debris that's up there already. So we've got this, exponentially growing problem. We're adding to it because we want to use space more. And we need to find a solution that sort of scales to meet the challenge. So the way we see that changing, the way we want to shift the debate on this. I mean, right now, when we think about space debris, it's generally thought of as a tragedy of the commons. And if I go back just a couple of slides, to this looks like a tragedy of the commons. Like who's responsible for cleaning up, all the debris that's up there already? It's a bit like the plastic that's in the ocean, right? There's not a lot of economic incentive right now to clean this up. Now there are some, and the more crowded it gets, the more those cases grow, right? But what we're seeing is if we can transform that and sort of challenge the notion of the tragedy of the commons being our mindset, the position we come from, and start looking at space debris as a resource, because it does compose a large amount of metal and other materials that are already refined, and we can use them. They're already up there. We spend a lot of energy to get them up there. And if we can look at it that way, then we can completely transform the economics of space debris. We take it from a tragedy of the commons we have trouble finding ways to pay for. And if we do find ways to pay for them, they're probably government-driven solutions that may not be sustainable and probably won't scale naturally. And we turn it into an opportunity. And so we looked at upper stages, for example. When we first started this idea, we looked at this, and in LEO, I've got the stats up here. You can see them for yourself, but there's, over 1.3 million kilograms of metal just in the upper stages. We look at upper stages because they're, mostly metal. They're kind of simpler targets to go after. They're also large. So you get a lot of bang for your buck in terms of the operations. But if you apply a valuation to these between $1,000 and $5,000 per kilogram, sort of thinking about how much it costs to launch to LEO, this is $1 billion to $5 billion resource right now. In GEO, you've got less that's in this sort of accessible circular orbits, but it's still almost 500,000 kilograms of mass in the upper stages. And that, for the higher costs to get to GEO, that could be worth $4 to $6 billion. And that's just the beginning, right? That's the stuff that's already up there. If we approach the mega constellations that are going up, that creates a whole nother set of value. And it creates an ongoing flow of materials that we can use and divert from being deorbited and re-entering the atmosphere and use to create materials for space. So how are we doing that? Well, we are making what we're calling the microspace foundry. And the idea here is that we build a small scale device that is sort of platform agnostic. It can be added together to scale production and throughput to match the demand that you need wherever you need it. It can be located in multiple orbits. And that's why when Michael introduced me, in my bio, we have this concept of a distributed metal processing capability. In LEO especially, it will be all over the place in a variety of different orbits on different platforms that can host this capability. And it allows for us to make two key things. categories of things, I guess. One is metal propellant, which it creates an interesting opportunity from the reducing the cost of the removal mission, and it makes products for more what you might think of as the products for metal, industrial metal materials. And we just want to make the simple stuff to feed into other manufacturing companies like wire for 3D printing, sheet metal, rods, tubes, that sort of stuff. And we can do this on the moon too. So this is also feeding forward to future potential as well. But as I said, this is platform agnostic. We can use it anywhere. And we've already started building some of this technology. And now what I'm going to show you in the next slide is kind of how this metal propellant really changes the architecture. And that also is where Newman Space comes in, because they build the propulsion system that can use these metal propellant rods that we can make from melted space debris. So we conceived of this architecture a long time ago with our own platform, but as technology has advanced and we've sort of shifted to this smaller scale version, now it's great because now we can rely on partners to do all these other pieces of the puzzle. So we got KMI and Astroscale here. They're two of the companies, but there are many others that are trying to build spacecraft that can be used for transportation in space, either for transporting space debris or other goods. And we would set it up such that we have a platform, that's where we can host these materials. This is what I think of as the real estate in space. We're not building the real estate, we're just building the processing plant. That is, in the middle here. And then we've got, I guess you're on this screen, in the middle here. And then we've got, and this is like, I've got Nanorax, Axiom, Orbital, Reef. Those are just some of the many companies that are trying to build commercial stations. We'll talk about that later a little bit more. Then we have spacecraft going out to retrieve the debris. They leave, and ideally they're using the Newman thruster for their primary propulsion. And in that way, we can fill them up at the station. They go out and get the debris, they bring it back. We convert just a fraction of that debris into materials that can be used to refuel these spacecraft, enough to go out and get the next one. And then they come back, and the rest of the material can be used for making those other industrial building materials, or even salvaging some of the stuff that's on there, like solar panels and other materials that might be able to be salvaged for future use. And so there's a couple companies we mentioned, but one of the key points here is, okay, we got this architecture, but our system is not really useful without all of the other pieces of the puzzle being there. And this is just the tip of the iceberg, these companies that I have here, but I'm just highlighting several companies out there right now that are, moving the ball forward in a variety of areas that are required to create this industrial economy in space. And we see ourselves collaborating with all of them in different ways. We're either supplying them with materials or propellant. The stations we can supply with propellant for station keeping, they're hosting us, so we're a customer of theirs. It's very circular, and exactly how an economy works, right? We sell things to them, they sell things to us. They sell things to each other, and now we have an in-space economy that's actually broad and diverse, and can actually build this future that we all want to see. I mean, at the end of the day, what we're seeing right now is an opportunity presented by space debris to really take, and this kind of comes back to the title of the whole thing, this talk, to really take space debris, turn it into a resource by recycling it, turning it into propellant, which can fuel the removal of the debris itself, turning it into building materials, which can be fed downstream to build this in-space economy that we're all aiming for, and catalyze a whole host of industries along that chain. It's not just the real estate and the trucks that are going out to get them, but it's also the robotics and the communications and really everything that's needed for that, the whole OSAM market and all the other tertiary, secondary markets that relate to that. This could accelerate the whole thing. And if we commit to this path of this approach on a national level, from a funding and policy position and as an industrial level, I think we can move things forward even faster. And that just accelerates us all the way out to the moon and beyond. So that's this is an ecosystem chart to show some of the companies that are operating there and some of the government agencies that are supporting it. So then the next thing I'm going to show you is just kind of how we've gotten to where we are so far. So this is getting back into the story, right? We started this idea back in 2017 originally, and it was a bit early. You didn't have all these other capabilities becoming plausible in the near term. and also NASA wasn't really that concerned with space debris or recycling it. It wasn't something that they were going to be paying for. But in 2020, a call came out for NASA SBIR in the solicitation, a subtopic that was specifically around recycling outside metal scavenged from large objects outside of the space station. And we're like, holy crap, this is exactly what we've been talking about for 3 years. So we jumped on that. We got one of the awards, and we went from, this concept and, dirty maker's garage. Our CTO has this awesome garage that he had all this cool stuff in. But he converted it into our lab. So we have a lab up in Fort Collins. We call it a garage lab. It's his garage. That's now our lab. We were able to take that concept over 6 months and turn it into a working prototype, which we demoed in October in a live demonstration with Astroscale, NanoRacks, ourselves, and Newman Space. I'll show you sort of the setup for that. I can show you a little bit of video from that. I don't have, short cut off the whole thing. It was about an hour and 15 minutes in total, but, and that is online if you ever want to see it. It's pretty cool. But what we showed is, Astroscale showed how they're able to go get the debris. NanoRacks showed how they can host our capability on their platform. They showed some cutting techniques. We showed the live demonstration of making a rod. And then Newman Space showed one of our rods being used in their propulsion system, making plasma propulsion. And so I'll just show you a little bit of the demonstration itself so you can get a sense of what it looked like, at least the parts going from our demonstration and then being used in the Newman thruster. I think I have it on the next one here. Well, it's a little setup first, I guess. So the way we set up this demonstration, we wanted to create a system that was semi-automatic rod making machine that would be similar to what we might be able to do on orbit. So we used an aluminum strip that is meant to represent a piece that we would cut off of, say, an upper stage. And it's just a 6061 aluminum. It's pretty standard sort of aluminum alloy. And then we fed this down with a roller, and it's all programmed, with this software program that the team wrote, which once he sets the button to say go and the size of the rod we want to make, it sort of senses where the rod is in the process, or the ribbon is in the process, and how much has been made to finish the process off automatically. You've got an induction coil here that are in the middle here that processes that melts the aluminum, and the cylinders, the molds are made out of boron nitride, and sort of a two-part mold. So you have this bottom piece that sort of forms the floor of the mold, and then later this will move up to push out the rod, so you can kind of see how that works. And we had a couple of different setups here to show how we could make 3 different rods, and we made one in the person, had another one that was already made. So I'll show you how that looks in action here. Oh, this is sort of the screen that people saw when they were watching. You have different views of the process. The thermal view on the upper left, you have a top-down view on the upper right, side view on the bottom, and then sort of the computer program on the bottom left. Now let's see if this works. Let's see, which one do I want to? There we go. So I'm going to just talk over it. So we're casting aluminum rod. This is 4 times speed. It took about a little bit less than 4 minutes. So we were sort of, you can see it warming up already. It was just turned on. It's feeding the aluminum in. You can kind of see that here. I'm showing that I'm getting low system resources, so hopefully you're still seeing this, but it's feeding it in. You can kind of see it getting silver at the top there. And as it's feeding in, this at the bottom, you can see there's the platform kind of lowers down. So we're filling it up and moving the platform down. So the top of the melt is always in the middle of the coil. And so as that goes, you can see it getting red hot up here. And now on the bottom left, you can kind of see the wattage that's being used and some of the other details. And of course, you can see how it's getting super hot, in the thermal view. And in the upper right, you can see me walking around too, I guess. So soon here, I think it's going to get to the point where we can, well, you can even see actually the mold itself getting a little bit colored from the heat. Okay, so now we're gonna retract the ribbon. So once you've made the whole process and filled it up, we pull the ribbon out. That was pulled out like that. And then we'll rotate this around momentarily here. Oh, actually, I forgot about this part. So then we actually did a little bit of mixing. So what you can do is kind of pulse the frequency and the, you know, how it's working, and you can see how it kind of shimmers in the screen here. We think we can use that for mixing. So that's kind of the idea there. And it's sort of pushing it up, squeezing it together, showing how the electromagnetic fields kind of force it together, showing how that can be influenced. We're zooming into it so you can see a little bit better how that's being done. And now we're in a rotate position. So we lower the platform, and then this kind of rotates around to a next one so we can make another one. And then we've got a one that was already made in the other one that's in the position for ejection. So over here on the upper left in this top corner part, you can see it coming out. On the bottom, you can see it from the side coming out. And so we just kind of grabbed it with our sort of robot tongs. And then we moved to this demo of this of the Cislunar, or of our rod in the Newman space propulsion system. So they put it in this test stand. They had it in an acrylic box. They were able to fire it up live in front of the audience. They had some people on site in Australia where they fired this up. And after I'm done, I'll play a little video of theirs that shows, you know, more about their company, briefly anyway. But so it was pretty cool. We got to show how it actually, you know, it's hard to see, but they pause it at the end here. So you can see this blue plasma pulse, and each pulse creates a little bit of thrust. It's electric propulsion system, so it's low thrust, but very high ISP. I think aluminum is estimated to, but from the lab work, it was around 2000 ISP, so it's pretty efficient. That's a demo video. Let me see, next slide here. Oops, it's playing again. Okay. So where is that taking us now? That was the demo that we did back in October. This is showing some renderings of how we see this evolving as we move into the future. So the way the MSF will work, we imagine a modular setup. So we have a base system that does the melting, and then we have different modules that attach to it. And this is only a few of the ones we have in mind, but we have the rod making module, we have the tube making module, we have a wire maker, and you can see these on our website too if you're curious, but same information. Some key points here: it's meant to use less than 1 kilowatt of power, so it doesn't use that much power. This is one of the questions we get: doesn't it take a lot of power? We can do this with solar. It should work. We want to do it for less than 100 kilograms, and actually I think it's going to be maybe quite a bit less than that for this base unit, but this is what we're aiming for. And sort of filling the space of, like, this one's basically 5U in lengthwise. It's 50 by 10 by 10 for this base piece. And then you add on more, you know, size, of course, for the different attachments. From where we are today, where we're headed with this design. Oops, let me skip. No, there we go. Okay. Yeah, so we see ourselves, we're in this pre-seed fundraising stage. We have gotten through our NASA SBIR phase 1 very successfully. They're very happy with it. We think we've got a good shot of getting to phase 2. We'll find out in a couple of weeks. And then, you know, we're also proposing to a number of other solicitations that are out there from Space Force and also new NASA ones. But we hope to do a parabolic flight by the end of this year, and then maybe a little bit into the beginning of next year, depending on the timing. And really, we're aiming for an on-orbit flight demo by late 23, early 24, and there's opportunities to do that in the Bishop airlock on the space station. We hope to be doing recycling, actual commercial recycling, by the middle of this decade. So this is 25 timeframe. And if all goes to plan, we'll even be trying to do a lunar demonstration also around that time frame. So maybe 1 year later or so. But it kind of always gets speculative as you move out. But we see this kind of building up in those markets and really, developing it from there and being a major supplier of materials both in space and on the moon, eventually out at the asteroids and beyond. So that's the roadmap. I think that was the main thing I wanted to cover with us. And I've got this slide that we can show this later, Michael, if you want to have sort of a backdrop for some of this stuff. It's up to you. But this is kind of some of our overview. I have the Newman slide, Newman space thing that I can show next, and then we can hand it off to the other guys to talk about their pieces of the puzzle that works. Are you all able to hear me? Because I'm getting low system resources, so I don't know if I'm getting bad sound quality.
We're hearing you.
We're good. You're 5x5 on this end.
Great.
By the way, do you know Peter Garretson, who's on this call?
I don't know if I've spoken with him much, but we've certainly been on calls together.
Okay, so he would like access to your charts. I think more importantly, y'all should just chat for a minute.
Yeah.
So I'm gonna send you his email address.
Sounds good. I think we've tried to connect before, but I don't think we've actually had a lengthy conversation yet. All right, I'll show the Namespace one. There's sound to this. I don't know if the sound works the way that this is set up. If there's a setting or something that you guys have to do on your end, but let me know if it doesn't work, because you'll be missing some of it if it doesn't. So let's try this. Can you hear that?
No.
No. Okay. Let me see if there's a. Maybe if I turn it up, it'll go through my microphone, but that's not going to be very good. Let me see. Oh, share sound. I found it. Try this now.
At Neumann Space, our team of engineers designs, builds, and tests the complete propulsion system comprising the thruster unit, power processing unit, and software. We have tested our patented technology using solid metallic propellant rods such as magnesium, vanadium, and molybdenum, all cast on Earth, until we received out of this world Cislunar Industries aluminium 6061 rods cast in vacuum. Using these propellant rods in our thruster, we forged the first link of the in-space recycling value chain. To prove thrust, we fitted a Cislunar rod in Neumann Space first practical demonstration hardware. We used a torsional pendulum thrust balance developed in collaboration with the Australian Department of Defence DST group. After pumping down to reach LEO pressures, we initiate the firing sequence. Firing. The damped oscillation showing on the display monitor is proof of thrust generated from the Cislunar propellant, as is the flash of plasma visible through the steel vacuum chamber viewport. To better showcase plasma generation, we used a molybdenum rod in an acrylic vacuum chamber. And for clarity, paused on the one frame capturing the plasma plume. New propellant sources shall soon be available on orbit for the Neumann Space Thruster.
So that's the Newman Space guys. The acrylic thing that you saw in the previous video from our demo was the actual rod, our actual rod being used in their machine. That was recorded prior to doing that. So that was a new piece of it at that point in time. But these guys are making interesting progress with their device. They're going to be flying a demonstration version of their system in orbit on a satellite, I think by the end of this year, with a bunch of other Australian payloads doing sort of this experimental system. And that one is designed for CubeSats. It's not meant to be refueled, but it will show us that, yes, it can work in space, and yes, it can make the propulsion that we expect. And then, we'll be testing it with our stuff as we move forward. So yeah, but these guys are, they're great, and they're making amazing progress. And we look forward to deepening our partnership with them. We're sort of the way we look at it is we're kind of like the oil companies making the gas, and they're the combustion engine. We sort of need each other to to make that piece of the puzzle work, right? So there's some interesting opportunities to carry that idea even further. But let me see if there's anything else that we wanted to cover and escape from this. See my background. Yeah, I think that was what I was planning to share today, and I think with the time we'll hand it over to the rest of the team. So I had in mind that KMI would go next, and then Astroscale could sort of carry us through the end and round it out with the stuff that they're doing on orbit to demonstrate space or space to be removable. Okay. Space.
Awesome. I don't know if Michael's got any words for us before we transition, but Gary, great coverage. And I always forget about how wonderful it is hearing Newman thrusters say their own name. Their accent's way better at it.
Neumann. I asked him about that afterwards because I'm like, oh man, have I been pronouncing it wrong this whole time? And he's like, nah, mate, people say it different ways. And, it's like, all right, I'm just going to keep saying it. That's what it looks like. But anyway.
No, Troy, go ahead and take it away. I'm enjoying this so far. Most of what Gary had to show was not new to me. That's why I brought him in the first place. But you two are brand new to me, so I'm all ears. I had to step away for 2 minutes to go pay the darn parking meters because they're very vigilant around here. But so I missed a few minutes of his talk, but I didn't want to miss either yours or Krystal's stuff. So jump in, take it away.
Yeah, we appreciate it. Are you seeing my screen?
Yes, thank you.
Awesome, wonderful. So as has been said, I'm Troy Morris, one of the co-founders and director of operations. And again, just so appreciative for you guys having Call Morris Inc. here. Our focus is keeping space clear for all. So we established back in 2019, again, Marquette, Michigan. It's wonderful to find on a map, even better to visit. But I'm joined with two wonderful co-founders, Austin, who's in charge of engineering, and Adam, who's developed a lot of our technology. But like I've said, we're an orbital debris research and solution development company. Kind of pictured in the middle is a sneak peek of what we are working on and the target that we're going to be chasing. But first, I always like addressing the problem. And Gary did a great job of showing us at a thousands of kilometer view, but I want to bring it down to the individual person. That 30 times before breakfast, the average American is utilizing space. So Amy, for example, here, she's from a Midwestern town living in the big city, uses GPS to get to work, internet, check your email, phone to keep up with friends. And even if you just have a small, oh, can you hear me now? You're not having a great day. Well, space debris is threatening all of that communication and more, all that weather prediction, all that ability to navigate our modern world, and it would leave us disconnected. Looking at the number side of it, it's not just personal, but it's for the economy and it's physics. In 2020, we saw billions of dollars of revenue that are directly tied to the space economy and satellite services alone. On the physics side, that doesn't care anything about our economy, is the math that an object that is 1 to 1250 mass ratio, a small bolt can take out a larger craft. We've actually done the math of I believe it was a grapefruit versus a Jeep would be at orbital speeds absolutely decimated. And that's, oh, the cantaloupe's right there on the screen for me. So it's something that just our minds struggle to wrap our head around. And that's why we use numbers and graphs. So we're seeing the launches over time from Sputnik back in the first to the fragmentation events where not a Jeep and a cantaloupe, but a missing piece, a dropped glove or a tool from a astronaut. And more often it's rockets. It's rocket bodies and their shielding and their cladding. And those are what leading to these fragmentation events. The blue, though, we have to take a bigger view of because of just how purely massive the actual objects in orbit are, with the large lion's share being debris. We are seeing launches increase over time here. We're not to 2030 yet, but the tracking is showing that both debris and launches will increase, good and bad, because that debris growth is exponential and the launches are making it more possible for us to go up there and clear this debris. So history of RPO and docking, just to give a little bit better context for those who might be unaware, it's not a new thing, but it is a challenging one. First started with some of the Gemini missions, and actually the Soviets in '67 did the first automatic docking. We then saw over the shuttle program dozens of RPO objective missions, and in 2007, DARPA and Marshall Space Flight Center did a great demonstration of some of these newer capabilities with Orbital Express. And something I am just so proud to, as a species, that we've done is the MEV-1 and 2 missions done just a few years ago. So RPO and docking is already challenging when you're communicating with the target that you're trying to dock with. We have additional difficulties with debris. These are tumbling objects with uncertain shape Is it the same size as when it launched all those decades ago? Unconfirmed surfaces. How has the aluminum cladding impacted with either other objects or just the harshness of space and that unknown physical status? Has it been remained intact, damaged, destroyed? Did it explode one of its tanks? And most of these lack the docking systems. That's the problem that we've started to rationalize and realize, is that without a docking system, a fiduciary marker, a sure attachment point, some of these legacy assets, as they've been referred to, are otherwise stuck. They're stuck in their physics and they're stuck in our way. So how do we deal with these inoperable satellites, debris fragments, and more? At KMI, we bring two solutions to the table. First being software, TumbleEye, an artificial intelligence machine learning algorithm, and then Reach, a hardware solution to actually close that final distance. So TumbleEye works by characterizing three-dimensional rotation rates on approach from a single camera, not too dissimilar from our webcams. It's then able to calculate that approach at a minimized relative velocity using some of the successful RPOD systems that we've been developing from Gemini and on forward. So TumbleEye solves for unrecognized objects. It doesn't need to be pre-fed of what the object is because sometimes it's just a best guess. Reach on the hardware side then attaches to unprepared surfaces using a few different space-tested technology. From that attachment point, and I've got a great video I'll show you here in a moment, it can actually control that object's trajectory, selectively releasing without damage or residue, and it goes through many repetitive cycles. So with Reach, we can secure to unprepared surfaces, things that were never intended to truly be grabbed on, because when you launched it in the 60s, that's never coming back. That's the future's problem. Well, that problem is here today. So for those who really like getting down to the details, I did grab this from our tech team, looking more at the convolutional neural network that makes up TumbleEye and kind of how that video frame adjustment works. So you can take an image, like there's an example one there on the right, and using simulated data sets over thousands and millions of runs to build out the system as it works itself. It's wonderful, and it's something that if offline conversations you'd like to discuss more, it's something that we're very excited about, and it leads to a lot of deep conversations when we're talking to some of our DoD contacts. But an important thing for me is that it's humans still in the loop, and TumbleEye is checking back. It does a confidence reporting function so that as much as we want to hands off and give technology all of our problems, we still want humans to be involved with the solution. We're involved with the problem, and it's something that it's important to make sure we have a full context before we go no-go. Do we maintain station keeping, or do we go and actually capture this piece of debris? That actual capture then relies on some of the technology here also from our tech team on electrostatic adhesion, gecko adhesion, and tentacle arms. They're rigid, semi-controlled structures, but a tentacle arm really puts the image into your head as to what you're going to be seeing here in a moment. But the electrostatic adhesion and gecko adhesion are components that have been tested. I think Stanford's ISS system is still on station after they did some successful testing, showing that gecko adhesion in a perpetual microgravity environment. So using these systems, using these examples, we've been able to build up and move up the TRL tree. TumbleEye was developed by Adam Call during his thesis, and in that we were able to see up to 50 revolutions per minute and 85% accuracy just from the proof of concept. Reach, which we've got a still there of the flow testing, is a little bit further along. Hardware sometimes is almost easier to mess with, but that is seeing 20 kilopascals of adhesive grip strength per each pad. And as you see along the length of it, there's many EGA pads giving it that adhesion strength in addition to the mechanical advantage of the design of the arms themselves. So here, if the video will run, there is no sound. But here you can see an example of the float test system as it's grabbing onto a simulated space object right there on a 3 degree of freedom air bearing table. So even though the system doesn't get a full mechanical wrap around that corner, you can actually see kind of that EGA pad sticking out there. It's still a secure enough attachment point that we can manipulate the target object. So when you don't have one gravity fighting you that we did in this example, you can move then in all degrees of freedom and manipulate the object. This is just a 2-arm testing, really, again, some early prototyping that we were doing there. So I always like to keep this image in case the video gives us issues, but it also helps slice down what we are seeing there. The rollout, the electrostatic, and then the gecko adhesion for that secureness, that as long as you don't have that translational shear, you're able to manipulate and move the object. And with just 2 arms, we're already able to do it in the degrees we've established and looking to expand and surround that as we move to deeper processes. So how does this actually get applied? Is we take the hardware, take the software, and use a lot of COTS systems. We don't need to reinvent the rocket. We don't need to reinvent the solar panel. New space economy is providing that for us. So we're going to take our systems and operate the debris removal spacecraft. It's something that we've also had discussions for. Let's operate the payload, because if we've decided that the launch is something we don't need to do, sometimes there's a better solution of partnering up and really getting a complete ecosystem of expertise rather than trying to go it alone. I do love this quote from Lieutenant General B. Chance Saltzman talking about characterization, kind of the forgotten child sometimes of the orbital debris situation, but really just how important it is to understand and characterize those tumbling objects to be able to begin towards a path of doing something with them. Now for those objects, this is a decent list. This was from back in OSAM in October when I was down in Huntsville, looking at what some realistic, if we were to go today, targets would be. Again, look at these launch dates, 1959 to the late 60s, 65 to the mid 70s. It wasn't something that we were truly considering. Don Kessler and the Kessler syndrome that bears his name were starting to be developed in the early papers were coming out at the end of this period. But even here, if we're picking object 733, we know where it is. We have an idea of what it looked like when, but again, it's an estimate of the mass, of the empty stage, and of some of the sizes. If it's crumpled, if the skin has sheared or paint flecked, it gives a lot of difficulty. So what do we do with it all? Obviously here today in this audience, everyone's understanding it's more of a make it and don't take it philosophy. Let's use these to repurpose, reuse, recycle, all the great things that were put in our heads as we've been growing up and making a better world. Here, let's bring above our heads. Let's make great big things using the risks that we already have and turning them into an asset for our future. So in a simplified ConOps, I'm gonna have to steal Gary's guy because his are way prettier. We've got a real view of what this is gonna be looking like. So as you go, align with the target, confirm that this legacy asset is safe to capture, capturing it, reducing the rotation, and moving it to a graveyard. And step 8 there is really where the exciting part happens here, where we'd move it off to a station, unlikely to be the ISS, as that's going to be ocean bound in just a few years, as we found out this week, but to a new station, to new ideas, to new things, and letting this debris live on as new things, whether it's the fuel, whether it's as structures, whether it's just as a simple Whipple shield, and then the craft moves on. We have to see multiple captures if we're going to anticipate any kind of return of economy scale for being able to do length of missions and extend distance of missions as time goes on. So here is a video. I think I have to do a second option to get the audio to work.
It's under the 3 dots. You can, yeah.
All right. Oh, and I have it muted. That doesn't help. So the video continues. It's not a fast process. And that's something we did want to show through the video there is I've seen gravity. I've seen Wally. I mean, I've got him over my shoulder here. And there's always these interesting speeds, but to do it carefully, the relative speed needs to be low and the actual speed from ground is quite high. And that dichotomy plays into the business model as well, is understanding what's the accepted and what can we actually do. So on the accepted is these contracts for debris removal. Government supported, tragedy of the commons, some of these phrases and terms that we've heard will matter. Thompson was saying, I'll pay by the ton if they can remove debris. And I think us, Astroscale, and quite a few others around the world were quick to knock on his door and try and cash that check. But we really see it as emergency removal, risk mitigation, and removals of opportunity. If we're moving from one paid object to another, is there a potential for something small along the way? That's where that releasability of the reach system really comes into play. On the newer side is those contracts for debris repurposing. How can we take these thousands of kilograms, even of just dumb weight, just aluminum, just material, and repurpose, reuse, recycle it? And this is where we're seeing Deanna Burt talk about this later in the same year. So with Gary as a great lead in here, I don't have to re-explain what's happening. It's exciting, and it's opportunity that wasn't there before 2017, wasn't there before some of the rideshare capabilities that we're seeing. And it's important that it's there now. So this is a paper by Kessler, Johnson, Liu, and Matney, 2010, and we've had to update the information a little bit. One, it's 12 years old. Research was great at the time. And this was showing the post-mission disposal, PMD, and active debris removal of either 2 or 5 objects, showing that with the debris at the time, 5 major objects, significant objects, like rocket bodies being removed, could steady the growth and make it to a manageable level that us humans can maintain, that we can navigate between debris. Unfortunately, that red line is real. That's the actual growth in debris from ASAT tests to accidents to just new launches. And it's something that if we were to do the same steps of 12 years ago, we could hope and dream for the same results. But we have to do, and we have to do more because we've waited. There's a great expression that I've heard a few times. The most expensive way to solve this problem is to do nothing and pay tomorrow. So it really is something that we have to move forward. I'm lucky to be joined by not just my co-founders, but also my team with Will, Bilal, Liza, experience in critical industries, in aviation, with NASA. And it's something that we're also fortunate to be pre-seed funded this last summer. So we're moving towards some opportunities that are going to extend that and move it forward. And that's what leads us to what next. I saw that someone already mentioned in the comments, Orbital Prime. It's something that is on my mind when I wake up, eat my food, and go to bed. It's a great opportunity. It really is something that we're seeing a matching to what JAXA and ESA have been pushing forth in their areas of how can we, as spacefaring nations, make a big and positive dent in our world. Partners and paths are numerous, multiple opportunities through the government, but also some through industry and insurance and operators. Confers, if you're unfamiliar, great organization that we really get a lot of this across the table conversation, because many times when you're looking out at the field of active debris companies or satellite servicing, we're not competitors, we're pioneers. We're really all working towards the ideal future that we can continue to operate in, and collaboration is what's going to keep us there. And then the repurposing part is moving advanced all the time. It really is a great set of partnerships and agreements that are going to move to some further demonstrations, if I were to say, later this decade. So there's a business case for debris removal, and we just need to pull it through. The team is growing. We do have some advisors coming on. We do have 1 or 2 opportunities as well, and pending some of those contracts that are shown on the last screen, some great engineers and analysts that we're excited to bring on as the team can grow. It's something that we are a small company. We identify that, but it's something we're excited for, is the opportunities that as this space grows, we can and bring in additional expertise to the space. So I do want to provide my contact up there, troy@callmorris.com, our website. We're on all the social medias other than TikTok, but I just want to thank everybody for their time. I think that is about my 20 minutes here that we were talking through. So Gary, thank you for giving me the opportunity to come and share with another great group here. Michael, I've already enjoyed everything I've listened to here today. So with that, I'll hand back the mic.
Yeah.
All right, I think that leaves me to present next. Let me just see if I can get my slides to share here.
And while Krystal is sharing, I did see during that video a comment by Kamil with a paper that sounds very interesting. So if you got the chance, I'm eager to hear more. I was very intrigued from just that short comment. So thank you for mentioning that.
Okay, can everybody see my slides? Did I do it right? Yeah, all right, thanks for the thumbs up. Hey, and Troy, I agree with what you were just saying, right? There's enough opportunity here in the on-orbit servicing space, in this ecosystem that's being created, that we're not competitors, we're pioneers, right? It's going to take all of us collaborating, sharing lessons learned in order to really deal with this problem that, you know, continues to grow. And so loved seeing your technology and what you guys are doing. Excited to be here again today to share a little bit more about Astroscale. And kind of like Troy, I want to start a little bit with giving some context around, you know, why we're all here. Why are all of these on-orbit servicing companies being created? You know, what Gary is doing, right? Why does on-orbit recycling matter? And so if we take a step back and if we think about our orbits as an environment, right? They're a natural resource that we really need to protect because they are finite, which sometimes is hard for people to understand because you look up in space and you think, oh my gosh, it's so huge. How could we have a trash problem in space, right? But we do, because the way in which we utilize space, you know, we need to be able to protect that. And so, you know, by and large, what happens in space actually stays in space, right? Which is, again, is why we're here talking about space sustainability and the need to protect our orbit. So jumping right in, what is space debris? So if we think about space debris, there's sort of four general, you know, buckets or categories in which we operate. You know what, can you guys see these pictures on the side here? Yeah, oh, okay, I'll minimize them. That's a little distracting. So if we think about space debris in four different ways, number one, defunct satellites. So satellites that are no longer operational. And since Sputnik launched in '57, we've had about 12,000 satellites that have launched into space. About 5,000 of those are functional, right? So we have a lot of dead satellites that are no longer providing any sort of space-based capabilities that are still orbiting, so posing great risk to those satellites that are operational. If we think about number two, upper stage rocket bodies. Upper stage rocket bodies, we've had that since '57, we've had more than 6,000 rockets that have launched. A great number of those remain on orbit. The question was brought up in the chat, right? Is it concerning the SpaceX rocket booster that's going to collide with the moon? What's concerning there is that that rocket was launched in 2015 and we didn't know it was going to collide into the moon, right? So while, like it was mentioned here, you know, the damage it's going to cause is not really concerning. What's concerning, again, is the greater debris problem, right? And it's an opportunity for us to focus on debris on on-orbit servicing so that we can get better, we can clean up our orbits so we don't have these risks in front of us that will limit all of the great innovation that's happening on orbit right now. Another piece of debris that we watch for is objects that have been released during normal operations. So there was a spacewalk, I don't know, in 2008 or 2009, where an entire tool bag, right, was released in space. And when you think about it, even small chips of paint traveling at 17,000 miles an hour pose a great risk. A robotic arm on the ISS just last year was damaged. It wasn't from a piece of debris, I believe it was from a meteor, but in any case, something really, really small can cause great damage, again, to these operational satellites that we depend on for our services. And so we want to make sure we keep our orbital environments clean. And the fourth piece of debris that, large pieces of debris, are on-orbit fragmentations. In March of 2001 or 2021, so just last year, the 18th Space Control Squadron, which tracks breakup events on orbit, they tweeted out 2 separate breakup events in less than a week, and they were tracking 43 new pieces of debris on orbit. So all of this, you know, if any one of these individually, okay, maybe they're manageable, but when you think about the whole orbital environment and all of these things are impacting debris and creating more debris, right? You think about the Kessler syndrome that Troy mentioned. That's a problem, and that's why we're so focused on debris. Why should we care about debris? Again, Troy gave a really great overview because space-based technology impacts our everyday lives, right? Everything we've become accustomed to in our modern world is impacted somehow through a space-based service. And in addition to all of these services that we've come to know and love, there's also an economic impact. By 2040, the global space economy is projected to reach $1 trillion. That's $1 trillion of innovation. That's job creation, right? That's a lot of money that that is being infused into this space, to the space industry. And so we want to be able to protect that. I want to keep my job being able to communicate all the cool innovations that are happening in space. And I want my children to be able to grow up, you know, and if they choose to have a career in space, they can do so. And so protecting our environment, again, isn't just protecting our services, but it's protecting our livelihood. And it's opening up new space in STEM fields, which I think is so cool. So we talked about it already, right? Our orbits are unstable, and these are orbits both in the LEO and the GEO orbit, right? You hear those two orbits talked a lot more than MEO, because those are the two orbits that are utilized most for these space-based services that we come to love, things like internet, our telecommunications, our satellite TVs, things like that. So again, there's millions, literally millions of pieces of debris orbiting in these environments right now that pose risk. And there's more that are going to be launched. According to Aerospace Corp, by 2030, 46,000 new active satellites are expected to be launched, right? So we are going to exponentially see this increase in the utilization of particularly the low Earth orbit. And again, the risk there is the risk to the operational satellites we depend on, the risk to space tourism, right? We're seeing an increase in launches, right? People that want to go to space, and eventually the cost will come down. And, you know, you might be able to book a ticket to LEO just like you book a ticket from Denver to California. And you're not going to want to book that ticket if you're afraid of being hit by debris constantly, right? And so, again, this is all a part of the why all of this matters. And so Major General Deanna Burt, she recently said, we need to pick up debris. We need trash trucks. We need things to make debris go away. I think there is a use case for industry to go after that as a service-based opportunity. And that's a little bit about what Astroscale is doing, right? We looking at debris, at on-orbit servicing in general as an opportunity. And the United States government is taking some critical step forward. The Orbital Prime proposal, or the program that SpaceWorks has launched, is one great step they're making. But since this is a global problem that's going to require a global solution, we're also seeing other international agencies step forward. ESA, the UK Space Agency, JAXA have all committed to orbital debris programs to address this growing problem. Geez, I need to take a drink. And the United States is finally, you know, stepping up too, which we're so excited about. Talking about the UK, we have an office in the UK. That's where we operate our mission operations from. And just this past Monday, Prince Charles actually came to visit our operations center to learn a little bit more about the debris problem, about space sustainability, and what we can do to help. And so that was a lot of fun to be able to host, he and his team. So when we think about the orbital environment, you know, if you think about the culture around sustainability and the way we've been operating, it's sort of been what we like to think of as this throwaway culture. You launch it and you leave it there, right? So, you know, you launch your satellites, you build your constellations, and you leave it there. There's this sort of 25-year rule that's an honor system, right? After 25 years, a spacecraft in LEO is required to deorbit, but there's not really a governing agency. There's not a body. There's no one really to hold operators accountable for this removal. And so we want to shift that mindset from this throwaway culture into being one of a servicing culture, right? Where we're doing just what you saw towards the end of Troy's presentation, thinking about, you know, in elementary school, recycle, reduce, reuse, right? And we're sort of closing this loop in order to keep our orbital environments sustainable so that we can utilize them for future. So this is exactly why Astroscale was founded. So we were founded by Nobu Okada. He's in Tokyo at our headquarters. And he had this vision, right, many, many years ago to start this company to address the debris problem. And he wants to do this for the safe and sustainable development of space for future generations. So just like we were talking about, having, you know, those coming behind us be able to have a space environment that they can explore, that can be utilized that can be innovative and unreach this full potential, we're not going to be able to unlock it if we don't secure it and if we don't make it safe. And so that's really what we're focused on here at Astroscale. We're a global company. We have offices in 5 countries. Like I said, Denver is the headquarters for our US region. Then we also have offices in Singapore, in Israel. That Astroscale Israel is a subsidiary of the US team. We have our office in the UK, which again is where our mission operations is out of. And then Astroscale Japan is the headquarters for Astroscale, and that's also where our corporate leadership team is as well. So we've got over 200 team members and we continue to grow. We've raised over 300 million in capital, and we continue to receive numerous awards and recognition for the technology and the other opportunities, that we're moving forward and again, sort of changing that mindset in this on-orbit servicing ecosystem. So we're the only company solely dedicated to on-orbit servicing across all orbits. So we're not just focused on the LEO environment. We actually offer on-orbit services across, including Cislunar. So we're looking at, okay, how can we be better on orbit across all orbits? And I'll talk to you a little bit more about that technology in a second. So how are we going to do that? One of the things that really attracted me to Astroscale actually is our approach to space sustainability. We don't just look at it from a technology perspective. We actually look at it in three pillars, right? So we've got the technology. We also look at it from a policy, regulation, international standards perspective, and then the economics of space, right? How do we actually make this a business opportunity for operators so that they want to adapt more sustainable practices early on in their designs, when they're building their spacecraft, when they're planning their missions. And so we look at space sustainability in those 3 ways. And when it comes to our technology, we have 4 different what we call mission lines as part of addressing sustainability. And so we have what's called end of life service. So we actually have a spacecraft on orbit right now. It was launched last year. It's called ELSA-D. And what this is demonstrating right now is the ability to capture and remove a piece of debris. So this would be a piece of what we would call prepared debris. So think about, we have a contract with OneWeb right now where we're going to be integrating our docking plate onto their spacecraft so that when a spacecraft in their constellation is no longer operable, we can send our servicing spacecraft to the client spacecraft, we can attach to it, and then we can bring it down into, it's in LEO, but we can bring it down into a space in LEO where it can actually safely be deorbited, and then we would go back into LEO and then service additional spacecraft. So that's one way we're addressing debris, particularly in LEO. Another way we're doing that is what we call ADR, or active debris removal. You heard Troy talk about his ADR solution. So this is for existing debris that hasn't been prepared, right? So if you think about these large rocket bodies that I mentioned earlier, there's a lot of these very large, school bus size pieces of debris that are orbiting in LEO, and we are building the servicing capability to remove them. And so we actually have a contract with JAXA right now. Phase 1 will be to inspect the piece of debris. And then phase 2, when they open that up, will actually be a bid to remove the piece of debris. So we've been awarded phase 1, and very soon we'll be launching the spacecraft to be able to inspect that large piece of, that large rocket. Another mission line for us is what we call in situ SSA, or just SSA as it's probably most widely known in industry. And so that's our ability to inspect, right? So we know there's a lot of objects in space. We have a good understanding of that. What we don't have is the ability to really inspect that, to understand where it is, to be able to project where it's going to go. And so we are a leader in that technology, and we offer that as part of our mission. And then another piece of technology we offer is what we call our life extension service. So our life extension service right now is really focused in the geo orbit. And so these are capabilities to move a spacecraft, a defunct spacecraft in geo, into what's called the graveyard orbit. It's an opportunity to inspect. There's a full suite of capabilities we offer in geo. And actually just this month, we signed a contract with OrbitFab, who are building gas stations in space, where we're their first customer that we've agreed to refuel our Lexi spacecraft in the geo orbit, which will be able to extend our mission life so we can service more spacecraft in LEO. And so just like Troy was showing, there's a lot of opportunity. There's a lot of opportunity in on-orbit servicing. There's a lot of opportunity to clean up space. And Astroscale is really excited to be a part of this ecosystem, right? And to be working across industry to collaborate to address this, really truly global problem. If we have a bad day in space, it's not just a bad day that's going to affect, one country or one region. That's a unique thing about space, right? If we have a bad day in space, we're all impacted. And so we want to do what we can, be a part of this ecosystem to prevent that from happening. And so there's my contact info. If you have any questions or you just would generally like to connect, please do reach out. We're also on Twitter, and you can find me on LinkedIn as well. So I hope that presentation was helpful.
Thanks, Krystal. It was great.
Wow, fascinating, y'all. I mean, what this really shows, and what I want everybody to understand, is that this is an ecosystem. No one organization, regardless of how big or how well funded, whether it's government or commercial, no one organization can tackle all of this stuff all at once. That these systems are interconnected, they're all dependent upon each other. When I first started doing these events about 1.5 years ago, the common theme was, who are the customers, right? Who are the customers, and who's going to buy the service that you're selling? Well, 18 months later, there are real checks transferring from one bank account to another bank account for services that are going to happen on orbit. From the 15-year-old kid in me that was reading all the crazy science fiction to the evolution of where we are today, it's boggling. It fills me with hope. It fills me with ambition for the future. So hats off to y'all for your role in the ecosystem. Thanks. I think it's really super important. Let's do some reality checks. So we've got about 45 minutes. So this is more conversational. Space is evolving very, very quickly. Yay, I'm very happy about that. I'm really interested in kind of what happens next. So y'all lay a foundation, you build your systems, identify space junk, go out and grab some space junk, bring it back, let Gary melt down space junk into something and turn it into something good. Where do you think we're going to be? I always use 3 markers: 2025, 2030, and 2035. So take what we really know about the next 3 years, make some good guesses about 5 years after that, and take some wild guesses for 5 years after that. So who wants to start here?
I can start. I mean, we're sort of building our whole plan off of the idea that many of these capabilities are going to start to become viable in the middle of the decade. So around 2025, right? That's when we can start to field a commercial, full value chain for space debris recycling. It also happens to be the same time that is planned for the Starlink constellation to start having their 5-year lifespan reaching that deorbit phase. So that's just, it's not like we have a contract with a SpaceX or anything yet, but it's one big constellation that's actually put, a couple thousand satellites in orbit. And, they're going to be going down every 5 years is the idea. And those, if we do this at scale, we can feasibly remove all of them and divert that mass from the atmosphere and use it in space. Requires a fleet of ADR spacecraft, a couple hundred, and a few, at least probably 6 or 7 stations, in the right orbits, but it's doable. And so, that I see a potential to start building that out and actually start fielding that in 2025.
And that's one constellation.
That's just one constellation, right?
Kuiper, and you've got OneWeb like on their heels, right?
And actually, that those numbers, the couple hundred ADR is for 12,000 satellites, but they want to do 42,000. So you can take that 12,000 and scale it up, right? But I think 2025 we start to see this commercial ecosystem actually emerging. I'm not sure what they're saying for the commercial LEO destination space stations, but I think it's probably a little bit after that is what I've heard. But those are going to start to becoming something. Then we still have the space ISS at that point too, so they're going to be a little bit of competition, I suppose. And then 2030, I would actually like to see the capability to exist so that we don't have to drop the ISS in the ocean and instead recycle the ISS. We've got, how many tons of material is it? Is it 400 tons of material that's in the ISS, something like that? So, some of it's not valuable, right? But like there's a lot of metal there. We can certainly take that. I've talked to people in other companies that are building space stations, and they would love to take parts of that as well that are still functional or could be useful. So yeah, I think we'll have the commercial LEO destinations fully functional at that point. We'll have the capability, if we want to recycle that stuff, and this will be spreading out to the moon at that point too. I think at that point you see probably a small outpost on the lunar surface. It all depends on how competition drives things, but small to maybe larger, but at least a few 10, 20 people at the lunar surface, and a pretty steady flow of transportation infrastructure that goes there and back. And then out at 35, it's sort of the sky's the limit at that point, a little bit, or not the limit, I guess. Okay. I think for us anyway, I would like to see our systems, all over the place in LEO, GEO, at L1, possibly recycling or processing materials to build, large interplanetary spaceships. There's a lot of things that could happen by 2035 if it really starts to accelerate in a commercial way. It's a bit like in 1995, did you know where the internet was going to be in, 2025? Or I guess, what would that be? That would be just 2005. So, or maybe 2010 even, right? It can accelerate at an exponential rate. And I think that's the thing that's missing from a lot of people's assumptions around when we can get there. When you see projections for, having people, when they're going to hit the lunar surface or a Martian surface, or when we're going to have these, broad capabilities in low Earth orbit, it's mostly a linear thought process. But once these things break, they can easily break exponential and in a good way. And so that's how I look at it.
I'm really counting on that. I'm going to segue, Gary, to Krystal. Kamil in the chat asked a question that Gary might have just said something heretical about. He's asking, and given Gary's just comment, like Kamil asked this question, Dr. Muzyka asked this question a little while ago while you were giving your presentation, but will there be a space heritage system, meaning that some objects would be treated as trash to be collected, but some might be memorial and be preserved? Apollo objects, remains of major firsts from other cultures. So Gary's like, hey, let's just melt the ISS into slag. Like he said that about.
You can make it a museum if you want to. That's right.
So, but seriously, like it's a real question, right? So what is slag to one person might be cultural heritage to somebody else. So has any of that come up in your idea calculus here? Yeah, any of y'all? But this was especially to Krystal first.
Yeah, well, Kamil, thank you for asking that question. And it is something that's been brought about, right? And I think, a part of what's so cool about what's happening in the space industry right now and all these innovations and all this evolution is we're able to ask ourselves questions like this that we couldn't before, because before we couldn't bring down a piece of, an old satellite or a defunct satellite or something we wanted to preserve. That wasn't an option. And right now what we're doing is we're giving ourselves options to think about things we've never thought about possible before, right? And so, to your question, what could that mean? Could that mean orbital museums, right? We're talking about people living in space, visiting space, right? If they're going to have a space hotel, why don't they have space artifacts that they can visit while they're in the space hotel, right? So I don't know the answer to that question, but I do know that's a great question to ask, and we're going to see where the industry takes us and where things like on-orbit servicing, how they can lead us there. But I think it's the right question to ask, right? What do we want to preserve and how can we do that? And that's something industry really needs to be thinking about, the sort of the ethics and the morals behind some of what we're doing too. Yeah.
I could also just quickly point out that on the moon, For All Moonkind is promoting just such a program for lunar heritage. I'm sorry. Troy, I didn't know if you were going to make that point too, but
no, not that one. And I'm glad you make mention of it, because exactly like Krystal just said, is that some of these artifacts are so important. And like we've just this week seen with the ISS, you don't really know it until it's scheduled for destruction. And that's suddenly where people come out of the woodwork of, no, save this old building. Save this. And that's great, but way too often it's too late. And so it's something that one of my favorite objects is Vanguard 1, the oldest human-made object still in orbit. And thankfully, it's not relatively large. Now, is it right to remove it from orbit? That's a whole ethics discussion to go for historians far beyond myself. But it's something of, there is technology now. There's a company out of California that has finally gone out of stealth that, we've had discussions of, if we could, does it go to the Smithsonian or is it better to leave it in space? And there's other objects. Yeah, we're probably not going to bring the whole ISS and put it in, the Johnson Space Center, but Canadarm2, with the hole in it and everything, it alone has had done some great opportunities. The Bishop Airlock, there's sometimes these small components that you don't bring up the entire shipwreck. You save the bell. You don't bring some of these entire components. You have these artifacts to show, yes, we're human and they were too, and so will the future. And I think it's really important. So I'm glad that the discussion's happening here. It needs to continue to happen as things develop, as we've all seen our neighborhoods or areas where for the sake of progress, they steamroll the ancient history. They roll over the Colosseum to put in a new highway. We need to be careful of our history as we move towards the future. But I do want to return to the original question that Michael had there for the 25, the 30, and the 35. I think Gary hit the nail so squarely on the head. There's not much to add. For mid-decade demonstrations, we are going to see things that would have knocked the socks off us in 2015. And that's just a few years away. So it really is something, like has been said, just such a radical change. Our prediction, 2030, we're really seeing those commercial LEO destinations and developments thereon. I don't need to quote how many few years it was from the Wright brothers to the moon landing of it's not a linear projection. Things are accelerating at an amazing rate that everyone's like, okay, we'll have, oh my gosh, we could have a few space stations. China's been well at work on theirs. It really is something that by 2030, it's going to be a whole new world. And I've got to build more Lego figures to go with it. I've got a whole display. It looks like Michael's got some of his background. So I'm sure the toy companies are happy as well. For the 2035, I think that's really an exciting period of just so far beyond, but it's going to be habitation on the moon. It's going to be maybe not permanent colonies, because breathing is nice and full gravity is a good thing for your bones. But it's something that we're going to see some persistent bases. We're going to see cislunar trade, whether it's the hydrogen-3, whether it's a number of materials, or just for the wow of you can go to another planet for a period of time. I've honestly been surprised at how many billionaires and tech moguls go to the ISS just to be there. And the moon and those footsteps are something many leagues beyond it. So I'm excited to also watch this video in a few years and see how close I was. But those are kind of where my thoughts are, and where our discussions when after the end of the work week, guys, what's going to happen in a few years? That's kind of where our ideas kind of go. Is we want to be sipping our hot cocoa, looking at the moon and on the moon.
Yeah, absolutely. Krystal, do you want to throw any predictions in for 2025, 2030, and 2035?
Yeah, I'll start backwards though, if you don't mind, since we've heard everybody. So I'll start by 2035. So what gets me really excited about 2035 is the accessibility of space, right? So everybody, everybody thinks space is cool. You walk down the street, everybody's wearing a NASA shirt, right? And everybody's fascinated with space.
That's new though, right?
It is new. It is new, right? I agree. And what I want to see is more of that. I want space to become such a part of our routine lives, where people understand how we're using space services, that it's accessible to everybody. And it's not just looked up as this far-reaching thing nobody can touch, but it's actually a part of their everyday lives. And that's where I think by 2035, what I would love to see is space sustainability being driven by consumer responsibility. So just like consumers have driven sustainability in, plastics and some of these other consumer-driven products we know and love, I am excited because I think by 2035, we'll see some of those similar consumer-based behaviors driving sustainability change. So when we think about internet technology, right? And we were talking about Kuiper, Facebook, SpaceX, right? They're all building these mega constellations to make it internet accessible to everyone. Well, let's challenge those companies to be sustainable in their practices. And, I'd love to see a system where you're choosing your internet provider and you've got the sustainability data right in front of you. So you pick your internet service provider based on their sustainable practices, right? And that's when we can hold, again, industry accountable for things like that. I think that's going to be really critical to driving change. So that really excites me because space has never been a consumer industry, right? People like space, they think it's cool, but they can't really buy a service from space, but they can. Now the way the industry is evolving. And so I think that's really cool. And then kind of to Kamil's point, thinking about, particularly recycling, bringing down large orbits in space, or large pieces of spacecraft. I'm excited for, again, the accessibility part. Like what does that look like on Earth? I think of Chihuly exhibits, right? And these big, beautiful glass structures that are all over the world that you go see and people are fascinated with. Let's do that with metal, with space metal, right? Let's have these museums on Earth that are full of these amazing displays that are awe-inspiring, that are inspirational, again, so more people are excited to enter the STEM field. So that's my sort of 2035. By 2030, I'd love to see all satellites prepared for proper removal. So we've shifted from sort of talking about the problem and talking about the solution to actually driving that change. And then I agree with what Gary said. By 2025, we're going to see some real on-orbit servicing, routine on-orbit servicing happening. So I think that's really the first step. And then hopefully that will lead to more sustainable practices.
That's very cool. That's very cool. I like the progression. By the way, shout out to my town. Dale Chihuly's foundry is about a mile to the left of me in downtown.
Cool.
Yeah, so I was really surprised to hear that name thrown out. He has spawned an entire ecosystem of glass artisans. So we're pretty fortunate here in the city. We have a tremendous, it sounds super boring, but the glass museum is super cool. And it's just filled with that kind of stuff. So I love the idea of taking that concept that's beautiful in art and taking it into the sky and doing something that's just kind of transformative just from the pure art perspective of it. I don't think we talk enough about that. I'd also like to see a ballet done in 0G or on the moon at 16G. Like those are the kinds of things I think would make a difference to the world, right? I think that that makes it a consumer accessible Whereas for a lot of folks, NASA was kind of like this, you had to be the super nerd, and if I'm not good at math, I can't do anything, right? Like it was never available to people, and it is available to people that can work in this field. It's an amazing field.
And not only is it available, but the more we use space and the more we move people out to space and we start settling places beyond Earth, the more all of those activities across the economic and social spectrum are going to be required, because where people go, they're going to need the same services they use here. So it really is going to encompass. That's definitely something that I kind of took from going through the ISU program. That's something that they talk about a lot, but it's now you can start to see it actually happening to some extent, I think. So I definitely think that's only going to get more. The other thing that I think, you're probably going to get to this anyway, but the space accessibility could hinge quite significantly on the success of Starship or not. If that works out the way it's promoted to, that changes all that stuff. I mean, even trips to the moon on a per kilogram basis become like orders of magnitude less than the prices the commercial operators want people to pay right now. So that could really change the game. But
we talked earlier today about a report that the Industrial Space report that came out in November. As a personal part of pride on my part, I was cited in that thing for the phrase Starship Singularity, that everything changes. Everything changes once that spacecraft is in place, and that's not the only one, right? It's not the only one. There are other things coming, but wow, does the world change pretty dramatically once that happens?
It's kind of similar to the smartphone movement. We all know who was kind of the flagship of it, but they weren't alone, and it's completely changed our world. Of look at the services that no one could even imagine. Uber. What do you mean you use your phone to order a ride? Like that's just calling a taxi, Troy. What are you talking about? Yeah. So it's something that I agree with you, and I love that phrase, the singularity. But I also like to Gary's point a few minutes ago where he was talking about us going to other places. I think that foundation is, and something I'd like to discuss, is space is cool again. And it hasn't been that way for a long while. I'm on the younger side of my career here, and it's something that, the shuttle program was exciting, but I felt like the only darn kid in the classroom who wanted to watch a launch. And now it's something that, we're coming up on another reunion, and I have 3 or 4 friends who are like, cool, I want an hour for you to explain space and just tell me everything because you work in space. Like, wait a second, you bullied me like years ago. It is something that space is cool. It's in the video games. It's in the second movie, not Don't Look Up, but there's a moonshot one. It's in our culture. And I mean, watch a football game, the Super Bowl. I'm guessing there's going to be 4 or 5 different ads that even just reference it. There's a car commercial, don't know which one, where they show space, and they're like, ours isn't that hard, but that they're trying to borrow the star power of space. And I think it's something really exciting to be in this industry, be part of this movement. But it's also something that got some of the developments we've seen is that groundswell of interest that turned into NASA, that turned into the ISS. So it's something we have to foster and not turn our noses to, but water it. These are the STEM students of tomorrow, and also the voters that support the policies from government. So that space is cool again, and I kind of wanted to hear if other people have a perspective on that as well.
I remember, so I was 27, 28 when the internet first happened, right? So this would have been 1995, 96, 97. And I had a small internet company. And I would just go to cafes and coffee shops, and I'd hear people, and they like pull out a card because they couldn't remember it, and they'd be like, http:// blah blah blah.com. And I was like, and they were just trying to wrap their brain around this new digital communications technology. And 1997, it was crazy. I mean, you were still getting AOL discs in the mail and magazines, right? And we're there now, right? We're there now. I never in my life was one of the cool kids, but being in space, I'm having the same reactions. People are like, wow, can you tell me about that? In the office building I'm here in downtown Tacoma, I'm known as the space guy or the moon guy, right? They don't know my name. Nobody knows my name, but I'm the space guy. I'm the moon guy. And so I think I wear that kind of as a badge of honor. Let's bring this back to something like really specific on space stations, right? Like that's where we're going. I think humanity has proven that we're really, really good at rocketry at this point. A launch basically every other day somewhere in the world.
You don't even pay attention anymore.
No, right. I'm still.
I mean, maybe we do, but like, oh, another rocket landed. Oh, big deal.
What? I don't care about launches, but I still go out of my way to watch landings.
Oh, yeah.
That is dumbfounding to me, right? That one, I'm still having a hard time with that, right? That's amazing. Rocket launch, sure, that's cool, but landing, that's a different animal. So we're getting to the point where earlier this morning I talked about this grand architecture. So we start with launch. We get good at launch. We get good at satellites, communications, and Earth observation. So that's like the first checkbox, right? The second checkbox is space tugs, orbital transportation, being able to maneuver in this newfound environment. So that's like stage 2. And all of y'all are kind of in that box, right? You're not worried about launch. You're not worried about satellites, right? You're worried about, step number 2. And then step number 3 is stations, right? Building stations. So I look at y'all as necessary precursors to having a cislunar iconosphere that actually functions. It's not all about upmass. It's about operationally on orbit, operations on orbit. And I think that the stronger your team is, the more likely space stations become. And so that's kind of the theme of this. So I want to talk a bit about what your role is in that kind of next stage of the space economy, right? It's going to take a while for you to establish second stage, right? You still have work to do. I'm not discounting that. You all have work to do. But assuming that you are successful, it enables the third step. So how do you relate to space stations? I'm tracking 9 stations, 2 that are functional, 5 or 6 I consider planned, and then a few others that I think are aspirational. Whether they happen or not, it's too soon to tell. So where do you fit? What do you think your role is? How do you enable this next step in the econosphere?
Gary, go ahead. For our perspective, I actually think that we're sort of challenged that the stations come after this, because we need at least an early version of the stations to even do what we're doing. I mean, there is one configuration where we put our system on an ADR spacecraft, but really the more desirable one is where the ADR spacecraft fills up at the station, goes and gets stuff and brings it back to the station so we can process it there and store, the components while we're processing them and everything else that would be needed for doing sort of a salvage yard kind of setup. There are nascent stations that people are already talking about. Nanoracks has a great one for our application that, they've talked about publicly, which is the Outpost program and their mission extension kit. And together, those things could be a nice platform to host, ADR spacecraft, micro space foundry, and the whole operation. And that stuff is going to be, I think, ready in the middle of this decade. So that's not necessarily the next step that comes after the infrastructure is built. But maybe what you're saying is more the larger kind of like, where there's lots of tourism and all that stuff in those stations. I think that, that does kind of build out later, but the seeds of it are there already. Orbital Reef is also an interesting, the path that they're planning to take, and the way that they're sort of building the spine, and then they have the ability to attach lots of different other modules that other space station companies are building. There's a lot of paths forward that I think are viable in the near term. So I don't know how that, I might have missed part of the rest of the question, but.
Right.
No, I think you hit some good parts there. And as you were talking, Gary, kind of answered that we're talking about space stations as if it's a singular term. And it really is something that is so worlds of different, from 2001 Space Odyssey to, bringing planets to, I actually found where I have it. It's behind me, my ISS. I was like, where is it? And it's something that there's two versions. I think the one that Gary was talking about there at the end is that SEP 3 version, the one that has multiple moving parts to it. And that's something that honestly, I would see this kind of servicing craft that we're discussing here, very small part of that. They are the, not to put it lightly, but the service vehicle, the catering truck that comes to the hotel, not the one that's getting all the attention of the celebrity arriving. But I think that those services are also crucial to the operation of those types of stage 3 space stations, for whether it's removing mass, adding mass, bringing materials so that you can expand and build that next wing and gymnasium of your hotel. It's going to be essential to have our kind of services, or even just repair. The satellite goes out in a hotel now and you're on vacation, you're a little bit mad. The service goes out when you're, that's the only way you talk to home base. That's a little bit bigger of an issue. So it is something that the services that we provide, either directly to the stations or in the support of them, will allow those dream stations, as we're kind of talking. And the more immediate, I think Gary again hit it, of it really is an optimization. There are plans that you could bring everything with you like a rugged pioneer, but if you can use these outposts, if you can use these stations, these optimal places to bring material, refuel, Orbit Fab's leading the way on some of that, of use this as a center spot, refuel, and we start building off these systems. That way you don't have to bring everything with you, because that's a lot of inefficiency. So I think it's kind of both is the terrible answer, but I think we really need to start understanding in these discussions, are we talking of a simple station, a outpost, term is great, I'm glad Networks use it because it makes me think of the Old West, or are we really talking of this self-sustaining system that's up there? And I think we need to start splitting those in our discussions.
That's interesting. So, Orbital Reef, giant organization, massively funded, brand new, so we don't really know what's actually happening. I haven't, they're in Kent, so they're 40 miles away, but nobody's invited me to tour the factory floor just yet. So
they're here in Denver now too, apparently.
Yeah, they're everywhere now. Yeah, no, they've got a big footprint right now, and growing. Oh, I mean, that goes back to the conversation we had a minute ago. There are thousands of unfilled jobs in this industry, tens of thousands of unfilled jobs in this industry right now, because all of these organizations are blossoming. Yeah, that's pretty amazing. So in a way, both Gary and Troy said it was kind of a chicken and egg problem, right? That's kind of how I heard it. Like, so maybe you can put something up on the International Space Station, but maybe if we're talking about the next gen space stations, that's really where some of this stuff is going to, start to, some of the seeds planted now might bear fruit. Kind of paraphrasing there. But, Troy's like, well, we're the delivery truck, but I mean, Krystal is actually the delivery truck. Am I misunderstanding that a little bit?
So we'd be part of the mobility service, right?
Yeah.
So being able to move a spacecraft, a commercial space station, around once it's in space. So we wouldn't be a part of the delivery service like a rocket would be, if you think of them as the delivery, but we would be that in-space mobility provider. And, as we're thinking about the commercial, particularly in LEO, this thriving LEO commercial economy that's bustling with stations and, tourism and all this, all of these things we're talking about, the value someone like us at Astroscale brings, of course, is not only just the technology to provide that mobility, but it's also advising, partnering with these commercial station operators and helping them to understand, again, how early on in their designs can they bring in sustainability? How are they thinking about how they're going to protect their assets that they're launching? You think about something like Orbital Reef, the potential for what that's going to do. We're talking about scientists, we're talking about space tourism, right? We've talked a lot about that already. And how are these companies thinking about sustainable practices to protect those investments that they're making? And, that's one of the values Astroscale can bring to these companies, because we can help them think about, that whole sort of system, their whole system, and what they need to be doing early on while they're conceptualizing these things.
But Krystal, you guys would also be, you wouldn't be transporting up from Earth to the stations, but like from station to station.
That's
if I wanted to transport like a cargo, module from one station to another, I filled it up with a bunch of materials. I need someone to take it, from Starlab to Orbital Reef. Like that's what you guys and others in space transportation companies are partly, I imagine, is on the roadmap, right?
Yeah, absolutely. That goes back to that mobility piece, right? Yeah. So we're giving commercial, well, not just commercial, I shouldn't say, it's not limited to commercial, but we're giving operators an opportunity to be mobile in ways they haven't been able to do before. And like partnering with someone like OrbitFab now, they're not going to be limited by fuel constraints, right? Fuel is one of the #1 limiting factors in space right now. And so if you can refuel your spacecraft and extend the life of it, then you have a lot more options. You're unlocking all of this, again, potential. And so, someone like us then would be able to provide those services. And, something else that's an important piece of this puzzle that's starting to get a lot more traction. In fact, just 2 weeks ago, I think it was, the White House, they held, OSTP held a town hall to talk about, right, the policy side of this. How are we going to regulate it? What are we going to need to do? And Astroscale, we talk about SEM, right? This the space environmental management, right? How are we going to manage the space environment? And if you think of it like air traffic control, at airport, how are we as industry, both locally, domestically here in the US, but then working across with our international partners, going to make it so we have a good environmental management system in place so that all of these things can happen. And what I think is so cool is nobody wants to stop the utilization or limit the utilization or exploration of space. We just want to put in place the right framework so that all of us can be successful. And so I love to hear all these conversations that are happening because, again, just the possibilities are truly endless. I think it's such a fun time to be in the space industry.
There's a thing that they talk about in all the Air Force briefings and some of the NASA ones too. Certainly, like part of Orbital Prime's pitch is this desire to have maneuver without regret. And I'm thinking about, that's what Orbit Fab's propellant depots do. That's what us making metal propellant allows. Which we could sell through Orbit Fab's depots for that matter. As the gas station, right? Allow that to do. Then you can make more aggressive moves to deliver things here and there because, well, you can just fill up when you get there. So, you don't have to be as careful and precise about and take as long to get places as you would before. And that sort of opens up a lot of those channels.
Oh, go ahead, Troy.
No, just I was thinking off your idea there for just involving the world for it. The World Economic Forum and their space sustainability rating ties right back into that of just, it's wonderful to see, like you said, that this is happening all around us. It's not just in this conversation for a few hours and then everyone goes back to their Friday. It's continuous and moving. And the space sustainability rating, I haven't heard updates in a little while. I heard it did move out of MIT, and best of luck for it because it's a great system. I mean, we see with the LEED certified buildings of nothing changed. We still make buildings. We still build beautiful things. Just now people that care and the consumer can push of, well, why isn't it? Why didn't you build your brand new campus and have it platinum or mega platinum, whatever they're up to now? And it gives consumer choice and it just drives the economic factor because the policy part is great. Gary talked a few times with the White House. He did some good points there and we heard it from across industry, but we can't always rely on government to drive for us on that. Sometimes the consumer market has to keep its own force, and best is both. Both pushing, it moves us into that positive direction.
Yeah, like building on this idea, I think what I think is really exciting about this particular moment is we can take sustainable practices, if we can build in recycling and that sort of thing into this whole ecosystem. And it's not like it's not even what you were saying, where it's like, oh, there's lead and some people do it, some people don't, and there's pressure for people to do it. Actually, we can make it enable and help to enhance the business case for utilizing space. If we can make it more sustainable and make sure that the debris is not being created, and we know that we can remove objects when they stop working, and we have good space traffic management, well, actually the carrying capacity of orbits goes up, and we can actually do more in space. So in that way, these sustainable practices should drive strategically better business growth for the companies that want to utilize space. And I think that's somewhat unique in general for like environmental type of issues that tend to be driven towards the tragedy of the commons perspective. In this case, I think it really does. It could work out that way.
We need a space Smokey the Bear. Only you can prevent orbital debris, right? Like, kind of sarcasm, kind of not, right? Like, we know this is a problem. All of you referenced Don Kessler. All of you shown in different ways that this is significant. Gary turned a giant problem into a giant opportunity. I that's the thing that surprised me. That's why I've been paying attention to Cislunar Industries for such a long time. Everybody acknowledged the problem, but I didn't see anybody who actually had a solution to it. So that was a big surprise here. We're gonna start winding down here for a second. Before I let you off the hook, so earlier, Colonel Garretson was talking about how I asked the same question, 2025, 2030, and 2035, how many people would be living on orbit by 2035? I can give you a hint about what his number was, but I'd prefer not to. And then also Dr. Goswami gave us a different number. So put on your crystal, pull out your crystal ball, and take a stab at these numbers, because I'm trying to get a consensus from people in the field. And I know that y'all are not space station people. I don't think there are very many space station people in the world. But so I'm trying to get folks who have actual skin in the game, building hardware, have budgets. I'm trying to get those people who actually are coming from a point of, insider knowledge to help me get to a point to understand what our numbers are. So people on orbit, continuously living on orbit at any one time. ISS is our baseline of 6 typically. Max has been, I believe, either 11 or 13. And 3 years from now, who's going to give me a number on 3 years from now? All of you have to give me a number. Who's gonna step out in front? 3 years from now, 2025.
Well, I think just based off of your numbers there and the 9 stations that you said before, expecting 50 to 60 is not unreasonable. If stations come through as the way they do, especially if there's so much activity of building out and expanding, I think it's something that we're looking for about 50, maybe not as a continuous time, but that are regularly operating. I think that's the number that we might be honestly seeing in just that few years.
50 by which year?
2025.
2025. All right. So 50, 2025. All right.
Yeah, I think by 25, many of those stations are not yet going to be fully operational. You'll have ISS still. You'll have the Chinese station, which will have been expanded to several modules. So figure that's at least maybe upwards of 15, I guess. Maybe you've got a first crack at one of the commercial ones. I think probably by 25, you're more like in the range of 15 continuous, maybe 20. that now, it's one thing that could totally change that is if Starship works, one Starship just sitting in orbit is bigger than the entire ISS in terms of volume. So, that would be, how many people do they think they can carry into orbit with that thing? 100 at least?
100 at a time. 100 at a time.
I mean, that could change it completely, but I don't think it's going to be quite ready for prime time at that point. But.
Hashtag Starship Singularity.
So yeah, 25. I'm more in like a two functioning space stations camp for that one, I think.
Okay. So your answer is
15 to 20.
15 to 20 or 100.
or over 100. Yeah.
Way to hedge me on both sides, Gary.
Okay.
I mean, it's more likely 15 to 20, I think, by 25.
Super helpful that you're specific about things like that. Thanks. Krystal?
Okay, so I'm gonna give a little bit of a PR answer, which you might not like, but I don't think we're not necessarily going to be limited by the technology, right? We're going to be limited by our behaviors into in space, and so. With that said, I like Gary's, numbers, thinking through what's realistic within the next few years, to be able to be launched. So I don't know, maybe I'll take you said 15 to 20, maybe I'll take the 21. I'll take the one over.
Yeah, the price is right?
The price is right, so
right.
yeah.
Nice.
Okay, all right. Same question, using your logic, don't change your logic. 2030. Now things are happening. So where are we at 2030?
Do you count the moon?
Yes. Let's throw that in there because all I'm looking for is 15,000 people in the sky, wherever they are. I don't think, right.
So I'll take the prices right under 15,000 by then.
Okay. 14,995.
Yeah.
I don't think we're going to have 15,000 by 2030 or 2035, just for the record. Aspirational, but I like to think big.
Krystal goes big.
Even though my first answer there was a little bit on the large side, because one, predictions like that are way more fun if they come true.
That's true.
But second is that I don't see that the growth will be explosive from there on. I don't think we'll go from 50 to 500. I see it more as 85 because it's something that for the number of work hours it takes to support a astronaut or cosmonaut now, is that the stations and support for that, I don't know if we'll have the full ecosystem and desire. I mean, look at how many submarines the US can put out in the oceans, but there's still a cap number of, you only have so many people who agree to go into a steel can for 9 months at a time. And I think there will be a similar waning of interest, unfortunately, as it becomes mundane. It's no longer exciting. It's no longer the new frontier. It's, well, yeah, he's doing it as a work job. He's going to go work on the oil rig. It just happens to go around the moon. So I would put my number as probably 85. I think that we'll start to see a wane of interest before we can get to those third stage stations, those 15,000s, those hundreds, where it's the movies we've watched. I think we're going to see it slim down where it's just a working position.
Interesting. Okay.
So there's two parts to that. There's the people who are working in space on a continuous basis. So the people who like work in the hotel and run it. And then there's the people who are visiting. And so the question that was asked at the beginning was how many people continuously in space at any given point in time, right? That includes the tourists that are up there and the people utilizing the space, as well as the people who are working in there. So you got your oil rig worker kind of people for sure. I think by then, by 2030, I think you'll have 2 moon bases, at least. You'll have the Artemis coalition and you'll have the Russia-China coalition probably. And each one of those, I would guess they'll have 10 people each maybe. So that's 20 on the moon, perhaps, maybe more, but let's start with there. And then in orbit, I think you've got, you've got all those LEO destinations. I think you've got something like Orbital Reef has a good chance of being built out and having more, the full extension of what it wants to do. The other destinations as well. And then there's some of those other stations that I've seen are pretty interesting ideas. Like Think Orbital has a really cool one where single launch, it makes this big open sphere and you can fill it with whatever you want. But that open sphere could be like a great place, like to do a ballet performance, for example. You got this huge volume of space that you can do. They just that company SEE is going to put a spherical module on Axiom to do movie production, and that's coming in the near future. So you figure get a couple of those up there. If it only takes one launch to put something like that up, I mean, I don't know. I think if launch prices come down, which let's say plans go as expected, it's not going to cost that much to get to low Earth orbit. It's going to be more like a plane ticket. And in that case, I think there's going to be quite a lot of demand for even when it costs tens of millions, there's quite a lot of demand for people to go to space. So I think you easily have, let's see, multiple space stations. I mean, I think you're in like the 200 people range at that point. Maybe more. Maybe it's more like 1,000. I don't know. I'll give you a range again. 200 to 1,000.
Okay.
Plus 20 on the moon.
Krystal, do you want to modify your under 15,000 more specific, or is that going to do it?
I'm going to stick with that, and then we'll get together again in 2030 and see where we are.
Yes.
Awesome. All right.
Put it on the calendar. Yeah.
All right. We're running out of time. Does anybody want to give me 2035, or are we going to move on from there?
I mean, that's where you're above your 15,000 people, man.
Right.
Like easily.
Okay. Amazing. All right, y'all. Thank you so much. Thank you so much for being a part of this. It shows that there's value to be created in the cislunar iconosphere. It shows that your people are going to have somewhere to go home to, and I think your people are going to come home to our stations. So like that's a necessary part of the ecosystem. Thanks very much. You're certainly welcome to stick around and join us again tomorrow. Tomorrow's interesting. I'm going to be way out of my depth and comfort zone tomorrow. We are going to be talking about having children, having babies in space, right? If you're going to build a 15,000 person outpost, you're going to have kids, and what does that look like, and how challenging is that? So, what stages are we at with that? So that's going to be a fascinating conversation tomorrow. All of you will get invites to the Discord channels if you want to participate there. Feel free to post any links that you want to promote here. We are going to keep this chat for the future, because one, I want to get all of your numbers and compare them, when 2025 and 30 around. But sincerely, thank you, everybody who's on the screen here and everybody who's watching from the internet. Really glad you're here. This has been a fascinating first day. This is Liftport's first internal conference. We've run 16 of them for other people, but this is our first for ourselves, by ourselves. I really, really want to do a shout out to Taylor and to Fabio as my background team. This thing couldn't happen without y'all, so I really appreciate that. And with that, I'm gonna sign off. Really appreciate y'all as speakers and the folks attending from the internet. We really appreciate that, y'all.
Yep.
Thank you.
Thanks for hosting us.
Yep. Have a
Bye,
great
see you
day.
guys.
Yep.